Can you hear me? Are you able to hear me, my audio? Thanks. I'll go back on mute. I can share my screen too. Thanks.
Is it? Yeah, yeah. I mean, Nestle is from Switzerland, so yeah, no, no, it's true, yeah. But how many people are working for Nestle? 5,000. 5,000. It's not a huge company. I mean, it's big, but it's not huge. Okay. 5,000. Okay. But you're based in the Netherlands. I'm based in Amsterdam. Yeah, we have an office in Geneva, where the trading, feedstock trading sits. Okay. Feedstock trading, that sounds interesting. What are you trading with? Yeah, so we have biology feedstocks, the animal fat and everything, and then we also do oil product trading, so we do tanker stuff. Yeah. So that sits in Geneva, but unfortunately they won't let me work in Geneva. I would have preferred that. But so I used to work in Geneva before. Okay. Good morning. Hi, I'm Shakib. Mit Amsterdam at first glance, it's nice. Yeah. It's nice. It's from the Alps, and I think one of your colleagues are based in and it brings in. Okay. That also will research and financial organization. Actually, I grew up here in working in Germany, close to the border. Actually, but they share the Swiss and German. So it will come to this. Okay, okay. Thank you very much. Ja, ja, gut, das ist ja bei mir so. Das ist
So, good morning, ladies and gentlemen. I'm very happy to welcome you to day 2 of our conference. I hope you enjoyed the first day and had a restful night. Just as yesterday, let me share a few couple things of the organization remarks. The coffee breaks will be held today, same as like yesterday, in a foyer in front of the conference. For lunch, we will go to the restaurant located downstairs. During the upcoming 2 weeks, you will receive a link with all the presentations. I would like to remind you to fill the evaluation forms and hand it to me or my colleagues at the registration desk. Your feedback is very important for us, and it enables us to improve our future events and services. If you have anything you would like to discuss with us, do not hesitate to speak to me or my colleagues. Today, our chairman is Christine Dresten. Christine, the floor is yours, and that's all from me. Enjoy the conference. Thank you.
Thank you. Welcome, everyone. Welcome to the second day of the World Sustainable Aviation Forum. My name is Christine, and I'm a director for Aviation Strategic Advisory at NACO. NACO is a Dutch company based in The Hague. Maybe you know it. It stands for Netherlands Airport Consultants. Today I'll be your chairman, and before we get started, I just wanted to give you a few highlights of what we have discussed and seen yesterday. So we kicked off yesterday talking about policies and how important a regulatory framework is to implement sustainable aviation fuels. We also saw that having something quite strong already on EU level is good, but that you still need a global framework to actually make it work. We also discussed The biggest challenge regarding the different projects that are going on now regarding the production plants for sustainable aviation fuels. And what we see that there is that most of these projects are now arriving at the stage where they need financing. And the uncertainty around the mandates also make it difficult for these projects to receive their financing. So there are challenges, but it's also, I think, very positive to see that those projects are getting further and arrive at this stage. Today we will continue to discuss sustainable aviation fuels. We will also look a bit broader on topics regarding sustainable aviation. And actually we're kicking off this morning with a presentation on hydrogen and electric aviation, which will be given virtually by Anita Sengupta, who is the founder and CEO of Hydroplane. She's joining us virtually, so I think we will see her shortly on the screen.
Can you see me and hear me?
Yes, we can.
Oh, okay, great. Should I start?
Actually, we can't see you. We can hear you and we can see your presentation.
Oh, I shared it. There was many different ways that I could share. Just I could try sharing it in a different way. I'll try one more thing. Let me know if this is any better.
It's coming. Yes.
Okay.
Just
Yeah,
need the full screen and then I think we're ready to go.
Okay. Is that good?
Yes, perfect.
Okay, great. Well, thank you for having me. And I'm sorry I couldn't be there in person. I ended up getting a pretty bad cold last week, so I didn't want to infect everybody with my illness. But I do love Amsterdam, and wasn't there that long ago. I guess probably this past summer. So I'm going to be talking to you this morning about my company, Hydroplane. We're actually based in Los Angeles, California, in the desert of Los Angeles, California, and the whole origin story for the company was to decarbonize aviation using electric propulsion, but powered by hydrogen fuel cell technology. So ultimately, that can lead you to renewable energy with zero emissions. So I think everybody there already knows the source of the problem is that global energy consumption is increasing and renewables are needed to reduce emissions as well as to meet energy demands globally. One of my other roles is on the United Nations Council of Engineers for the Energy Transition, or the Green Energy Transition Task Force. So we just had a call this morning, or I guess it must have been yesterday, your time, sort of talking about the path forward and that energy, whether it's being used for transport or for energy storage, for ground use, industrial use, it's all the same problem at the end of the day. And in the context of aviation, obviously, as human population grows, as commerce increases, aviation carbon footprint will be on the rise, and it is expected to be a primary contributor by 2050, hence the topic of this conference and many topics, conferences around the world. So our focus as a company is hydrogen fuel cell technology for energy storage, for electric propulsion, as well as for mobile energy transport, and that utilizes green hydrogen in order for it to be emission free. And the good news is that green hydrogen production is very synergistic with renewable energy production. So green hydrogen comes from electrolysis, where the electricity of the electrolysis is provided either by solar or by wind. Then electrolyzers are used to produce the hydrogen in this green way, and then it can be used by a variety of different end users, which could be aviation, maritime, chemical manufacturing, or automotive sector, for example. So it's synergistic in terms of energy production as well as green energy use and zero emissions. And similarly, electric aviation can also be synergistic and evolutionary. So ultimately, you want to start with the smallest platforms first, electrify them, get them working, and then improve the technology to make it more efficient, to enable larger aircraft, which gives you more payload and more range. And so we're actually starting off with smaller aircraft, single engine aircraft, multi-engine aircraft, helicopters, all propeller driven for the use cases that we're looking at. So my background actually is from the space program. I spent the majority of my career working as a electric propulsion technologist for NASA's Jet Propulsion Laboratory. And the irony is many technologies that we use in the commercial sector actually do have their origin story from the space program. And proton exchange membrane fuel cells were actually developed for the space program as energy storage for the human space program, including Apollo, Gemini, and the space shuttle. So uh, most technologies which are developed for the space program are developed with energy efficiency, lightweight, compact in mind. And so it actually translates pretty well when you look at it for a vehicle energy storage technology. And then ironically, fuel cells are not some kind of newfangled technology. They've been around. They've been around since the 1960s, and they are commercially available in the automotive sector today. I drive a fuel cell car myself. This is my Toyota Mirai. There's a variety of different cars that you can buy in California, and I think you also have a similar infrastructure set up in Europe. So it's great to see synergy with this technology from the automotive sector, and of course, we're focused on transitioning it into the aviation sector. So for our approach to zero emission aviation is to have electric propulsion, and the electric propulsion is powered by hydrogen fuel cell technology. We actually have a 100% hydrogen fuel cell powered aircraft, which is a single engine Piper aircraft, and it doesn't actually use any lithium ion batteries whatsoever. It has its traditional 12-volt bus, which is just with a lead acid battery, but all energy for primary power and auxiliary power comes from a hydrogen fuel cell inside of the aircraft. And so the benefits of this, of course, is it's carbon emission free. The output of the reaction is liquid water. It has a significantly reduced noise signature because you no longer have a piston or a turbine. And ultimately, because of the fuel cell technology, it results in lower maintenance costs and lower operations costs, which is great for the aviation sector when you think about it from an operational perspective. So I won't spend too much time on talking about how hydrogen fuel cells work, but they are essentially a passive system. What you have on board is hydrogen gas, H2, which is split up, dissociated into hydrogen ions. Those hydrogen ions pass through a membrane, which is an electrolyte, which then combines with oxygen from the air. So it's an air breathing system. And in this process, the release of electrons is where you get your electricity. And the only output from this reaction is liquid water. This happens at a relatively low temperature. Maximum temperature is around 70 degrees C, and also at a relatively low pressure, 1 to 2 atmospheres. And what this means is, from a engineering perspective, it means that the system lasts for a really, really long time. You can get better time between overhaul and significantly reduce maintenance costs because there's essentially no moving parts associated with it. So the audio wasn't working before, so I won't play our short video. But in terms of who we are as a company, we're a relatively young company. We were founded in 2020 by me. Most of us do come from the space program, so our backgrounds is from Boeing, Virgin, SpaceX, Blue Origin, and then of course NASA. And so we're translating a lot of our hydrogen expertise from our NASA work into the aviation sector now. So we see multiple aviation use cases for hydrogen fuel cell electric propulsion for aircraft. It could be for a traditional aircraft, which you can see above, like a Cessna Caravan. It could also be used for helicopters, rotorcraft propulsion. It can be used for UAS, UAV propulsion. It can be used for eVTOL systems. And it can also be used on the ground for ground-powered airports or for auxiliary power on board larger jet aircraft. I will point out that our focus is not on electric jet aircraft because the PEM fuel cell technology is probably not a good fit for that. Our focus is on propeller-driven aircraft. And ultimately, it does couple to the green hydrogen production, which is going on, I think, throughout Europe now, which is a great solution for that. So the primary advantage of hydrogen fuel cell electric propulsion versus battery electric propulsion is that hydrogen has a very high specific energy. So the most efficient launch vehicle out there is one which operates on liquid hydrogen and liquid oxygen, and that's because of the amount of energy per unit mass that you get from hydrogen. The challenge, of course, is how you store it. For aerospace applications, it typically is stored in a liquid form, which is compressed and obviously very cold. And for an aircraft, you also do want to store it in a liquid form. For automotive, you can go gaseous and liquid, and for maritime, you could go gaseous or liquid. But ultimately, hydrogen has 3 times the energy density of hydrocarbons and over 10 times the energy density of lithium-ion batteries. So what that means from an aircraft perspective is that you can get the same volume, the same payload, and the same range as a combustion engine type of system, which of course is the desirable solution for any new technology, is that it gives you the same capability that you currently have, and hopefully better in the case of being an emission-free and operationally lower cost. So we do have two products that we have developed. One is a power plant for use on single engine aircraft and rotorcraft. It's modular. It can go up to 500 kilowatts. We have it integrated into our aircraft now. It basically just took the place of the pre-existing engine. And we started small, but we made it modular so we can go with larger platforms. Um, and it is a different approach to aviation when you're using electric propulsion, in the sense that you now have a liquid cooling loop. You've got power electronics. You have a hydrogen feed system. You have a thermal management system that you wouldn't normally have, but that's what we developed. It's a product. We actually did this under a contract with the U.S. Air Force, and to develop our prototype, and obviously now we want to commercialize it going forward for aircraft across the world. Obviously we're based in the United States, but we think European aviation sector is a really interesting use case for that. And we are a small company, all engineers. We did develop everything ourselves and integrated into the aircraft ourselves. So we kind of have optimized the system from a weight and balance perspective as well. We have a second product that we're developing, which is also coupled to the aviation sector, which is the same system that we built for our aircraft. We also can use as a ground power unit. So we've developed a mobile hydrogen fuel cell ground power unit, which can be used at airports, in for whatever you need in your ground power from a DC or an AC perspective. And we did this under a contract with the US Marine Corps. And this is also modular, so it can be a lot smaller if you don't have high power needs, or it can be up to 100 kilowatt, which is pretty standard for a GPU in an airport environment. And once again, we built this ourselves from scratch too, because we wanted to optimize it for what the customer needs. And it actually weighs less than a traditional diesel GPU. So in addition to being, carbon emission free, it's also low noise and lighter mass than the incumbent, which is also good for any new technology that's being developed. So the focus of the company, of course, is on aircraft electric propulsion. And so our first aircraft is a demonstrator aircraft. We have an experimental certificate for it. It is a Piper aircraft. It's equipped with gaseous hydrogen tanks because that's what we got approved for from a regulatory perspective. I know the opening comments were related to regulation. That is important because when you're developing a new technology like this, you do get regulated by both the FAA or your equivalent, but you're also regulated by, fire department, for example, who our ground-based regulator is in Los Angeles, California. So we got approved from a regulatory perspective to have gaseous hydrogen fueling at the airport, but we haven't yet gone through the process to have liquid hydrogen fueling at the airport. And the other advantage of this system is that it is straightforward. Any pilot can fly it. It doesn't require any kind of special training whatsoever, because instead of having a manual throttle, you now have a digital throttle. But from the pilot's perspective, it's the same thing. I won't go into too many of the engineering details, but this is the overall power plant system view. It's obviously different than a traditional combustion engine power plant because you now have a high voltage bus, you have power distribution electronics, you have liquid hydrogen storage system. But ultimately, it's very similar to the implementation of an electric vehicle if you have like a battery electric vehicle car. But instead of having a big lithium ion battery, you have a hydrogen fuel cell, which provides you your peak power, and your energy is stored in the form of hydrogen, which then gets converted into electricity through the fuel cell. One of the challenges for fuel cells, which is not insurmountable at all, is that it does require a liquid cooling system to remove the heat. In a combustion system, you dissipate the heat in the form of exhaust gas. In a fuel cell, you don't really exhaust gas in the same way, so the heat has to be removed with a liquid cooling system. So we developed that as part of our product and integrated it into the aircraft. And you also get to make use of, ram air cooling from the propeller and also whilst you're flying. This is just kind of a short video where you can see our fuel cell integrated into the front of the aircraft. Obviously, this is an experimental aircraft, so it's not the final configuration, but it was done for a proof of concept to show that you actually could do a swap and replacement for a combustion engine, a piston engine in this case, with a hydrogen fuel cell power plant. We are using gaseous hydrogen, so we have high pressure gaseous tanks on board the aircraft, 700 bar, 10,000 psi. These are automotive grade tanks, Department of Transportation approved. So, they've already taken care of all of the crashworthiness aspect of it as part of that. We did have to develop some custom avionics because we are displaying a different set of parameters and a different set of on-off buttons, right? So for a fuel cell, you have an electric air compressor that you have to start. You also have an electric motor that you have to start, and then you can also change your stoichiometry, which is kind of like changing your mixture ratio. So we did develop that as part of our aircraft implementation. And we also have a power plant specific start checklist. So I myself am a commercial pilot, so I do operate the aircraft. So I went through and made sure that we had everything that a pilot would need to use to be able to operate the aircraft. It's not that complicated. It's pretty straightforward. It isn't that different from what you would have on a regular, hydrocarbon combustion powered aircraft. So from a refueling and CONOPS perspective, we do use gaseous hydrogen. So we have gaseous hydrogen delivered to our airport hangar once a month. And then we manually fill the tanks just with a high pressure to a low pressure system. It's very similar to the way that it's done if you have a hydrogen fuel cell car. Takes less than 10 minutes to fill the tanks in the aircraft. We have leak detection, so we can monitor if we had a leak or something like that. But once again, it's not that complicated. Fueling your vehicle with hydrogen is a bit of a solved problem at this point. And this is part of the approval process that we have with our local regulator. And then here's just a short video where you can't hear the audio, unfortunately, but this is just from our ground testing. And the real nice thing about electric aircraft is they're very quiet as compared to traditional aircraft. And so you can see we're sitting outside of the aircraft and we don't even have a headset on, right? Because you do get, of course, propeller noise, but you don't get a lot of the other noises you get from the combustion type system. So the near future for us is actually the development of a system for helicopters. So we recently won a contract with the U.S. Army to develop that same system for smaller training helicopters, but of course we want to scale it up, and then also to develop that system for a cargo UAV. So there are so many different options in the aviation sector where you can use electric propulsion. And if it's hydrogen fuel cell electric propulsion, then you can get the same range and payload that you would get from the hydrocarbon equivalent. So I think that was my time, I believe, and I had 5 minutes for questions.
Great, thank you. Yes, we have time for questions. Are there any questions in the room? Yes, we have.
Yeah, thank you so much for the interesting insights into the company you're working for. I'm just wondering, bigger picture. Obviously, last week we saw, or 2 weeks ago, we saw that Airbus has announced that they're basically cancelling or delaying their 2035 hydrogen plane program. I'm just wondering if you have any insights into when we can expect a commercial level hydrogen plane.
So I think for Airbus, their focus is on jet aircraft, right? Their focus is not really on smaller aircraft. So they're kind of two different sectors, two different use cases. I do think it's going to take a longer period of time to get it into the jet sector. I also think that for a jet, you're more likely looking at hydrogen combustion versus hydrogen fuel cell technology. So in a sense, it's a very different technology path. So I think I would argue that what we're doing is getting into the commercial sector, but not for jet aircraft, but for other use cases. So whether that's for emergency services, helicopters, eVTOLs, training aircraft, anything where you're using a propeller, I think is where it can get in a lot sooner. So I think from a regulatory perspective, I mean, they're not going to approve it tomorrow. They never do with any new technology, but I think within less than 5 years, that's very reasonable for that to happen. And I will say that I don't think the solution for major changes in technology typically comes from the larger aerospace companies. It usually does come from smaller companies, and then it kind of makes its way into the market that way. So it's not unusual that the Boeings and the Airbuses of the world aren't the ones pushing these technologies forward.
So you're not too worried about the evolution of hydrogen in the aviation sector, if I understand you correctly.
No, I mean, I my very first job actually out of school was working for Boeing. So I have my own, long journey in aerospace. So I know that the right way to innovate in sectors, whether it's in transportation or in energy, is from the smaller business side of things. So I think that's the way that happens. And I think, whether you would call Tesla a small business, you probably wouldn't, but certainly it wasn't part of the automotive sector, right? And so they were able to revolutionize the automotive sector. Now everybody wants to drive a battery electric vehicle. So I think it's just kind of the way it goes. You get more innovation when you have smaller agile companies, which is kind of the reason why I started my company, is because I wanted to be able to bring about these technologies because they work really well, right? So I think there's only positives to shifting over to this technology. Like setting aside, I know we have the Trump administration in the US now, so maybe they don't care about things being carbon emission free, but setting aside even the climate change aspect of it, there are so many advantages to it that it beats the incumbent technology. So those are the reasons why you should change to new technologies.
Great, thank you, Anita. Are there any other questions in the room? Yes, we have one more question for you.
Hi, my name is Louis Lamartine from Inicio. I was wondering, so you're explaining the fuel cell aviation for these smaller propeller aircraft. There's also a lot of battery electric developments. What's the exact advantage to go for the fuel cells?
Oh, yeah, I guess I shouldn't have taken out that chart. So basically, batteries are really heavy. So you cannot achieve the same range or payload with a battery-powered aircraft as you can with a fuel cell aircraft. So every single battery-powered demo that's ever been done out there has actually been at the gross takeoff weight, not carrying any payload, and it can't go anywhere. So there is an approved battery-powered aircraft, which is an ultralight. It's the Pipistrel Alpha Electro. It holds two people and it can fly for at most 1 hour. So that's kind of the limit of battery technology, is that they're very heavy. And the reason for that is that the battery, if you want to have longer range, more total stored energy, you have to carry more and more batteries. The fuel cell, you pick the fuel cell or you size the fuel cell for your peak power requirement, which is takeoff. If you want longer range, then you carry more fuel. And in the case of hydrogen, it's a very lightweight fuel. So that's the reason why you can actually beat range potentially for larger aircraft if you shifted over to hydrogen fuel cell technology. Batteries, unfortunately, they're just really heavy.
And so for pure PPL training purposes, it would be enough to have a battery electric aircraft, right? It's taking off and landing and short ranges,
Well,
right?
you couldn't do your cross countries.
Okay, clear.
So yeah,
Thanks.
unfortunately, no. And in a place like Southern California, where you have very busy airspace, you would get into trouble pretty quickly if you only have an hour, right? Because you need 30 minutes of margin as well.
Clear.
Thank you. I was triggered also by what you said about hydrogen being so much lighter, but I also think it takes much more space, right? So,
Not if it's stored as a liquid. So if it's stored as a
all right.
liquid, the volume is slightly larger than the avgas equivalent, but the weight is a lot less.
All right, so best of both worlds with liquid hydrogen.
And also you get better energy conversion efficiency. So when you combust something, you lose a lot of the energy as heat. When you convert it electrochemically, you just have a more efficient reaction.
All right, thank you. Oh, one last question.
Thank you. And Anita, hello, it's Andrew Chadwick from Connected Places Catapult from the UK. Thanks for a great presentation. I just had a quick question about how you're going to develop the technology. Are you looking to develop for larger aircraft? Obviously, you've got your Piper aircraft now. Are you going to look for something which is perhaps a little bit larger, maybe, I don't know, I mean, in the UK, there's work taking place on sort of 19, 20-seat aircraft. Are you looking to develop that way as well, or just the smaller aircraft?
I think it's better to get them flying at the smaller scale first, because the technology, every time you do another generation, we've already done a second generation on our system, you drop the mass every time. So when you design a system, you don't want to design around an inefficient power plant. So if you can have the power plant be more efficient, then you'd actually get a much better larger aircraft going forward. But those larger, heavier aircraft will also take longer to certify. So we think that the best way to get it into the marketplace is to start with helicopters, to start with single engine propeller driven aircraft that are smaller scale, and then you work your way up from that. Because every time you get an improvement, and it's not just in the fuel cell, right? It's in the entire balance of plant technology. So I know everybody wants to go for the end game of the larger aircraft to start off with, but I don't necessarily think that that is the best business model either, because there was somebody who did that and they went out of business pretty quickly, right? Because when you have a business, you have to sell, right? And if it's going to take you 10 years to get this big aircraft on the market, you're going to either run out of money, or maybe you'll have some really good investors who will stay with you for 10 years, which is hard to find, right? So if you have a smaller aircraft, you can actually start selling now, and become a sustainable business, and you can use that as a means of going to larger and larger aircraft. So that's just my personal approach to it.
Which rose one more question.
So I heard you literally say start selling now. So I'm very curious, what's the cost difference between a regular fossil aircraft like the one you showed and if you build it on the fuel cell?
So we are we don't sell aircraft, we're selling power plants to go in an aircraft. So when you actually own small aircraft like this, you have to do an engine replacement every 3 to 5 thousand hours. And so typically you'll go and buy a new, Lycoming or Continental engine for your aircraft. So our case is to provide you with a hydrogen fuel cell equivalent. And so our engineering requirement was to provide you the exact same cost, not to be more expensive than that. But then also the benefit of reduced maintenance costs, right? Because you don't have to do oil changes and there's no moving parts and there aren't things that have to be replaced in the same way. And ultimately, if you get a longer time between overhaul, which of course we have to prove, then you would actually significantly reduce the cost of ownership of the aircraft. So, but there's nothing about the fuel cell technology which makes it more expensive than a combustion system. And the beauty of it too is that it's very refurbishable because a fuel cell is mainly made out of metal plates. Those metal plates can be taken out, cleaned, and reused again in a future fuel cell. So there's a circular economy aspect of it too, which I think is kind of wonderful.
All right, thank you. Thank you very much for all your insights on the hydroplane. Very exciting.
Thank you.
Um,
Have a great conference.
Thank you so much. Bye, Anita. So I think we will dive into the next one straight after this. So I would like to welcome Louis-Philippe Lamartine, Head of Sustainable Aviation Fuel at Initio, who will give a presentation on de-risking business cases for SAF production.
Hello, everyone. Good morning. So, just gonna check out this one. So, welcome everyone. I'm gonna talk to you about how to de-risk some SAF business cases. There's gonna be a little bit of focus on eSAF, but everything that I'm gonna say should apply both on the HEFA pathways, alcohol to jet, and eSAF at the same time. So, these days, as a SAF project developer, there's two ways to survive. One is to learn how to meditate and sit through all of the stress. And the second one is to get absolutely obsessed in de-risking your projects step by step on every single part of the business case. Initio is better suited to help you on the second one. The first one, we can have an informal chat on it. So we're gonna talk you through 4 different blocks. I'm just gonna check because I'm always watching around. So does this one work? Yeah, it's easier. Thanks. We're gonna walk through 4 different blocks. So first I'm gonna talk to you about the basics, like what are literally the minimum things you should find back in every SAF project. And this is based on about 200 Power-to-X and SAF projects that Initio, as a strategy consultant, has been helping on. And what we're going to see is that clearly there's 3 other blocks that every time come back and are super critical. The regulation, everything in the SAF space is regulatory driven, so you need to be regulatory compliant. The smallest deviation from that gives you a project that might not be bankable. The technology, clearly plenty of risks. We've seen it in multiple presentations in the past, yesterday. And there's lots you can do to kind of try to tweak and find ways to further de-risk from a technology point of view. And then the economics. You're not the only project out there. So far on the eSAF, there's no FIDs that have been reached. But anyways, at some point, there's gonna be competition between projects as well, even in the space of eSAF. So it's important to further optimize whatever you can do to get a better business case. Also means upside for the investors, means easier to get to a bankable business case. So a couple of basics. Oh, no, going back. Yep, voila. A couple of basics that we see coming back in every single project, and we still get phone calls. Very specifically, a couple of weeks ago, I get a call from a project developer, SAF developer, telling me, look, we spent the past year trying to get investors. We spent the past 4 years working super hard. Our team is getting super frustrated. We're not getting there. I'm highly doubting, should I kill the project? Should I pivot, find something else? And this is not one story, right? This happens every couple of weeks. And often what we spot is that there's a couple of things that could be better done from the very, very start, really from the ID phase. First of all, location. So we still see projects being developed in places that are landlocked, for example. It's great to see places with good solar and wind, but if you need to truck around the CO2, if you need to get trucks or rail to get to a port to then ship the fuel to another location, it's all adding up to the complexity of a project, and we see that sometimes this type of complexity is just not allowed to get a bankable business case. The regulatory compliance. So there, if the market is regulatory driven, which it is, it means you have to produce a product that also exactly meets the requirements, not a little bit, but exactly. And often developers have their internal teams doing this type of checks. But I can guarantee you that every single project that Inicio works on, we find at least 1, 2, 3 aspects where the internal regulatory team disagrees with our reading of the regulation, and where we really need to dig into all of the small letters and also the intentions of the Commission and see, okay, by the letter, and I'll give you one example, EHEFA using green hydrogen to hydrotreat, hydrocrack the HEFA pathway. If you read it by the letter, then according to the current regulation in Europe, it should be allowed to claim part of this SAF as eSAF. We know that that's not the intention of the regulation, so it's very unlikely future-proof. But this type of discussions, detailed discussions, take place in the project over and over again. And it's critical, right? If you count on it for your business case to have eSAF coming out, but actually you're not compliant, well, you're dead. Third block, offtake agreements. So it has been mentioned yesterday as well. There's a bit of a chicken and egg there. On one side, to have a bankable project, you need to get offtake agreements, and to get offtake agreements, you need to be a credible project. So from the start, you want to start looking into breaking this chicken and egg and getting closer to the offtakers bit by bit. And then, of course, there's the mismatch in long-term, short-term commitments. If your business case is 20 or 25 years, an offtake agreement of 5 years is not going to convince any investor, right? And then the fourth block, it's a techno-economic optimization. So what we often see is that certainly on the more complex setups, so a HEFA setup, we consider it already quite standard. A power-to-X setup where you have lots of different equipment, electrolyzers, hydrogen storage, before that even the battery storage. If you do the methanol to jet pathway, you have some methanol storage as well. And we see that often projects are optimized. For example, the hydrogen block gets optimized and then the methanol block gets optimized. But often there's no full optimization from the variable renewables all the way to the shipping and batches by boat. So this is something that we also help on, and we always see potential to improve things. Now, imagine you get the basics right. Then you should already have a little bit less stress as a project developer, but getting the basics right clearly is not enough. There's lots of remaining risks on the feedstock supply. So that's what you see on the left side. Getting affordable and compliant feedstock requires you to be future-proof, to have backup solutions. Imagine that you foresee now to take off point-captured CO2 from a fossil plant. and you're only allowed to do that until 2041, then clearly you should already know and figure out by now what's going to happen immediately after, right? Is the plan to have a direct air capture? Well, then you have to be very sure on the timeline of your project that it will make sense. On the production side, so the regulatory compliance, we'll look into that in the next slides. The technology readiness as well. I have a slide coming up on that. The storage and the transport. So getting downstream partnerships. We see over and over again, it's great to produce SAF and then to have an off-taker, but you're going to have to know exactly how you're going to get your SAF to the airline. And we've seen blocking situations there of some parties that are benefiting from monopoly situations in airports and just stopping you from doing what you were planning to do. And then the final use, clearly the commercial side, offtake agreements. There's things like portfolio approach or working through aggregators like there's Atoba, there's some others out there that can kind of help to de-risk and make sure that you have multiple offtake scenarios. And then the overarching risks, so regulatory and policy risks. Yes, there are shifts in governmental support in policies. What you can do there, and it's not a great solution, but at least making sure that your products are multi-compliant, that you already know in case something changes in region 1, how am I going to still market my product in another region? Like, am I ready for that? What would I need? Pretty critical. And, well, the project financing, of course. So limiting the number of partners, trying to make sure that the right type of investors are involved from the beginning. This is critical. So all of these aspects are things that with Inicio as strategy and technical consultants that we can help you on. So diving into the block of the regulation now. Most of what you see here is focused on the eSAF, but a lot of it applies on SAF in general. I'm not going to explain all of it, but clearly the European mandate, and that's the one that you see in the middle, the general SAF mandate, the synthetic fuel sub-mandates, they are driving the overall SAF developments. And over again, we get project developers reaching out that say, okay, and often outside of Europe, saying we are going to produce for the European market. Perfect, okay. Will your product be compliant? Well, we think so. Okay, great. Let's look into the details of that. And then we find out that their CO2 is not compliant. Okay, what can you do? Well, in most of the cases, if you have already secured your land and you find out that your CO2 is not compliant and you need to start off with alternative scenarios, immediately you will see a negative impact on the business case. It's not optimized anymore. So really the main point that we want to send on the regulation is to study the regulation and the offtake market very early on in the project. Really from the moment that you have the idea of developing, that's where you need to be full on regulation, because that's what's driving the whole business case. And for renewable developers or typical developers that come from other sectors than the power to X, they often have the idea of taking things step by step in a linear way. And so the regulation, it mostly doesn't come at the beginning. It comes asking for permits, so lots of things in terms of size have been determined. It's way too late for a power to X project. If you really do it in the same linear way as for a wind plant or a solar plant, then your project setup is not going to make sense. So from the beginning, doing a life cycle analysis, doing the checks, regulatory checks on your feedstock, making sure that the whole project setup makes sense. Doing pre-certification. So in-house, but also third-party pre-certification, where you really look into what does my project look like, what does the regulation require, where are the gaps, how can I improve, what type of documentation will I need, and then you can already even get an auditor to look at your project and really go through the documentation and tell you, okay, these are the weaker points, and by the time that you would go in operations, you will have to make sure that you can prove this or that. So that's something. So it helps to already start very early on preparing these documentations and the things you need. On the technology risks. So clearly, if you look at all the different ways of decarbonizing transportation and aviation, there's different pathways, different maturities, and different innovation risks complicating life of the project developers. The main risks that we see is that, well, from technology point of view, you don't reach the efficiency that you were hoping for. This has a major business case impact, of course. You can't get to the volumes that you committed to in your offtake agreements. The construction timeline is stretched way too far. And the first mover disadvantage. So we've been referring to that already in yesterday's session. Someone was explaining that they expect the first mover disadvantage to be compensated by the inflation. Fully agreed that part of it could be covered by inflation on the capex. But there's quite some learning money being paid these days with the first projects, right? So trying to do it as good as you can, trying to de-risk, spending a little bit more money now in the early phases before you go all the way and have to pay the learning money 20 or 200 times more expensive while running the project. It certainly makes sense from an investment point of view. Now, what can you do to still try to manage this technology risk a little bit better? Clearly, so, and some of you might laugh, when a developer reaches out to us to develop an ESAF project, I can guarantee you that 80% asks us to include direct air capture in the business case. I can also tell you that 2 weeks into the project, all of them agree that we take out direct air capture out of the business case. And that's the case for direct air capture, but solid oxide electrolyzers, all kinds of more experimental things, it certainly doesn't make your life easier if you want to reach FID with a project. Now there is potential to, for example, for part of your electrolyzer capacity, include a bit of SOEC. But going full on new technologies and combining all of these new technologies one after the other for your electrolysis, for the conversion towards the jet fuel, it makes it very, very difficult. What we also see, and that's something that came up heavily in the past 6 months. Before that, a lot of the developers would come to us with pure Fischer-Tropsch projects. In the meantime, many or most of the projects that we're involved in are a combination, biomass and power to liquid. So you try to make sure that your equipment, in the worst case, allows you to still process biomass. Or in the best case, you start with biomass, but you plan to expand towards ESAF with your equipment. So a step-by-step approach. We see, and that comes a bit later, the hub and spoke on the methanol. So, like I said, 6 months ago, lots of pure Fischer-Tropsch. In the meantime, a lot of Fischer-Tropsch believers ask us to look into the methanol to jet as well. And now more and more you see the setup of, well, maybe we shouldn't go straight to SAF. Maybe we should just do methanol. And then when we get mature enough, we can always add the module of the methanol to jet. Or we start shipping our e-methanol to a methanol to jet facility. So for example, the project of Power to X, based in Rotterdam, They are planning to do methanol to jet, but they're planning to source their methanol globally, right? There's multiple actors like that, and it allows you to further de-risk the business cases. From a market point of view, so there's a merit order in the market, and largely to keep our life simple, we've always said eSAF will be purely for the synthetic SAF mandate. It will be too expensive to supply to the general mandate. We keep these two markets nicely in our heads. We keep them nicely separated. But in reality, it is one big merit order, right? Going from the cheapest SAF all the way to the most expensive SAF, and then we're trying to fulfill these mandates in the most economical way. Makes a lot of sense. Now, already between the different projects in these blocks, there's pricing competition. Even if you can sell more expensive, logically, if you produce at a lower cost, your margins are higher. So never a bad idea to optimize your production cost. We often hear that the price of the penalty kind of steers the market price, and it has been discussed yesterday as well. There's a couple of critical aspects to have in mind there, because from one side, yes, in the UK, the penalty, it's not a penalty, it's a buyout price, right? The buyout price allows you to opt for something else than buying the SAF. In Europe, it's a penalty that does not take out the obligation to still fulfill your purchase of SAF. Meaning that actually this invisible line of kind of a maximum price for SAF in the European market, it doesn't really exist. So it's very difficult to see exactly how it would limit these purchases. A lot of the eSAF projects had targets of between 3,500, 5,000 euros per ton of production costs. Lately, more and more, there's been amounts mentioned of 7,000, 8,000 euros per ton of SAF. With the 8,000 euros per ton of SAF, you literally in the UK get to the buyout mechanism, meaning that if an obligated party needs to choose, if you go beyond this buyout mechanism, there's no reason for them to choose your project, right? It's less costly to just pay the buyout price. So what can you do there? Even within the same pathway, we see that there's huge optimizations in terms of cost. One example, thermal integration. You have a Fischer-Tropsch or a methanol to jet setup. If you, for example, would use a solid oxide electrolyzer, a high temperature electrolyzer, and you can recuperate the heat coming from the Fischer-Tropsch, you can have business cases where before optimization, you're around 4,500 or 5,000 euros per ton of eSAF, and you can push that down by 500 or up to 700 euros by having good thermal integration. Now, I mentioned before, SOEC, technologically speaking, it's quite risky, so it increases your project risk. But if you can reduce by 500 or 700 euros per ton your production costs, that's quite something. Huh? Reduction of cost through the design one, build many. This is something that we see coming back as well. So many of the project developers, they kind of try to identify a standard size of project, and it can really help you to have one design very, very, very optimized, and then try to replicate it in different regions in similar circumstances. It can really help you to optimize costs as well. So just to wrap up, and I see I'm already nicely over time. we had the list of the best practices, making sure that the basics of your project are correct. Everything is regulatory driven, so from the beginning you need to make sure that your project is compliant to the market that you're planning to sell in. Technology-wise, think twice about every technology block that you want to involve. And economic-wise, make sure to optimize every single bit of your whole project. Voila.
Great, thank you.
Thanks.
We have time maybe for one question. Is there a question in the audience? Well, in that case, see, we're time constrained. Thank you very much, and we will call up the next speaker. So our next presentation will be a presentation on how Neste scaled SAF production to meet EU and UK mandates. It will be given by Alexander Cooper, who is a Vice President Renewable Aviation Business at Neste. Welcome to the stage, Alexander.
Good morning, everyone. Great to be here. Great to see some familiar faces and some new faces as well. So I am going to speak a bit about Neste and how we scaled up the SAF production. It is maybe the opposite side of the spectrum from what we just heard. By the way, great presentation. So this is not the startup kind of world, but it is the, as most of you know, largest SAF supplier in the world with you know, a production capacity of more than 1 million tons. So we basically went through all that very early, many years and even decades ago. And I'll speak a bit about, you know, how that happened and how we did that and where we are today to basically meet the mandates that exist in 2025 and of course in the future. So there is a lot of fuel that is consumed right now. I think it's about 350 million tons per year according to IATA. And all of that, of course, or almost all of that, is fossil fuel with the corresponding emissions. Now, that picture not only looks very interesting and nice, but it also shows you that there are some areas in the world where you don't have as much aviation activity as in other parts of the world, which would be the US and Europe, which is like super crowded and you can't even see a bit of landmass for all the little planes that are there. But then if you look at Africa, you look at South America, it does look quite different. And the reason why I am mentioning this is that there is a lot of growth potential in aviation. According to Boeing, 80% of the world's population have not seen a plane from the inside, which gives you a clue about the growth potential that aviation has. And of course, while aviation is important for economies to develop, especially when you think about Africa, where the terrain is very difficult to build high-speed trains and motorways. Of course, these countries depend on the growth of aviation for their economic development. It is not something that, you know, for the sake of decarbonization, we can basically tell the world, oh, you can't grow your aviation business. It will grow, and it has to grow for their economic development. However, the challenge is we need to make that growth carbon neutral. And on top of that, we need to reduce what we have today, which is a massive challenge because already the emissions that we have today, it's a daunting task to reduce that. And unfortunately, we don't have a huge amount of time left for that. 25 years is, if you think about the lead time for these developments, if you want to be net zero by 2050, it's not a huge amount of time. All right, let's look at a bit more in detail as to where we are today and where we want to go. So we will need so this chart here shows you how we could decarbonize, but it also shows you there's quite a bit of growth in emissions. That's what I just said, and that curve could be even steeper depending on how the economic development goes and a couple of other factors. Now, technology is very, very important. It will play an important role. And when I say technology, it also means more efficient aircraft. So a A321neo emits about 30% less emissions than a first generation A321. So that is a very tangible reduction in emissions and in fuel consumption. At the same time, you also have new technologies like hybrid and electric aircraft. We just heard the first presentation of the day. It will not make a huge difference for 2050 if you look at the wider kind of aviation, commercial aviation business, simply because it will take time for this to scale up enough to play a big role. And you all know that the hybrid aircraft that Airbus was announcing has been postponed a bit. So I don't think we will see a huge amount of impact here for 2050. But more efficient engines are being developed and produced as we speak, and that will, of course, have a big impact. And then, of course, we have operations and infrastructure that refers very much also to the air traffic management. So if the single European sky and super efficient air traffic management was implemented in Europe, that could reduce the emissions up to 10% in Europe. It's quite substantial what you could do there, because as you know, airlines in Europe fly around in a bit of a zigzag a lot of the times. And then you have other things like delay management and congestion of airports and all of these things, which if you reduce that, that will also have an impact. Then you will have a residual, that is the gray area that you find here, a residual amount of emissions which you cannot abate in sector, which basically will still be there, and you will need to offset this. Now, when I say offsets, there is very high quality offsets, as most of you probably know, that will permanently reduce the CO2 and capture it. So there's very advanced technologies. There's companies like Climeworks and the like, and that will also play a small part. But the sharpest knife in the box is, of course, SAF, and that's the green bit you see here. That will do the heavy lifting to reduce emissions, and you will need a lot of SAF for that. In 2021, which is not so long ago, the global SAF production, not just Neste, everybody, the global SAF production was 80,000 tons, roughly. According to IATA in 2024, the global SAF production was 1 million tons. That's quite a significant scale up for a kind of 3 to 4 year kind of time horizon. But we need to go to more than 500 million. So we were just at 1 million last year. In 2050, which is in 25 years, we will need to go to more than 500 million tons. And that is just a massive challenge. How do we get there? I will talk a bit about the pathways and, of course, also the availability of feedstocks. So how can we get there? And, of course, in theory, it's all nice to think, yeah, we'll have lots of e-fuels and then we'll have 500 million tons of e-fuels, but it is quite challenging to get there. Having said that, every project that is being started is good, is positive. We need everything we can get to really ramp this up to 500 million tons. So, if there are competitors out there that want to start a new SAF production facility, e-fuels or whatever, welcome. I think we will need everything we have. Good. Let's talk a bit about Neste, because I think the example of Neste is very interesting. And when I joined the company almost 2 years ago to the day, I was quite fascinated by how it came about that Neste became the global market leader in SAF and renewable diesel, with quite a significant reduction of greenhouse gas emissions. And how did that happen? Why did Neste start so much earlier than almost everybody else? So Neste is a Finnish company. It's not a huge company. If you compare it to Shell and BP and Total, it's about 5,000 people, and with probably a bit less in the future because we're going through a bit of a resizing at the moment. So we are not a big company, and we started out as the Finnish national refiner, so to say. So basically, after World War II, Finland had a need for refined products, gasoline and gas oil, and everything basically. And then Neste was basically refining those products with crude oil that was imported from somewhere else. That crude oil sometimes wasn't the greatest quality, and they developed the ability, the engineers, to process difficult feedstocks. In that case, it was fossil feedstocks, difficult fossil feedstocks such as very heavy and sour crude. With these developments, with this technology and that know-how, eventually they went into, hey, we can also start processing non-fossil feedstocks, renewable feedstocks. And that's what they started to do in the 90s. Eventually they patented the technology, which is called Next BTL, which is what we use today in our refineries. And and then in the 2000s, there was a decision to go into this and invest. Now we're at that stage that we are before FID, right? There were a couple of very visionary people that in the 2000s said, okay, let's invest into this. And when I say invest, I'm talking billions of dollars. I'm not talking 100 million or something. I'm talking a huge amount of money. These people were visionary, and they had a very strong sense of purpose. I admire them because when they took that decision, the demand was literally zero. It was more a purpose-driven decision that wasn't based on how do we make the quickest return. Of course, the fact that Neste was at that time a state-owned company also helped because you wouldn't have the shareholder representatives breathing down your neck and saying, okay, I want my return in 3 years and I want this and this rate of return. It was a bit of a maybe a framework where you could think a bit more long term. And they did this, so I do think Finnish people, I'm not Finnish myself, but my observation is that people in Finland tend to be, it's a very big country, it's not a lot of people. They're very connected to nature. So many of my colleagues have their little kind of cottages at the lake where they spend the summer, and it's super connected. Protecting nature and being close to nature is a very strong value that you would find in Neste. And this is why I'm saying this is also purpose-driven. It's not just a numbers game. It's not just a business case. Anyway, they did this. It didn't work terribly well for Neste in the beginning because they had a lot of investment, but there wasn't a lot of demand. So if you look at the numbers in the late 2000s, the profit went down quite significantly. Neste even went into generating losses, which is quite unusual for an oil company. And there was a bit of a crisis because they had invested so heavily in this that there was no market. I mean, remember 2000s, 2005. I mean, you had 9/11, the Iraq and Afghanistan wars, you had the financial crisis in 2007, 2008. Sustainability was not at the top of the list in people's minds. This was like much earlier. But then it came, of course. Now they invested. We invested in chemicals and polymers, which is basically renewable plastics, if you will, renewable diesel, and then, of course, eventually also with sustainable aviation fuel. Now I'm going to spare you the details of the rest, but so today it is road transport, polymers and chemicals, and aviation. And where we are today is that we have a global network of production facilities. Singapore is our biggest refinery with a production capacity of more than 1 million tons. Just to put it in context, I mean, I already mentioned the 80,000 tons in 2021. 1 million tons is, give or take, the entire refuel mandate. That's about 1 million tons. Neste alone, with our Singapore refinery, could supply that fuel. So it's really, really big. And then, of course, we also have Rotterdam. We have a production facility in Porvoo, which is in Finland. And then we have a renewable diesel facility, which is a joint venture in Martinez, California. As I said, now we're at the end of this year, we're going to be at 1.5 million tons in production capacity, then growing to 2.2 million tons in 27. And since we are here in the Netherlands, I do want to mention that we have a massive expansion program in Rotterdam, which is what you see here. This is all reclaimed land, and we are building an additional SAF production facility, which is going to cost us about 2 point something billion to do that expansion facility, and that will take us then to 2.2 million tons. So, taking an investment decision, I explained a bit sort of, it wasn't a core business case in that sense, but of course they were looking at what they were doing, and of course they were also very heavily involved in advocating for mandates. Without the RefuelEU mandate, this investment would not have made sense, and we wouldn't have continued investing in the ramp-up of SAF if it hadn't been for RefuelEU. Now, you have other models. Of course, we all know there's a pretty good set of incentives in the US. By the way, it's not just always black and white, stick and carrot, because we also do have some incentives in Europe. And in other places, the combination of both of the mandates and the incentives are extremely important to kind of form the business case for this. There is the execution risk, and I will admit, Neste has tried over the last 20 years many times. We've tried something, it didn't work, we started again. And so it is not an easy thing to build this because it's new. I come from the fossil oil industry. I used to work in Shell. If you compare a fossil refinery, it's something that has been there for a long, long time. There's a lot of experience. What we're doing here is kind of, something new. It will always be phases where you try something, and you also mentioned it when you sort of, how do you risk these investments, where you need this experience, but there's very little experience in the market because this is new what we're doing here. Of course, the market expectation is important. Again, we see that the voluntary demand is not that strong, simply because SAF is more expensive, and it has to be more expensive. If you look at the feedstock, so if you have a liter of used cooking oil, which is what we use as a feedstock, and you have a liter of jet fuel, fossil jet fuel, that you can put on a plane and fly on it, the used cooking oil at times will be more expensive than the jet fuel. But then you need to put the used cooking oil into a refinery that happens to cost $2 billion, and then you have the product you can fly a plane on. So can it be the same price? No, it can't, because otherwise the refining process would be for free. And even Neste, we need to earn the depreciation on the investment that we made. That, of course, and without, maybe I'm jumping here a bit, bearing in mind that I only have 3 minutes left, I want to show this here. So if we talk about feedstock, it's pretty obvious that used cooking on animal fat is not going to take us to 500 million tons. It's impossible. I mean, there is way to go. We can produce a lot more HEFA. We can produce a lot more SAF that we're now producing with the current technology and the feedstocks. Our estimate is that in 2030, there will be more than 40 million tons of used cooking on animal fat, so way to go. And I also believe that HEFA will remain there simply for the fact that it cannot be replaced with something else, and certainly not for the price that it has. So it will remain there, and so we will have in 2050 maybe about 50 million tons of HEFA-based SAF, but the big growth is not going to come from there, simply because the feedstocks are too limited for that. There are different ones, and you can spend probably a full week discussing which ones will be bigger and less big. In Neste, we have a lot of research going on lignocellulosics, which is basically forestry waste. So all the trees and the branches and whatnot that fall down. So you don't cut the trees. I mean, the forest continues to exist, but you kind of clean it out and you get that as a feedstock. That can have a big role. We've been also looking to algae, and then of course there is the power to liquid, which largely depends, of course, on the availability of sustainable green energy. So if we have lots of that at some point, then of course it will be a lot easier to scale up the power to liquid as well. So I think having not a lot of time left, how do I go back with this? Okay. Maybe to wrap up a bit, sort of, what do we need to increase investments further in the remaining minute or so that I have? The policy support is key. Without policy support, this is not going to fly, period. You can produce as much SAF as you want if you rely only on voluntary sales and the passenger that buys some, small share of SAF for their flight, which very few people do. This is not going to fly. You do have an important factor, which is the corporate customers. So you have corporate customers that have very ambitious ESG targets and decarbonization goals. They buy SAF that then the airline burns, and the company that pays for it gets the certificate, and they can count it for their reporting. That is quite substantial. In Neste, we have a product which is called Neste Impact, where you can do that. But of course, also our customers, such as DHL and others, they buy SAF for their, basically, so they can then sell the certificates on to their final customers. That is a driver, but without regulation, this is not going to fly. And you can have incentives in the US, you can have mandates. By the way, Singapore is having a mandate. India is probably in 27. They want to start with a mandate, so you have mandates popping up in a lot of places. And then, of course, you have incentives. Ideally, the combination of both will have the fastest ramp up. But this is important. Then, as I said, you have some voluntary markets. That alone will not sort of do the trick to ramp up to 500 million tons. And then, of course, you have the innovation with the new pathways and how we can actually grow. The key is that the industry, the regulators, the producers, the customers need to work together very closely. The engine manufacturers, the airplane manufacturers, we all need to work together in a compliant way, of course. But we need to work together because otherwise this ramp up is simply not going to happen. So if we do that, we're on track. We can do this. Humans have done other things which are amazing. Nobody thought it was possible. We believe this is possible. And of course, at Neste, in a way, we are leading the way here. So that was it. Happy to answer questions if you have.
Thank you, Alexander. Thank you for your presentation. We have time for questions. I see a first one there.
Thank you very much. I'm going to go straight into the maybe difficult question. So Neste announced in 2024, sorry, my name is Sarah Wilkin from Fly Green Alliance. In 2024, I know that Neste didn't sell all of the SAF. Was this that you produced? Was this expected? Is it a major concern? And what is your strategic kind of plans for ensuring the demand is going to increase in the future?
So, as any oil company, that is not different than in the fossil world. You sit on a refinery and you produce different products. You can do renewable diesel, you can do SAF, and what you produce will depend on the financial profitability of it and other factors. According to our report, 2024 report, we have produced 530, I think it was, 530,000 tons, and we do have a capacity of 1 million tons, so we had a capacity of 1 million tons. So you're right, we didn't produce and sell as much as we could have, but simply the market is not there. The market is currently oversupplied. There's a lot of SAF, and there's too little demand. To make it very clear, I mean, my former boss, Willie Walsh from IATA, he says, the airlines will buy every drop there is. That's not the case. It's simply not true. It used to be true maybe a couple of years ago. It is not true. The airlines, and I get it, SAF is more expensive, and airlines have very thin margins. I think the average margin on a ticket globally is about $7, I think. So it's I understand why it is the case, but the fact is that there is not enough demand, And of course, now we have 1 million tons in demand coming in through Refuel EU, and then you have the UK, and you have Switzerland then following, and so there will be, but of course that will remain flat. So until 29, you will have no additional demand through Refuel EU. We believe it should be more of a linear ramp up, because then, before you know it, on the 31st of December of 29, you need an additional 2 million tons, and then that might still be possible with the production that we have. But then if you look at 2035, where you go from 3 to 10 million tons, people, you can't switch on a refinery overnight. You need, years and years of ramp up. So that's part of the answer. So we wish there was more demand, but clearly, I think the regulatory environment needs to support here again.
So do you think it will be it must be voluntary? It's only voluntary demand that will support in this case. Would you?
Yes.
Yeah.
Yes. And maybe just one thought on that. A lot of airlines would like to do more, but there's a competitive distortion, obviously. So if an airline buys a lot of SAF, that will cost more money. And if they compete directly with an airline that buys no SAF at all, or has no mandate, they have a competitive advantage. So I think, and then we're talking about COSIA, ICAO, and global schemes. If you have those, then of course, and I know it's very unlikely, but let's assume we had a global ticket levy that would be used for SAF and earmarked for SAF, which is very unlikely, but if we had that, then of course we wouldn't have that distortion. I think part of it is also jet fuel is simply too cheap in the sense that it doesn't contain the cost of the environmental damage it does. And maybe you also have to approach it from that angle.
Thank you. Nicely said. Any other question? We have time for one more.
Yeah, Davide Stramare from Nextcam. I'm very curious about your knowledge and expertise in the feedstock collection, aggregation, and treatment, since you've been one of the first in the field of the EFA, and also related to the new expansions you have or your capacity. How do you see like the feedstock has been more difficult to aggregate? Maybe you find that it's more contaminated. What's your thoughts about this, and what's your view, your strategy, also to aggregate the necessary feedstock for your expansion projects in Europe, especially?
Yes, I think this is one of the biggest advantages of being a first mover. So I heard the first time the word first mover disadvantage, but in this case, this is really a big advantage because we sit on a very well-established supply chain for feedstocks, if you're a newcomer, you might struggle with those feedstocks because they're in high demand. So we source our feedstock from lots and lots of countries. We have, in every country where we source the feedstock, we have people on the ground to really make sure there's a good chain of custody, and we have an overview of what is happening. We prevent fraud and all of that. Now, there is enough. If you have a very diversified chain, so for instance, in the Netherlands, I think we actually collect the used cooking oil from McDonald's, and in the US we have subsidies that actually drive around in the cities and collect all the used cooking oil from the restaurants, and it's a very granular kind of tedious way if you compare it with fossil fuel, right? Where you just you drill a hole, which is not easy either, but in a way it's more scalable quickly. This is very granular. This is very tedious to collect it. But it is what it is. This is kind of how you collect it. So we are not facing any major challenges. And if you have some developments that you would have a change in the VAT regime in China, or you would have some other restrictions that you cannot export certain feedstocks anymore, our supply chain is so diversified that we kind of manage quite well to deal with this. But I can see if you don't have that diversified supply chain, it might impact you very heavily if you just depend on one country or two countries or something like that.
All right, thank you.
So if you can, one more question. We have one more question online from Mariana Villegas from Paragon Scientific, Liverpool, United Kingdom. The question is, how is your company regulating the specification targets on SAF to meet the regulatory compliance? Quality reference materials to trace specification are key in other fuel fields. What's the position of those quality reference materials in your company as part of the regulatory compliance traceability?
It's quite, thank you for the question. It's quite a detailed question. I think I can go on for about 2 hours trying to answer this, but I'll try to keep it very high level in view of the fact that the time is out. So there's two aspects. One is that, of course, we have a dedicated sustainability team that is really looking after what do you need to do to meet the requirements. I mean, we work with RSB a lot. So there is under COSIA different, certifications and bodies that you need to basically adhere to certain criteria. And then, of course, you have Annex 9. And so there's a lot of different kind of things you need to watch. And I think it was also said earlier today, you really need to monitor this very, very precisely. What is happening, what is changing, how do you meet it, read the small print, so that there's an entire sustainability team around that would then make sure that we meet all the specifications. And then, of course, we also work, not only we take what we get from different bodies and different associations and certification entities, but we also work with those entities. So we, have an observer seat when there is a certain ICAO meetings. We talk a lot with RSB, for example, and with ISCC. So that there's also kind of, we are as a leader in this. Of course, we're also someone that has something to say on this. And then maybe there's the other part, which is very important, which is then sort of, there's an aviation world with an established framework on how you can, what specifications jet fuel needs to meet. So there is JIC, which is called Joint Industry Group. There is Energy Institute, and they kind of say, how do you need to handle the fuel? How do you blend it? What kind of specifications does it need to have? There is EASA, the European Aviation Safety Agency. So all of these bodies will also determine what you can do and what you cannot do, so you have clean and on-spec fuel in the plane when the passenger flies with it. And most people don't realize it, but if you fly home from Amsterdam, you will have SAF in your tanks. Many of you, that will be, obvious. For a lot of people, it is not. So of course, it needs to meet all the specifications that we have from the engine manufacturers, the airframe manufacturers, the authorities, and also we have that is a technical fuel team that is in my team as I lead the whole aviation unit in Neste, and there's a couple of people that really only make sure that we meet these specifications. Now I realize that was maybe a bit too high level for what the person that was asking was trying to discuss, but I think in view of time, I'll leave it there probably.
That's okay. Thank you very much, Alexander, for your presentation and answering the questions of the audience. We will now move to our last presentation in the infrastructure and social integration topic. I would like to welcome Cyril Dufont-Sanso, I hope I pronounced that correctly, who is the Chief Executive Officer and co-founder of Hy2gen, and he will present on the importance of strategic location selection and partnerships for eSAF product plans. Thank you, Cyril. The floor is yours.
Thank you very much. Good morning, everybody. So based on a case study and a eSAF project in the south of France, I will speak today about the importance of strategic location selection, but also the importance of closing strategic partnerships to develop such difficult projects. But first of all, just some words about who we are. So Hy2gen is a German-based company founded in 2017. So I go fast on this. I am one of the co-founders. But very quickly, we closed partnerships with financial investors and strategic investors with the goal to work very, very closely on the bankability of our projects. And we decided from the beginning to have a global footprint to find the best locations worldwide to produce competitive hydrogen and hydrogen derivatives. So today we have 6 subsidiaries, mainly in Europe, so France, Germany, Nordics, Norway and Scandinavian countries, but also in Americas with USA, Canada and South America and Paraguay. And in 2022, we had a capital raise, and we welcomed new investors, as you see on the screen. And from the left, so strategic investors, and in particular Trafigura. Trafigura is one of the biggest raw material and commodity trader, a Swiss-based company, but helping us in closing offtake contracts by bringing on the table their offtake capabilities, but also their balance sheet and the way they can deal with liquidity damages, securities, guarantees towards final off-takers. We also welcome Technip Energy as our EPC and engineering partner in order to develop in-house blueprints in order to optimize the technical setup of our plants to make it more competitive. But also, we welcome financial investors, and this is a very strong message on partnerships, to work early enough on the projects, on the bankability of the project. And here we have, for instance, I-24. I-24 is the biggest hydrogen fund, with big LPs like TotalEnergies, Air Liquide, Airbus, CMA CGM, and so on. So they can work from a venture capital point of view on the bankability of the projects. We have also Mirova. Mirova is a subsidiary of the Natixis group. So we have also here the point of view of banks on the bankability of the projects. And CDPQ is the pension fund of Quebec. So same point of view from VC. So today we have 3 gigawatts of projects. So we are basically only on eSAF, speaking about e-fuels today, but from a hydrogen point of view, we only produce green, no blue, but only green. So we have 3 gigawatts of projects worldwide to meet FID by the end of the decade, or before the end of the decade, and 15 gigawatts of project pipeline. We are more than 70 employees today, and I say the global presence in the best areas to produce competitive hydrogen. So now to enter into the project in France, our goal is to develop an eSAF project in the south of France, in the industrial harbor of Marseille-Fos-sur-Mer, utilizing the existing infrastructure there. And I will enter into details in other slides to make you understand why the project selection is very important. The goal, obviously, is to produce eSAF to address the mandate's requirements, but I will not detail that. It has been done enough yesterday and today. But to focus on partnerships. So this project is developed in partnership with another developer, the company H2V, having footprint in France, UK, and a bit in Spain. You could say they are competitors to you. Yes, they are. But the goal is really to join forces because such projects are very high demanding in terms of DevEx. Or to bring such a big project, which is something like 2 billion euros capex project. So to bring such a project to FID is requiring a lot of development expenditures. And joining forces is helping to share the risks, to share the costs first. Second is also to share the competencies, because H2V has developed previously a hydrogen project that has been sold to Air Liquide that is currently under construction in Normandy. So they are very good in securing land, securing power connection, developing the first phases of permitting like public hearings. But at hydrogen, we have a better competence in technical matters, but also in commercial matters, thanks to what I have shown before. So joining the competencies is helping to tackle all the issues of the development of such a project. We have also joined forces with the harbor of Marseille itself, being a shareholder into the SPV, because the harbor of Marseille is a state-owned harbor. So it means that we were able then to gather the support of the local authorities up to the French authorities. So easing the whole process for the development of the project. And then after that, we have developed partnerships downstream with airports, because we need to get access to airlines, we need to get access also to the infrastructure to deliver SAF. But also, and I will show you that later, with all the infrastructure, and especially at the end with pipeline operators, because we need to handle all the streams, CO2, and the delivery of the SAF. So a picture of the harbor itself. So it's the biggest harbor, industrial harbor in France, and one of the biggest in the Mediterranean area. And in terms of milestones, how we did that. So at first, H2V secured the land with the vision to develop e-fuels, and could gather the harbor of Marseille as a shareholder. And they developed the public hearing of the project. And here it's important to understand that this harbor is a very strong oil and gas facility because of the presence of 4 refineries, oil terminal, LNG terminal, logistic infrastructure, petrochemical industries. So the public is well trained to industrial matters, and they have a strong understanding, which is not always the case when you want to implement an industrial plant, in particular an oil and gas plant or a chemical plant in an area where people are not accustomed to that, because then you will face a lot of social acceptance issues. So that's also one point to keep in mind. The social acceptance today, and especially in Europe, is very important. And finally, we joined forces last year, and we entered into a consortium, and we diverted the project to the production of eSAF because of our understanding on the regulatory framework and the eSAF requirements, thanks to the mandates. So, and I go fast on that. So the project goals are related to the regulatory framework, so I will not enter into details, you know that, and we have spoken a lot about that right now. And to go into the main topic, which is the choice of the strategic location. So you see here on the picture all the chemical infrastructure, the tanks, and so on. So the project will be developed in an area like at the bottom, so it's a free zone that is not facing biodiversity issues. So that's also very important to keep in mind, even though it's a green field. And the project is aiming to implement a 300 megawatts electrolyzer to produce 75,000 tons a year of eSAF locally. But you will see that thanks to the infrastructure, we could also import SAF to store it, or we could import intermediate products to upgrade to SAF on site, so increasing the capacity of the plant. And this is another goal, thanks to the infrastructure in place, because we benefit from a harbor that is used to import LNG, diesel, crude oil, and to upgrade that on site. So our goal is, thanks to a methanol to jet process, and we know that this is maturing, but we make a bet here that it will be ASTM certified soon. We will be able also to produce methanol in other locations where we can benefit from better power prices and from renewable bidding zones like Sweden or Spain, where we already develop projects, and to increase the capacity of this plant. The goal is to start operation in 29. As said, the first steps of the permitting have been passed, so we expect to meet FID in early 26. The harbor itself, why this harbor? As said, because all this infrastructure is in place. So they are currently already importing jet fuel by tanker or crude oil that is upgraded into refineries there. There is also the biorefinery of Total Lamed in this area that is producing biofuels, but also importing SAF to be stored. There is also strong storage terminal, DPF, there with all kind of products. We also benefit from underground storage in salt caverns in the area with pipelines helping to store and unstore there. We have airports with storage capacities in the area, in particular the Marseille airport. So everything is in place. And you see that we can deliver by pipeline because there is the SPMR pipeline, so this is the red one. You see that is already delivering SAF or kerosene today, but in the future SAF to the local airports like Marseille, Nice, Lyon or Geneva. But this is also connected to the green pipeline that could deliver also the products up to Amsterdam or Frankfurt. So it could, thanks to the import capability of this area, we could also deliver across Europe. But as you see, not to Paris. So that's why it's important to understand that developing eSAF projects, according to us, has to be done in industrial harbors that are connected with pipelines with airports or with refineries to be blended. That's very, very important. So that's why from Marseille, we can deliver except to Paris. And for Paris, we are developing projects in Le Havre or in Dunkirk, for instance. So as a conclusion, before opening the floor for questions, so the site selection is very important in terms of obviously infrastructure, land availability, connections, power connections, and so on. But also it's important to develop partnerships to make it happen and to work on the bankability. What I did not mention earlier is that this site has been selected also because of the power availability. 300 megawatts is not available everywhere. You know that many projects or very power-intensive projects are under development across Europe. In this area as well, so that's why the grid operator is reinforcing this capacity to bring 6 gigawatts additional power capacity there. So this is really a focus of the French authorities, and that's why we also selected this plant. So I came to the end of the presentation, so let's open the floor for questions.
Thank you very much, Cyril, for this great presentation. Are there any questions? Yes.
Hi. Two questions. So the first question is, you've mainly focused on the production of hydrogen, but also the synthesis of the fuels, or only the hydrogen and you work with partners?
So we are on a DBOO model, so design, build, own, and operate. So that being said, depending on the locations worldwide, we focus obviously on hydrogen production, but we need to have an off-take market. So that's why on our own, we also develop the synthesis, and depending on where we are, it can be ammonia, it can be methanol, it can be SAF, but we handle the whole supply chain, so we do also the synthesis and we sell the final molecules.
But do you develop the technology for the synthesis yourself or you license it?
No, we integrate technologies that are available on the market. So.
Oh, okay.
Yeah.
Okay. And my second question is for the project in the south of France. You said you are also so you go the pathway methanol to jet. Do you consider that it's going to be ISTM conform until that time when you start the operation?
That's what we are working strongly on.
Okay.
Yes, we do. We do. We are technology agnostic, so we have other projects with Fischer-Tropsch, for instance. We also looked at fermentation in some cases, but for this one, because of the logistic infrastructure in place, we have chosen methanol because we want to be able to import methanol as well.
Yeah, yeah, I understand.
So that's why we hope that it will be certified.
Yeah. So yeah, you hope, but so it's not a guarantee because we don't know how long it's going to take.
That's the point. So
Okay.
that's the point.
So
But
this is a risk that you take. However, for the multidisciplinary aspect of your offtakes.
yeah,
Okay.
it is a risk we take. Obviously, it could delay the FID of the project if this is not certified in time. But yeah, we make a bet.
Thank you. Any other questions in the audience for Cyril? All right. Then I want to thank you again, Cyril. And,
Thank you.
So with this presentation, we also finalized the four presentation on the infrastructure and social integration topic. We will now start our new topic with 3 presentations on aerospace, technological and operational advancements. And before we have a small coffee break, we'll have 1 presentation still pending. So I would like to invite Andrew Shadwick. He's the ecosystem director at Air Mobility and Airports at Connected Places Catapult. And he will give us a presentation on the role of data and digitalization in sustainable aviation. Thank you very much, Andrew, and welcome.
Thank you. Thanks very much indeed. And good morning, and thanks for the opportunity to speak to you today. So my name is Andrew Chadwick, and we Connected Places Catapult. It's been really interesting for the last day or so, just hearing about all the different stories about SAF and all the different fuel sources and how that's all going to work, and it's really exciting. One of the things, and perhaps just a little detour perhaps for the next 20 minutes, is looking at perhaps some of the things that will support that. And one of the important things is going to be data. There's a lot of numbers that have been thrown around in the last day or so, and I'm going to throw some data around as well, and some numbers. And it's really one of the things that will be supporting how we report because of the regulatory compliance and everything else. So I'm not going to go into the details of regulatory compliance, but just talk about some of the issues, but also all the opportunities and how we can use data more efficiently, more effectively as we take it forward. Before I get there, though, I've just got a couple of slides about who we are as an organization. That works. So we're Connected Places Catapult. We're based in the UK. We are one of 9 catapults. We're an innovation accelerator. Basically, it's a network of technology and innovation centres across 40 locations around the UK. We're all independent, not-for-profit or private organisations. And the idea is that we all work in specific sectors to help promote, develop UK capabilities, but also working overseas as well. Connected Places Catapult, the one I work for, excuse me, we are the UK's innovation accelerator for transport, for the built environment, and also for cities and for local growth. So we do a lot of work around transportation, how that connects, and also the people aspects of that as well. So we are an expert convener. We bring together government, both local, both national, also small, medium enterprises, so small companies, larger companies, and also academia, so that we can bridge the gap between that innovation and the market. So we can bring those together, we can look at some of the challenges and some of the barriers to the adoption of innovation, so that we can actually scale that up across our communities and towns and cities. And our vision, because we all have visions, is to be better connected places, in particular across the UK. But as I said, we do a lot of work in Europe and globally as well. So that's really who we are as an organisation. So why should we decarbonise? We've already spoken about this a little bit, so I'll just go over this quite quickly. Obviously, global CO2 emissions from aviation have quadrupled since the 1960s. We currently account for 2.5% of global emissions, but 5% of total global warming. There is a difference between emissions and the warming side of things. These figures don't take into account non-CO2 effects. So aviation's share of global emissions is likely to rise as other sectors decarbonise faster. In fact, as we all know, it's one of the hardest sectors to decarbonise. If we were to choose not to decarbonise, which some people might wish not to do, by 2050 we would actually be about 40–45% of global emissions if we didn't stop. Now our emissions, CO2 emissions from aviation, as it says here, has reached 8% of their pre-pandemic peak. So we're getting to that level where we were in 2019. And as we spoke about in the last day or so, is that global demand is going to grow in the coming decades, so therefore we need to accelerate any improvements in the energy efficiency and switch to the low carbon fuels that we've been talking about. Otherwise it will just continue to grow. And I think so far the sector has made little or no progress. So I've mentioned there's no quick fix to aviation decarbonisation. So I'm suggesting, some of the work that we've been doing, I'm going to talk about, is a systems approach across all of this, where we can actually understand what the overall picture is. So rather than looking at specific elements, we look at what everything is, and then we break that down into smaller steps. And then we approach each one of those separately and quickly. So within that, as we're breaking it down, then that becomes a data piece. And so data and digitalization then will have a more significant role to play in how we actually understand what that footprint is, and then we can actually work on that. And therefore we understand more about sustainability. Now, one of the pieces of work that we did recently around airports was looking at mapping and categorizing the scale and quality of data available for monitoring energy supply, the demand, and also for emissions itself. So we broke down, or split up, a typical airport itself into landside, airport terminal buildings, and airside itself, plus also energy supply. And we broke that down to the type of, to the different sections within there, but also what type of emissions, so scope 1, 2, and 3 emissions, took place with each one of those elements. So we can actually start looking at those, determine the responsibility of those, but also what that would look like and what the data behind it looks like itself. What's interesting and what we're finding more and more is that energy is now being a part of what we look like in airport. I think typically a few years ago we probably wouldn't have had the energy vector on there, it would be just really the buildings. Now we're looking more as energy as a part of that. So what we've been doing is breaking that down, looking at all those different elements and then how they relate to the carbon footprint, but also the emission side of things. Now the data from that, as we break it down, obviously there's a number of challenges, and there's a list here. A lot of it is around data availability, so looking at things like what sort of data do you actually need? Do you actually know what sort of data you want and what's available? It's quite interesting when you start looking at this in a bit more detail that a lot of organizations don't know what sort of data they need or where it will come from or who has it, and let alone how they're going to use it themselves. So it's looking at that availability and how you're going to use it, looking at the analytical side of things, so what do you actually need to look at, how are you going to report that, how are you going to collect that information, and then looking at how you can use that then to make data-driven decisions. And understanding the data flows and also identifying and the buy-in of all stakeholders, because as we start to decarbonize and that grows, we're going to have to reach out and deal with a lot more stakeholders than we currently do. And then it's how we visualize that. What does that look like? Is it dashboards? Is it the use of digital twins? There's lots of ways in which we can actually look at those data so we can actually use it for the analysis itself. One of the things that we do in Connected Places Catapult is a lot of work on digital twins. We manage the government's digital twin hub, which is a collection of companies, academia, who come together and share lessons learnt from the development of digital twins, but also we come together and collaborate in developing those twins across infrastructure as well as other types of projects. So we have programs looking at resilience across our water networks, across airport networks, and across the energy sector itself. And so we have a definition that we like to use of what a digital twin is, and that's replicated here, and I'm not going to read it for you. But it's really how we bring together the current state of a system and the historical state and how we model all that and bring all that data together in real time so we can use that for analysis. So we use these digital demonstrations, particularly using digital twins, so we can actually trial and real-time interventions where physical ones are not possible. And that's the beauty of this, where we can bring the historical and the up-to-date information together into these digital twins. Obviously, as the industry, aviation industry, is highly regularized and standardized, there's high barriers to real-world testing. So to be able to digitally test this is actually a really big step forward and something that we're finding a greater use being adopted. Indeed, aviation is ideally suited to the adoption of digital twin technology. And because we're a lot more mature in that respect than others with regards to simulating and lab testing, because we're used to doing it using different techniques and how we develop our systems. And so we think it's a powerful tool for addressing decarbonisation challenges and also for optimizing performance. So one of the things, and just an example that we have of this, is we do a lot of work with Glasgow Airport. We have a partnership called the Connected Airport Living Lab, which is really an opportunity to work with Glasgow Airport to use the airport as a research and development site where we can actually bring these technologies together. And so we've been doing some modeling of the airport operations, looking at emissions, noise, looking at power usage, and using looking at charging aspects as well in particular, so we can actually test the system. We've run a competition last year, which is coming to an end in the next month or so, where we invited a number of, it was an open call, looking at the current state of play really in digital twins in aviation itself. So we created or worked with a number of clients and stakeholders in the airport in particular, where we actually determined a number of challenges and requirements, and we've identified 3 specific areas, so looking at passenger movement, asset replacement, and energy management. And so we had a call out then to industry to look for potential solutions for that. We had over 40 responses, and we down selected that to 5 small companies. So they actually developed those use cases and then put forward a case on how they should get funding so they can develop a digital twin itself based around Glasgow Airport. And the 5 companies are listed there: Consortic Limited, EMU Analytics, Entropy, IES, and Open Space. And as you'll see on the listing there, it varies right across those 3 requirements, looking at things like using drones to digitally map airport and pavements, and so you can look at maintenance prediction and approved efficiency, looking at monitoring aircraft ground movements, looking at digital twin platforms to alleviate terminal and gate congestion, also looking at reduced energy consumption, and then finally looking at the customer experience itself. So it was a real mix of companies, and there was a lot more other, obviously, proposals that were put forward. The winner was Entropy. So even though we're talking about decarbonisation, we're using digital twins here to look at terminal and gate congestion, but the idea of that is it helps to feed into the overall terminal design and ultimately into the actual energy requirements for that as well. The demonstration, so the work is going to finish next month, so in March, and the report on that will be with an example of the digital twin would be on our website at that time. So it's just showing how you can use digital twin technology for that as well. So onto the solution side, and one of the things that we've been looking at and talking about for some time now with the sector is looking at how you can actually effectively share data right across aviation. So aviation, as we know, is we've proposed rather, we're looking at the need for better data sharing is clear, but the solution is not necessarily straightforward because it can take many different types of forms, and there's a risk of over-specifying the requirements for that data, which could lead to unnecessary complexity and also inefficiency. So we're proposing that there should be more centralized, sector-focused and flexible and in particular independently curated and assured aviation data sharing infrastructure. So this would prioritize comprehensive data sharing, bring together cost reductions, and also provide an impactful way to address decarbonisation and sustainability. And we've been doing a lot of work with stakeholders throughout the aviation landscape in the UK, so people like National Air Traffic Services, so from an air traffic perspective, but also with the Civil Aviation Authority, with the Met Office, with airlines and with airports, and also with ground operators. And it's looking on how we can actually bring all the data that they use, that they need, because sometimes they don't know where the data actually exists. So how we can bring that together and how we can share that. And if there's a way in which we can independently share that, which is verified data as well, so independently assured. Not necessarily giving away your commercial secrets or anything else like that, and that's why something more centrally and centrally managed as well takes that into account. We can actually manage it that way. But looking at a way in which we can actually find a balanced approach, which also addresses things like funding, whether that's existing investments by industry and government, but also realities of legacy systems. Some airports we've been working with have one electric meter, just one, and which covers the entire airport itself in some cases, which was quite bizarre. But the idea of this is to have a central repository. And we've had a good response to that. So the idea of it would be a crucial role in streamlining activities. It'd be a single point of contact for data sharing across the sector itself. And there'd be transparent governance, looking at specific use cases and route maps, and also how it can inform legislation. And also the development of a framework of future-proof components, so building on existing assets and legacy technology. And it's also a way to share strategic insights to the market itself. So, with the example with Glasgow Airport, one of the things we've been doing is looking at understanding and how we model airport emissions. We've recognised early on with this programme that there's a need for digital and data-driven automated workflows, so we can quantify and model the real-world airport energy supply demand and also the associated emissions themselves. So we can create that data environment, in fact we have done, that drives the decarbonisation positive private sector investment decisions. It's evidence-led, so work that we've been doing around surface access in particular, where we've actually had a number of, we've been getting data from a variety of different sources, looking at passenger and staff movements to and from the airport for Glasgow, for example, so we can determine not only the requirement, potential requirement for perhaps some more greener, sustainable public transport solutions to the airport, but also looking at what the carbon footprint is to those journeys themselves. So we can actually have that evidence to support that sort of improvement path, the investment itself. And so we have a very good, well, there's a great model which again is going to be reported on in the next month or so on that work. So it's bringing together all that data, understanding where it lies within the scopes as well. And this feeds into a process or a framework we're looking to develop, which is looking at a collaborative scope 1, 2 and 3 framework agreement, which is a voluntary agreement really, because my scope 1 emissions are actually your scope 3 emissions and vice versa. So there's an opportunity here is if we have a more collaborative way of working, we can actually, because I'm responsible for you, you're responsible for me as well in your emissions, but there's a way for us to actually work, to collaborate, to help reduce each of our emissions so we help each other. And so we're looking to see how we actually can do that. And we've had a good response so far from the sector on that data sharing and understanding that, you know, as I said, my emissions are your emissions and vice versa, and actually by working together we can actually reduce those themselves. So it encourages that data sharing and collaboration, and it's very positive. Finally, the use of AI. This is probably going to be the shortest talk about AI. It's obviously we're going through a bit of a hype stage at the moment with AI and people trying to understand what exactly it is. Obviously, we believe it's going to be used in aviation so it can improve efficiency, safety and sustainability. What that looks like yet, I think we're still to find out. But it can process large amounts of data, so we can detect patterns, make predictions, and anticipate risks. So I think there's going to be a lot of opportunities there. Good examples recently, Project Bluebird, which is a collaboration between National Air Services and the University of Exeter and the Alan Turing Institute, which has brought together the first AI system to control selection of airspace. to shadow live aircraft, which has been very successful, so working with air traffic controllers, where they've developed a probabilistic digital twin of UK airspace and using or building on a machine learning system that collaborates with the humans to control the airspace themselves, so it's not standalone. And that's been a really successful way of, and it's been demonstrated and reported on quite recently. We could probably spend the rest of the morning talking about AI, but you're blessed knows I'm not going to. But as I said, it's in the early stages, I think, on how that's going to influence but there's a great opportunity there for the use of AI and how we manage the data, the huge amount of data that we're going to have and see. So that's my presentation. Data is going to be something that will drive forward and help support how we decarbonize the sector itself. I think it's important to recognize that we'll need to share it, and looking at mechanisms in which we can fairly share that, whilst not giving away commercial sensitivities. So thank you very much indeed, and I'm happy to take any questions you've got.
Thank you. Thank you very much for your presentation, Andrew. Are there indeed any questions in the audience? All right.
My gosh.
It's the first time.
Oh, there's one.
Oh, we triggered something.
Hello.
Hello.
I can always ask a question, so I will ask you a question. So with regards to data, I'm also kind of looking at data platforms for Scope 1 and Scope 3. Are you seeing, I'm sorry, I was outside at the very beginning, so excuse me but in case I missed this, but are you also seeing on the kind of SAF front, there are sort of digital solutions that airports, that they can really sort of do that on a voluntary basis?
Currently, airports are not looking at it. We're being asked, some airports are asking us, what is SAF? Which is quite enlightening. Then it's, where do we get it from? How do we use it? Do we need skills? So all the great things we've been talking about, a lot of the airports, a lot of your customers know nothing about it. They just know they've been told they have to have, there's a mandate, they don't know what the mandate really means, they don't know where to get the SAF, they don't know what it means for their operations, how it costs, how they're going to measure it, how that actually impacts their carbon footprint, their reporting, their ESG reporting, because there's no guidance, and it's not clear what that means for them. So there's a reluctance in investing because they understand why they're being asked to do it, but they don't know why SAF is the solution to that. And particularly when there's other things like hydrogen, for example, which might be a better long-term solution. So there's still a little way to go, actually, I think.
Well, if they need any training, you know where to come.
Well, yes. But it is a serious thing, though, is that the airports and some of the airlines are having these mandates put forward, and a lot of them don't really understand what it really means for their operations. Okay.
All right. Thank you very much.
Thank you.
This was our last presentation before a short break. So I invite you all to have a break, but first let's thank Andrew one more time for his presentation.
Thank you. Honestly, I'm always surprised when I see big notes of butter. Biggest 7 minutes I need that.
All right, welcome back, everybody. I invite you to take your seats so that we can start our next couple of presentation and use cases. We will start with a presentation on technological innovation, what is needed and when is it coming. And I would like to invite Maarten van der Graaf, who is a Germany Aviation Policy Officer for the Transport and Environment. Welcome, Maarten, and thank you for joining us.
Great, thank you. I'll just lower this a little bit. So yeah, like my introduction said, I'm Marta. I am Dutch, sound really British because I grew up in England and now work in Germany. So that's my background. A bit on T&E. So T&E, for those of you that don't know, we call ourselves Europe's leading campaign group on transport and energy. But yeah, we're a non-profit, a member-based non-profit. So we have members in 60 members in 26 countries, and we kind of represent, therefore, a wide range of NGO interests. And we're based in Brussels, but have 6 national offices. So yeah, I'm based in Berlin, for example. I don't know how to get this to work. I'm pressing the middle one. Oh, okay, now I'm way too far ahead. How do I go
Maybe
back?
a delay.
Okay, there we go.
All
It's
right.
working. So, yes, so I was asked to talk about technological innovation. So what technological innovations are needed, when are they coming, and what's causing the delay, and most importantly, T&E's bread and butter, policy recommendations. So, first of all, here we go again. I don't know how to, I'm pressing.
Do we have some
there we go.
help? With the clicker is not working.
There we go. I can kind of get it to work now. So we did this roadmap in 2022, basically looking at if we want to reach net zero, then what kind of technological innovations are needed. So as you can see, this at the bottom here, the green part is SAF. So SAF is part of the solution, is not the entire solution. What are the other things? So fuel efficiency improvements do have an impact, and then crucially, this blue section is actually demand reduction. So it's looking at leisure travel management, business travel management, and economic measures. What does SAF actually do as part of that? So SAF's contribution is about 40% in total, with 30% e-kerosene of contribution to carbon abatement and about 10% on advanced biofuels. So the crucial thing that I am here to say is that not all SAFs are created equal. So we basically created this traffic light system of ranking the different kinds of SAF. So yeah, the emissions of SAF can actually really vary quite wildly. So crop-based biofuels we put here in the red. So crop-based biofuels are, from our perspective, the least sustainable type of SAF. In fact, these biofuels can actually be a cure worse than disease if we're looking at palm-based biofuels. And this is because we need to actually take the direct and indirect land effects together. So in terms of crop-based biofuels, that means the indirect land use effects that are caused by agricultural land being turned over to biofuel production and the negative consequences that can have for both the climate, but also for biodiversity and local communities and food prices. Then we have the yellow part of the traffic light, which is used cooking oil and animal fats. Obviously, this is right now where the majority of SAF is coming from. We have this quite nice little diagram of fueling your next flight, a pig. so yeah, that's the animal fat side of things. And then there's the used cooking oil, which, as Nestle said, has been collected from McDonald's, basically. And in Belgium, I guess, a lot of fries are being eaten, and in the Netherlands too, so there's a lot of used cooking oil available. So yes, but there are still some considerations that we have to take into account. There's the limited availability. So Europe already burns 46% of its animal fats feedstocks as biodiesel. So as you can tell by that number, you can't expand the amount of animal fats that there are. We can't just kill a huge amount more animals. Well, I guess we could, but I don't know if that's what we want to do. And so that's, in terms of availability, there's not a huge amount more feedstock that we can get. Then there's competing uses in other industries. I remember a funny conversation that I had a couple of years ago during the time of Refuel EU when I was talking a lot to the pet food industry, who are very concerned about the fact that animal fats, or animal fat specifically, animal fat category 3, was going to be redirected towards sustainable aviation fuels when animal fats category 3 is what the pet food industry actually used to create their products. And if the animal fats category 3 were redirected towards SAF, then actually they would need to start using palm oil, which for them that isn't something they wanted to do for the sustainability reasons. And finally, there's fraud risk. We did a study that was published at the end of last year, which basically looked at the huge amount of imports that are coming from Asia on used cooking oil imports that are coming from Asia. So you can see here, this on the left is a kind of looking at China, Malaysia, and Indonesia. Crucially, what you can see in Malaysia is actually that the amount that is being collected is actually far less than the amount that is being exported, which suggests actually a large amount of fraud. You can't export more than you collect. So that's, quite clear. And in China, our numbers actually did show that it was equal, that the collection and the export amount was equal, but this potentially is covering up their very robust gutter oil use industry. So there's a potential there for the fraud to be coming from China, but we didn't find that in this study. And then the graph on the right is looking at the demand for UCO being much higher than potential supply. One of the numbers we found in this study is that, so Ryanair has a target to use 12.5% SAF in 2030. And actually, if they wanted to meet this target using UCO, they would need all of the UCO available in Europe. So that's obviously not quite feasible when UCO is also being used in road. And yeah, Ryanair can't take all of the available UCO to meet their own target. So yeah, that's just a bit of an insight into UCO, or used cooking oil. And in between, I didn't include this in my slides, but in between, obviously, you have the advanced biofuels. We saw a little bit of this yesterday, what that actually means. So that's from forestry residues, agricultural residues, sewage sludge, municipal solid waste. And this is somewhat sustainable, but also limited in volumes. Crucially, when we're talking about advanced biofuels, we're talking about waste. And waste you can't sustainably scale up waste. So what can be sustainably scaled up? E-kerosene. Sustainable, so renewable energy can be sustainably scaled up, which is why we place, as T&E, we place so much of our focus on e-kerosene. But as we've heard over the last few days, it's not looking good for the market ramp up of e-kerosene at the moment, so I want to go a bit into why that is. So we did this big mapping of all of the e-kerosene projects in Europe. As of 2023. So as you can see, there are really a wide number of e-kerosene projects in Europe. Primarily, the most advanced projects are in the Nordics. So the most advanced projects, I think, would be Nordic Electrofuel, Norsk eFuel, and Arcadia. But we also see a cluster of projects in France, Germany, one in the UK. So yeah, the market is ramping up in Germany, in the EU. The projects are there, but crucially, not a single one of these projects has reached final investment decision yet. What is causing the delay? So at the end of last year, we also published a study looking into what kind of SAF airlines are buying at the moment. And as you can see, at the moment, the grey is biofuels. So at the moment, airlines are really off-taking purely biofuels. The e-fuels, I think there are 13 airlines that are currently committed in some form to e-fuels. But yeah, the contrast is really quite significant. So this is off-take. But obviously, airlines can't off-take a product that isn't there. So we need to also have a look at the oil suppliers. This is a look at the plans that big oil has for e-kerosene or for SAF in general, or actually, if you look, it's actually mostly just fossil fuel. So most of these companies are pretty much only looking into the future for their oil development is purely fossil. And then the tiny pink bars are a little bit of biosaf that you can see, especially from Total and BP, and no e-kerosene. So yeah, you can see these are the companies that are primarily responsible for e-kerosene coming off the ground. So you've got 12, you've got Dimensional Energy, and the HHUE Sasol project, which I'm actually not sure if that's still running or not. But anyway, you can see these are all small companies. And when yesterday I was on the panel with two e-kerosene companies, those are startups. Those aren't the big players yet. I also want to tell a funny anecdote that last week we organized, as T&E, we organized a big event on ESAF in relation to the Clean Industrial Deal, and we had someone from BP sitting on our panel, and the whole event was about ESAF, right? So like, this wasn't an event on BioSAF, this was really targeted to ESAF, and somehow this guy from BP managed to get through the whole ESAF event without mentioning anything about ESAF. He managed to answer every single question, talking only about BioSAF, including what his wish would be for the ESAF industry, which is, his wish for the ESAF industry is that green hydrogen would be used for the co-processing of biofuels. So there's really no interest whatsoever from BP specifically, but also from other oil majors in e-kerosene at the moment. So this is a problem. We need big players to get there eventually. But why aren't they? I think what I discussed a little bit in the break as well is that with someone is actually we need the small players to get there first. The big players will come once they see that this technology is feasible. But at the moment, the small players aren't being provided with enough support. So how do we get the support that's needed to these smaller players? So first of all, at the moment, public funding isn't really sufficiently targeted. So we had the EU Innovation Fund or the call out, which in July 2023, where only 2 of the 41 projects selected were actually e-kerosene projects. And the Hydrogen Bank at the moment isn't really sufficiently targeted for applications such as aviation. So at the moment, it's not actually really providing, at EU level at least, we aren't really seeing the kind of support that's needed. And I've put 2 very outdated graphs that I should definitely update on the pricing, but we all know this, the price for e-kerosene is much higher, so that's another problem causing the delay. Then, I think this is actually one of the most crucial reasons why we're seeing the big delay, and that's the 2027 review clause of Refuel EU. So obviously this is just part of EU law. EU law means that the Commission has to review the feasibility of a law. But the problem that I think there is that because there's this review clause, that actually there's a massive amount of uncertainty around the longevity of these laws and if they actually are going to stay in place for as long as we think they will. And Peter Smeets and Celine Corridas, I highly recommend this article that they wrote called Is Regulation Failing Due to the Reality of the Slow Market Ramp-Up? Or is it actually failing because of this pessimism around the future unattainability of the SAF blending quotas, which is then leading to this kind of, this circle of basically this, crisis, this circle of banks not being willing to support SAF offtake agreements, airlines don't want to support SAF offtake agreements, SAF financing isn't coming because there isn't enough belief, because of this pessimism around the Refuel EU quotas. So, the positive side of things, the policy recommendations. So first of all, policymakers obviously need to make really clear that they are intending to uphold the Refuel EU mandate. If it would be absolutely disastrous for these startups that we've heard from yesterday and that I'm in contact with constantly, if there was any kind of delay or if there was any kind of weakening of ambition or any kind of signals that this mandate isn't, especially the e-kerosene mandate, isn't going to be in place in the way that we expect it to be. Secondly, better targeted public funding. I think we'll hear a bit more about it this afternoon from Project Sky Power, but what we want, especially as T&E, is a reform of the Hydrogen Bank, of the European Hydrogen Bank, to make it look more like a double-sided auction scheme, like H2 Global, for example, so that e-fuels producers can get long-sided offtake agreements, which they need to get the kind of stability, to get the offtake volumes that they need. But then off-takers can get much shorter-term contracts, which are then also covered by contracts for difference to cover the price gap, so that they can then actually have the shorter-term contracts that they want, while the e-fuel suppliers have the security in the long term. And we did a study on this of how much, for example, if we were to use ETS Innovation Fund money, how much of that would we actually need to make contracts for difference work. So we looked at 2 auction periods, the first one from 2025 to 2034, and then the other one from 2030 to 2039. But crucially, what you can see is actually this first auction, the smaller green bar on the left, that actually, if we were to use 25% of current ETS funds, using a contracts for difference scheme, we could actually target 87% of the e-kerosene mandate until 2034. And this would cost 2 billion euros over 9 years. This is a clever scheme, I think, and obviously then in the second auction, the amount covered is less. But the solution for that an extension of the EU ETS, which is something that I am pushing for very hard. Basically, the extension of the EU ETS would mean that the airlines are paying fairly for their emissions, first of all, so that the departing flights from the EU, which aren't being priced right now and should be priced and actually are causing most of the emissions, would be priced. And crucially, this would mean that we could actually use the ETS revenues to cover the majority, pretty much all of the e-kerosene mandate until 2040, which would be crucial for e-fuels producers and also really help airlines out in being able to cover the cost difference. So yes, and back to, oops. Okay, sorry. Anyway, I was pretty much at the end of my slides anyway, so if we could get my final slide back, that would be nice, but the final slide was only to say, okay, I'll click through while I'm, there we go. Sorry for all these technical problems. My final point was basically just to say, where can SAFs actually get us? This is a reality check that we need here. Demand is going to increase massively in the coming years. And here we did an analysis, which is also available on our website, actually to look into if we look at, I think we took Boeing and Airbus's assumptions of how they project the market to grow over the coming years. If we take those industry assumptions and compare them to the actual Refuel EU mandates and how much Refuel EU is mandating, how much are we actually stopping the use of fossil kerosene? And as you can see here, especially in 2049, it's really quite clear to see, actually almost no emission reduction is there in 2049 compared to 2019, even if all of the biofuels are bringing all of the climate reductions that they say they are going to bring, and even if we're sticking entirely to the Refuel EU mandate. And obviously in 2050, the Refuel EU mandate becomes significantly more stringent, so then you have a bit more emissions reduction, but I think, yeah, it's quite a stark reminder that in 2049, we're actually not reducing any emissions if we stick to Refuel EU. So finally, I think that's the point I wanted to end on. SAF is one piece of the puzzle. I made this incredibly ugly little diagram to show that, but yeah, SAF is just one piece of the puzzle. It's also, we have zero emission aircraft, which we heard from this morning, there's fuel efficiency, and crucially, there's also demand reduction. SAF just doesn't actually bring any benefit if it doesn't come hand in hand with demand reduction. So thank you very much, and I look forward to your questions.
Thank you, Marta. Thank you for your presentation. Are there any questions in the room? Can we get a microphone?
Hi, thank you very much for the presentation. I'm Maureen Gauthier from Fourier. I have a question for you. What is your view or TNU's view on carbon offsets? Because you're talking about Corsia, ETS, etc.
Yes.
What's the view?
Yeah, we have done a lot of work over this over the previous years. I think especially back in 2022 when we were looking a lot into Corsia. I think in general we see offsets as mostly a false solution. They don't actually really do very much, especially if we're looking at the Corsia certified offsetting projects. A lot of them aren't even actually helping much at all. They're protecting pieces of land that were never at risk anyway. There's potential for double counting. There's really, those offsets aren't really doing a whole lot. So yeah, in general, we see the benefit that offsets can bring is quite negative.
So you don't see in your puzzle that you showed, it's not part of the decarbonization strategy at all for you guys?
No.
Okay, thank you.
Any other questions in the room?
Yeah, thank you. Thank you for your presentation. If I understood right, one of the proposals is to increase the taxation in aviation to fill up the gap. Why do you make it, I mean, what do you propose such a complicated way, let's say, if not just that the market regulates? I mean, if it is more expensive, we will pay more. And that's it. I mean.
So part of the reason why, I mean, and this is what I mentioned earlier as well, part of the reason why I'm proposing taxation is because we simply need more revenues. If we have more revenues, this contract for difference scheme can literally cover the ESAF, can cover the contracts for difference that we need until 2040 for the whole entire e-kerosene mandate. So like, it's not, money is scarce, and especially in the political climate, in the geopolitical climate that we're in now, it's not like loads of money is going to be thrown around to sustainable airplane options. That's simply not the case. I think that's why we're saying primarily, okay, taxation is fair. Taxation other sectors pay taxes on their fuel, aviation doesn't. So taxation is fair, and second of all, we just simply need the revenues.
I don't think it's the best way, but of course it's a point of discussion, because at the end of the day, if this money goes to produce more fuel, if the airlines have to buy fuel, they will pay more, and the money will go to the producers the same, but in a direct way, not going through public administration and all this costly system that we have. If this is the purpose, I agree with you that aviation should pay some taxes, but pure taxes, like other, but not for this purpose, because for this purpose, I think the market system is much better, but it's just my opinion, of course.
Yeah, I understand that completely. I think it's a difference of opinions, but yeah.
So I'll follow through a little bit on that. We have EU ETS as an example. You have, where's the money going? Where's the money supposed to go, and where is it?
50% of revenues at member state level are meant to go towards climate-related projects.
Meant to go, exactly. Meant to go. So let me share a few things. I know you from far back, and at some point, and maybe I'm wrong, but at some point I still have the impression that UCO was something that you were searching for. There were several studies by the the FAO saying that, in fact, there is a way, and there is a lot of benefit to be gained from agricultural crops. And TNE was always, that is not it. UCO. UCO is that fantasy that now we see why it is that there is fraud being committed, because it has been supported as something that can support an industry, when that was, for me, a fantasy all the time. And now you mentioned the taxation, and we still don't know where the money of EU ETS is going. Supposedly it was going towards building this industry. So maybe that's also something that I would like to say, be careful if that's what you want to tell the world that should happen. And also the mentioning of zero emission aviation, you call it? Unless you measure everything with the same stick and the exact fuel life cycle analysis for the entire thing, it's not going to be a zero emission. So when you go to agricultural crops, you go through the entire life cycle. When you go to an electric aircraft, just whatever comes out of the pipe. So also, just for myself, because I hate for us to see ourselves in the same place that we see today on UCO, that everything was built around it, and now that's what we have. 99.9% of virgin oil with a drop of UCO, and being sold under that premise. It's just my advice, because you are quite outspoken, and people listen to you, but yeah, maybe the terms are not the right ones.
So just to check, so your question is,
Not a question.
But your point is essentially that we need to be careful on zero emission, on using the term zero emission and placing too much hope on that, or is it placing too much hope on e-kerosene, or?
Placing the hope on taxation when we do have it today as EU ETS, and no one really knows where that money is going for. It was meant to, but that meant to is the problem. And yet you just told us that, yeah, you do support taxation.
Of course, and I think part of what I'm proposing here is a way to ensure that ETS revenues are being used in a sensible way. That's exactly what we're proposing here, and I think that I don't hold out a lot of hope for taxation. I also don't think that it's the plaster to cover the whole wound of aviation's climate problem. Not at all. I just think it's one tool that we need, and especially considering I think everyone across the whole sector is in agreement that we need money. Like public money is going to be needed. So I think and we're coming up with a way to make sure that pragmatically these ETS revenues are going to be recycled in a way that actually helps the sector. I think that's...
Yeah, but one thing is you proposing and suggesting, and the other thing is politics and how the money is really dealt with. And Sergi, actually, he understands well where the money goes, where money's taken, and he gets into the administrative process. There's nothing that you can publish that will change that for now. So
no, thank you for your comment.
So yeah, leading on from this question actually, so you've just mentioned public money. So whereas a lot of people think it's going to be actually private funding that does this, and maybe the voluntary market. So what is my question is, what is T&E's kind of strategy or thoughts on voluntary, and also what about the big fuel producers? What is your kind of strategy for encouraging those that are already producing fuels to start to sort of transition their portfolios? Do you have kind of strategic streams of work to encourage that? Of course, I assume you will also work on Refuel EU from a political point of view and EU ETS, but what about the other strategic ways to change that sort of market and transition?
Well, hopefully if the penalties are there, then that provides enough of an incentive for oil majors to start. I mean, if the penalties are significantly higher than any kind of, than actually providing the e-fuels. So
I mean, they're all on track to produce the 2%, more or less. So hopefully they won't need to get penalties because they'll be producing it.
no, when I say this, I'm talking specifically about e-fuels. I'm talking specifically about 2030 and the penalties that could come once the e-fuels mandate actually starts. So yeah, I mean, hopefully the penalties will come, and I think our approach is always like we want to support these smaller producers. And when you're talking about public money versus private versus voluntary, I think yesterday we saw a slide, I can't remember who presented it, but it was essentially looking at at what point is public money needed and what point is private money needed. And at the really early stages in technology, often it's public money that helps those industries get off the ground. And then later, once the technology readiness level is higher, once the belief in the technology is higher, then the bankers and then the investors start coming in. So just a little bit of, I'm by far not an advocate of saying that this whole industry should be entirely supported by public money. That's definitely not my position. But I think to be able to get an industry that's struggling off the ground, you need a little bit of money.
Yeah, so you have a market approach. You think PPPs and then a market approach to scaling.
Exactly.
Okay, thank you.
All right. Thank you for the questions, and thank you for your presentation, Marta. We will continue with a presentation on Power to X and Circular Economy in Aviation, given by Samantha Michaud. She's a business developer management at Ineratec. I welcome you, Samantha.
Yeah, okay. Great. So, thank you for welcoming us. I'm hearing since 2 days all the challenges that we are facing in this world. So I hope to bring you some hope with my presentation about Ineratec, who we are, what we do, and what we plan to do. So Ineratec is a German company located in the southwest, in Karlsruhe. We are a spin-off from the Karlsruhe Institute of Technology, founded 2016, growing rapidly. We reached the 150 fuel time equivalent by this year. A lot to do, very active, but very exciting. So, our mission or the vision we have is to make this planet livable again, to defossilize also the hard-to-abate sectors, and offer a solution for post-fossil energy area. How we do that? So we recycle CO2, combine it with green hydrogen, CO2 from any sources. So we are CO2 agnostic, technically seen, so we can use the CO2 from point source, biogenic, industrial, or atmospheric. Of course, the biogenic one is the favorized one in Europe. But green hydrogen is the mandatory condition. So we are not using any blue, gray, of course not. We combine this and turn it into, the first step is a syngas, and then with the to replace one-to-one fossil fuels. So our fuels can defossilize hard-to-abate sectors or the transports of aviation, maritime, but also long-haul transportation, automotive. Ineratec is primarily a technology provider, but we are also the e-fuel company. So we establish ourselves as a fuel producer and also supplier, delivering any kind of fuels. So e-kerosene, e-diesel, marine diesel, also methanol, and gasoline in some way for customers who desire it. We produce chemicals, so waxes, which can be used either to produce SAF, but also in the chemical industry as a byproduct. And we shortly discovered that waxes have a high potential in the food industry. We have, for example, a customer in the US. They are using the waxes to produce vegan butter, so synthetic butter. And indeed, it's working, and it's nice to see this cross-sectorial application of our products. Particularly, well, the waxes have a very, very broad application segments. Our Power-to-X plant, so it's our proprietary technology. So we develop our own power-to-liquid and gas-to-liquid module, which allows to turn the syngas into long-chain hydrocarbons, synthetic e-fuels. So from the value chain, Ineratec decided only to be active on the downstream value chain. So we look after the synthesis, but also the upgrading and deliver directly to the customers. On the upstream level, we work with partners because we believe actually in the value chain cooperation. So we do not produce the hydrogen ourselves, we do not capture the CO2, we are acting as an off-taker, principally. This allows us also to de-risk the whole project, because by cooperating with strong partners, this way we leave the other fields of expertise to professionals, and we concentrate ourselves on synthesis and upgrading. What is the USP of our technology? I mean, Fischer-Tropsch reverse water gas shift exists since hundreds of years. It's nothing new, but we made them compatible to renewable power. So our technology or reactors are modular, microstructured, which allows to be smaller, more compact, and highly efficiency, and also to cope with the typical power irregularities, which is known with renewable power. So we can actually keep the synthesis operating at a very minimal load until 30%, which allows us to keep producing and not to have to switch off completely the plant if we don't have any supply of power for the plant. Another advantage of this, by being modular and load flexible, we can actually adapt the capacity of the plant in alignment with the site development. So, for example, big challenge today, still today, in some place the CO2 can be a bottleneck because the carbon capture units are not operational at this time. The transport of CO2, how we to purify it, because of course we have certain purification recommendations which are depending from the catalyst that we are using. But hydrogen is a big bottleneck. I mean, this is the truth today in Europe. It's a big bottleneck. And related to this, I mean, we have projects, they are project planned with 300 megawatts towards gigawatts. This is amazing, but the electric connection is not there yet. So this is a big bottleneck as well. So the solution is to start small and upscale. And this is what we can do. That's why Ineratech technology is so interesting, because we can start small, relying on the availability of feedstock. And as soon as I have more hydrogen available, more CO2, I multiply the number of reactors and module following a numbering up approach, which allows me to scale up very quickly, and then I can target higher capacity, production capacity this way. So, scalability, big topic. So we started with a research demonstration plant in Finland. That was our very first plant with VTT, where we produce e-fuels based on biogenic CO2 and green hydrogen. Then we developed our first industrial plant, which is the equivalent of 1 megawatt electrolysis capacity, so with which you can produce 300 ton e-fuels yearly. And now we are about to start the next step, which is the commercial plant. Probably you heard about it, the pioneer plant of Ineratech in Frankfurt. And I'm really happy to be here to tell you that the production is starting in the next weeks. So we will be producing 2,500 ton e-fuels yearly. Of course, it's nothing, but it's also a lot for this type of project, of plant. It's a big pilot. It's still a pilot. It's still a demo plant. So there we are demonstrating the upscaling of our technology, because the reactors who were in the 1 megawatt plant were smaller. So we developed a scalable module, a scalable reactor size that will be then multiplied and numbering up in the bigger plants. And this is what we are demonstrating in Frankfurt. Frankfurt is a blueprint showing that the technology is working, is scalable, and that we can produce e-fuels in Europe and in Germany. So we work, of course, to the next step, which is already the commercial rollout, so the big plants. We are currently developing the 100 megawatt concept that should be actually targeted in sweet spots like Chile, US, Australia. So now, Frankfurt. So Frankfurt, why Frankfurt? Why Infrasurf industry park? It was an ideal brownfield. We had the hydrogen from a chloralkali electrolysis. I start with the CO2, first the CO2, biogenic source from a biogas on site. So they are capturing it, they are purifying it, and I get it directly with the piping system, directly delivered on my site. So the CO2 biogenic is secured. The hydrogen was a byproduct from a chloralkali electrolysis, from a chlor production on site, and they were burning it. They were just burning it because they were not using it. So we said, ooh, we would like it. And we could get, of course, an attractive price, because the hydrogen coming from renewable production is always depending on the OPEX cost, high OPEX cost, and you get quite a high price for hydrogen. But using the hydrogen from a chlor production, which is a byproduct, then you can handle a better price. And this way, of course, because the price of e-fuels is depending up to 70% from the price of your hydrogen and your electricity. So this is, for example, the chlor production in Frankfurt. The hydrogen is green. We are currently undergoing the RFNBO certification with ISCC. So we will be producing RFNBOs in Frankfurt at the end of this year. Well, actually, the crude will be already produced, this starting the next week. But the next big news is that we just secured 70 million fundraising from the EIB and the Breakthrough Catalyst to invest in our upgrading module. So I'm happy to tell you that at the end of this year, we will have the first drops eSAF coming out in Frankfurt. So this is, of course, a big milestone that we are reaching. We realize that if we want to produce SAF or E-molecules, drop-in molecules, we needed to invest also in the upgrading, because co-processed fuels is at the moment not an option if we want to address the mandates. So this way we can offer 99% CO2 neutral eSAF, because the whole CO2 amount feedstock being used in the production process is fully recycled. So it's exactly the same amount which is being emitted when you are burning the fuels in your motor. Frankfurt was the first step, but like I said, we are looking at the globalization, at the upscaling, and we started also to see, okay, what do you have to look at when you are defining and qualifying ideal sites for the production of e-fuels? So we did this study. I think I'm complementing also with the colleagues from Hydrogen. When you look at the site, you have to be sure, is it an industrial site? Can you build a chemical plant there? Most important, of course, the feedstock. I'm not going to build a plant when I know that my CO2 is more than 500 kilometers away. So usually we try to establish always the plants at proximity of the CO2 sources to limit the transport. For the hydrogen is the same, except that if you have an access to water, I mean, you can easily install an electrolysis, but for the CO2, it could be a small problem if you don't have any pipeline already in place to transport it. Electrical system, very important. We have been actually analyzing this, and I know that some projects, they just unfortunately, they did not come to an end because of that, because the electric connection was not ready to install a 300 megawatt electrolysis. So there are a lot of constraints or challenges on the site aspects, which sometimes have nothing to do with your own technology. Also, what the balance of plants. When we are seeing the balance of plants, you know, the thing is that you need to make sure that the standard technology that you need in your periphery are also adapted to your innovative technologies. And all of this we have learned it with Frankfurt. We managed to cope with those challenges, and now we stand shortly for the production. So probably you heard about it. We are very active in Chile. Chile, one of the front runner when it comes to renewable in the world, sweet spot. So we did indeed a feasibility study to assess also the feedstock availability in Chile. And this is interesting. When it comes to CO2, it's quite well shared. So in the north, you have a lot of CO2, industrial CO2 coming from the mining industry, and the biogenic CO2 sources are mainly located in the center of the country. And in the south, you have barely CO2. So this is a big challenge. This is also a big challenge that HIF also is facing in the south. So Chile offers, of course, if we want to do RFNBOs in Chile, the central region might be the dedicated one. There is also huge initiatives now to produce green hydrogen, because Chile considers itself as a potential green hydrogen through ammonia, of course, exporter, but also producer. As you can see here, we have also mapped the green hydrogen projects that are at a more advanced level of development. They are not so many, but things are moving quite quickly. So on the regulatory aspects, Chile is also evolving a lot. Yeah, but of course they still need sometimes to get there where we are in Europe today. So we have identified 10 potential sites in Chile that are dedicated for the production of e-fuels. As you can see, the most of them are in the center, of course, favorizing the biogenic CO2 source. And now I would like just to show you a video. This is our concept of 50,000 ton e-fuels production that we have developed for Chile. And just the technique will be running the video. So we imagine a complete concept where you have all the module combined, not only the synthesis. Here you will see, for example, the synthesis is not in containers. This is also on purpose, because 145 megawatts, you have a lot of reactors. So to ensure a maintenance concept, you need also to move the reactors, and this could be very difficult in a container. So from design perspective and maintenance perspective, we have decided to have, for the bigger plants, they might be actually in fixed construction, building or a metallic construction. This will be depending on the site where we establish. In Eratec, rely on a very strong partnerships on customer side, but also on investor side. We have just secured, well, just no, but the beginning of the year we secured our Series B fundraising with our lead investor, PIVA, which is who is actually the investment branch from Petronas. But as you can see, a lot of American investors, however, a lot of European ones, but all strategic CVCs who are opening the market for us. We are proud to make the difference, and for so I thought maybe it's nice, I just brought you a small bottle of e-fuels. Yeah, you want to smell it, how it smells when you smell clean e-fuels, clean Syncrude. So I will let the bottle going out. I just need it back. So not drink it, only smell it. But you will see, it looks like water, but it's not water. Then you can smell it. You have, take care, yeah. So in that time, I'm open for question.
Thank you very much, Samantha. Very curious now about the smell of this fully clean fuel. Are there also any questions for Samantha? Yes.
Of course.
Now it's on. In your process, do you? I didn't see it, but maybe you do because it wasn't worth mentioning. Do you use a lot of water? Do you need water at all?
No.
Okay.
No, it's only for the hydrogen, and also most of the energy that we need is for the electrolysis. It's not for the synthesis. Doesn't need so much electricity, not so much power, because we have a lot of heat coming from the reactors, so this heat is being recovered. We managed to have a complete circular system within the synthesis that allows us to use any energy flow which is coming out from the process being recycled.
Okay.
So from the energy power, it's the electrolysis which is the high.
But I didn't ask about power. I asked
No, it
about
said water.
Water. Yeah.
Water. Yeah. Water.
So do you use it for cooling or anything?
So no, we use it to cool some reactors,
Okay.
but you use it also because how to turn the gas into liquid, you need some water.
But
So-
you wouldn't call
but
it a water-intensive industry? Okay.
No.
All right, thanks.
No, and even we can recycle the water that is coming out, so the wastewater from the process
You
can
can
be recycled to be resent into the electrolysis to be used to produce hydrogen again.
Okay. Thanks.
Thank you. Any other questions in the room? Oh, yes.
Yeah, thank you so much. This is Stavros from Halle University. Actually, I wanted to ask about the CO2 capture. What kind of technology you use? What is the point source?
Well, in Frankfurt is
In
the
Frankfurt, yeah.
biogas plant. So it's a
Okay.
biogenic point source. Yeah. And for example, in our industrial plant in Welte, for our customer atmosphere, they are also taking CO2 from a point source biogenic, but they have integrated a direct air capture module in the plant. So they are capturing both. And for us, it's the same because the CO2, before we take it, it needs to be handled. So it needs to be purified, and as soon as we have the required quality for the CO2, we can feed it into the synthesis. So the pre-process is actually on charge of the CO2 emitter or producer.
So are you using a conventional amine-based or membrane?
This depends. This is not the way how we are not looking at this. This is we provide the CO2 purification requirements to the CO2 emitter, and they have to, if they want to sell the CO2 to Ineratec, they need to cope with that and to prepare it. So we are not looking after this part.
All right. Okay. Thank you.
All right. Thank you very much, then, Samantha, for this very insightful presentation. This brings us to our next, I was going to say presentation, but this is a panel discussion. It's a panel discussion on efficient airline strategies for carbon footprint reduction. And this panel will be moderated by Domiana Serafini. I hope I pronounced that correctly. She's a senior manager of sustainable consulting at IATA. I invite you and the different panelists to come to the stage, please.
Do we have one for each, or we share? We share.
We have no.
Como quieran, however you like. Okay, so we have three, and we'll share the microphones. So we have a panel discussion. We want this to be a collaborative work, so we are asking you to participate. And with that in mind, we would like to know who is in the audience, right? So first of all, we know who to speak to and how to speak to you. And then to understand what questions may come from you or collaboration, right? So maybe a hands up would be best. And then we'll go through introductions so that you know who we're speaking to in the panel. So producers, fuel producers, SAF, whatever fuel you produce. Great. Get your hand up, so we know who we're speaking with. And then airports, aircraft operators, fuel suppliers. There we go. NGOs, research and development, academia, and who else wants to say who they are that I just didn't call? Aggregator, that's right. Yes. Finance. Perfect. Anybody else for finance? No? Okay. And you wanted to say? Okay. Well, airports will yeah, we'll get you in that category. Yes. Okay. Technology providers, I must say, or technology. There we go.
Yeah, we're a solution provider, so software.
Okay. Wonderful. Okay. Anything else? Anyone else? All right, we'll move on. So we have 4 experts here that are going to have about 40 minutes for us to speak. We'll go introduce each other. Introduce each other, no. Introduce yourself so that the audience know who they're speaking with.
Hi, I'm Andrew Thomas from VistaJet, Director of Sustainability, working with the company for the last 12 years.
Hello, everyone. Maureen Gauthier. I work for Foyer. We're a solutions provider. We help companies with sustainability strategies.
Hi, Jeslo, Sky Energy. We're a sort of SAF supplier, project developer, advisory, all-round SAF expert, I suppose.
Hello, I am Sergio Alegre. I'm Director General of Operations Council. Sorry.
So, one of the things that we wanted to start with is, because we have Andrew here and Maureen, they know each other very well and they work together quite well, and also with Sky Energy, is we'll do a small intro of what's the difference between business aviation and commercial aviation, because that will take us to the next conversation point, which is refuel EU and the impact that it has had during the first 2 months. And there is a difference between those two subsectors between the aviation industry. So we'll start with Andrew and Maureen to give us an idea.
Yes, and sorry, just to clarify, so we provide solutions mostly for business aviation, which is why I'm relatively qualified to talk about business aviation. So business aviation, any idea, anyone in the audience, what the difference is between business and commercial aviation? Yes, on demand. On demand, that's really the main difference. On-demand aviation is business aviation. Something really interesting is if you look at an operator, so the airline of business aviation, the average amount of aircraft that they operate is usually 1 to 2 aircraft. So that's just to set the scene. It's much smaller companies that has an impact on the SAF negotiation that we can talk about later on, because obviously when you negotiate SAF for 1 or 2 aircraft, it's completely different to negotiating SAF for a fleet of 100 aircraft, for example. But in addition to that, the companies are usually pretty small. So usually the CEO will also be the HR, who will also be the accountant. So sustainability is usually not a full-time job. Usually it's outsourced to companies, which means that when new regulation comes in, it is proper chaos because they don't have people in-house that are actually following the regulation. Refuel EU is a typical example that we can talk about later on. But I think those are the 2 main differences in this context, SAF bargaining power and the ability to adapt to new regulation quickly.
No, I'd completely second that as well. I think the main difference for us as an aircraft operator is we've got flexibility. So we operate in 2,400 airports around the world. So we cover 96% of the globe. Think of us as almost like an unscheduled operator. So that's the biggest difference for us as well.
Great, thank you. And one of the things that I also wanted to point out is you guys respond to a client right away. You're not scheduled per se, so you act fast, and that also has implications in how Refuel EU has is set and how you can handle or not the exemptions that have been given that maybe you're excluded because of the business model. They're different business models. They do fly an aircraft and fly people around the world, but different business models for sure. So for Sergey, when it comes to airports, do you see a difference between your clients? You have a client that is business travel, you have a client that is commercial.
I mean, well, before to answer you, if I may, I think it's important to underline, because I think I'm the only representative of somehow airports during these 2 days event, very well organized, that it's the first time that airports are really getting on the game. I mean, if you see it from outside, airports could say, well, it's your business. You want to fly? Fly. I put the tube. Now I put the tube for camions, for kerosene. That's it. You will move different liquid. It's not the picture. I mean, it's not the general picture, but there are a lot of airports, Schiphol, for example, not to go very far from here, okay? They are already founding that the islands use SAF, but they should, in principle, from the market point of view, or the business point of view, they should not. Or the same Heathrow. The group ADP, Aéroport de Paris, what is much more than bigger than only Charles de Gaulle and Orly. I'm proud to be member of the advisory board. They are spending money, they're investing money of SAF producers because they have realized, or they think there will not be SAF enough, and they want to incentivize and to support and not just to, let's say, criticize or claim or whatever these verbs you can use. So going back to your question, in fact, it's the same. Well, there are two, let's say, there are regarding business aviation and commercial aviation. We were commenting before during the previous coffee, that there are only a few, but there are. And they have to be underlined because they are the most important. Some airports like Le Bourget in Paris, that they are, yes, business aviation. They are very important for the sector, the business aviation, but the vast majority of the airports, as you know, they have commercial aviation and business aviation, or general aviation, let's say. Well, business aviation is part of the general aviation, to be very precisely, to be very German. Don't get upset. I love Germany, if there are Germans here.
Okay.
So the point is exactly the same. Okay.
And maybe later on we'll let Jess tell us a little bit about his business and the differences. But later on you can tell us, now that you brought it up, this is not their business, yet they're getting into it, right? Are we talking about their interest in local air quality? Oh, that's not good enough. And we're talking about diversifying. They know they saw what was coming with COVID. They completely shut down, and if they didn't have any other business within the airport, maybe they're starting to diversify, and they say, let's get into this because this is coming. Or
okay, I think you have to ask. This is a good question. I think in general, aviation. I'm involved in this business or this sector for a long time, and mainly in Brussels. I can talk a little bit with more knowledge about Brussels. 5 years ago, there were still people in the sector talking about the Swedish girl, I will not name her, as the bad girl of the world and against anything regarding sustainability and green aviation. This time is, thanks God, is off. So I think all the sector has realized, or it's green or there will not be aviation. I know it's really a big title, but let's say it like that. They have realized, all sector have realized, we must move green as fast as possible as our pocket let us to go there. And I think airports, even if, as you mentioned, they are not really the guys who burned any type of energy to move something, they have realized that. Of course, in their calculations, even if it is an indirect result, the economic idea, it's important.
Okay, great, thanks. Jess, tell us a little bit about, for your business, what's the difference between having a business aviation client, corporate client, commercial client?
Yeah, thank you. So yeah, just a bit of background on Sky Energy, and we're a project developer in a big way. So we've got 3 projects in development, and of course the Refuel EU mandate is a big supporter of that in terms of investment. You know, it's investment certainty for those kind of projects. So HEFA, RNG to SAF, PTL for the sub-mandate, those are the kind of things that we're working on. And we use that expertise that we've developed there to channel into our sort of advisory services, things that we do in our sustainability side of our business, in the policy side of our business, looking at feedstocks. But in reality, we're a SAF supplier, so we're supplying SAF today. And we're largely doing that in the voluntary market. So we currently aren't supplying volumes for the mandate. We do look at Corsia as well, but it's largely voluntary. So I think that's kind of my role today, is kind of to be that voluntary, talk about the voluntary side of the market. Definitely, differences between the sort of commercial and business aviation. When we talk about commercial in the aviation space, on an airline side, we look at scopes, scope 1 and 3. If you're looking at a voluntary purchase, you only need to purchase scope 1. You can share the costs of the SAF premium with a corporate client. When I talk about corporate, that's a business that's looking to reduce their business travel emissions or their air freight emissions, and that will reduce the cost of the SAF premium for both parties. So we can split those costs. With private jet, we have to keep those together. Similarly, under CORSIA, if you're looking at CORSIA, you have to keep those together. You can't split that scope 3. That's the major difference, if I'm honest. Other than that, we don't we don't differentiate too much beyond that, I think.
Yeah. Yeah, thank you, Jess. So, okay, let's take off with Refuel EU. Andrew, you can give us a start on, for 2 months already, what has happened? What have you seen? What are difficulties and the benefits that you have experienced as a business travel company?
Yeah, I'll try and keep it light because I could spend all panel talking about this. But I think look at the positives, and the EU have been saying this with the argument against carrot and stick for the last 3 years. We're all probably bored of that conversation. It's proven true that actually the mandate has helped. It's good. There's a mandate in place. Is it perfect? No, but at least it's a mandate, and it's a good thing for the industry, I think, to be honest with you. It's been tricky because one of my biggest concerns, a small concern, is it's going to affect the voluntary market, because I think some people may just go, okay, we'll just do the mandates. For us, mandates aren't sustainability. It's good for the industry. It's good for investment. I mean, we started off with SAF in 2022 with 200,000 gallons. Last year was 4 million gallons on the voluntary side. And that's good because it allowed us to incorporate Refuel EU without any problems really, because you've already got the system in place. But the pricing with Refuel EU is very different than the voluntary side, and you don't get a choice, and you can't use even the voluntary SAF that we pre-purchased. You can't use for you still get charged Refuel EU, which is frustrating. But like anything, it needs to obviously have the irons kinked out of it.
So that's one of the things that we talked about yesterday as well. And Daniel talked about, mentioned it, but he said that he was not going to talk about, which is the premise that the bargaining power of the airlines maybe, or it's a little bit shut down now with Refuel EU and the non-tankering. But I think that Maureen and Jess can also tell us about a little bit of this.
Yes, and just to take a step back, so if we take the operator side, so the airline side, there's 2 obligations under Refuel EU: reporting and anti-tankering. Reporting for business aviation is pretty tricky because, as I said, tiny teams, reporting from 2024. So the deadline is now for 2024. We don't have a very good bargaining power as well at the local CAAs, unlike certain airlines. So there are no exemptions, so yeah, we really have to start with the reporting on all of the fuel uplift from 2024. So that's already quite a big challenge from an administrative point of view. And then you have the anti-tankering, and that's the main topic in business aviation, because as Andrew was saying, we fly everywhere, we're on demand. We have, now we can have a flight from Schiphol to, I don't know, Madrid without having any idea how long the aircraft needs to stay in Madrid before going somewhere else. This is an issue for the tankering. The tankering in business aviation happens for a reason. It happens for an operational reason. We have no idea where we're going to go. When we land in an airport, we don't fly back half an hour later to our origin location. So we're not able to plan the flight routes like airlines are doing. So we need to tanker for those operational reasons. We can't stay overnight. Typically Athens is one of the huge ones. We can't stay overnight, so we need to fly out again. But when we do send those applications for exemptions, that's an issue because we don't know where we're going to be flying out of. We don't know the route. So yeah, it's a huge nightmare because it's a route-based exemption. That doesn't work for business aviation. So we're doing a lot of work together with the EBA to try and change that, to try and move it towards an airport exemption rather than a route-based exemption. Because again, we don't know, especially in 3 months' time, which is when you need to start applying for the exemption. We have no idea what our flight routes are going to be. So those are two of the points, I think, that are pretty burdensome for business aviation.
So we have willingness, but yet very impossible to
100% willingness,
yeah.
100%. It's just, in those busy times, it's just logistically very, very difficult to do. And we're not really considered in the European landscape because we're such a tiny part of business aviation, plus the image, plus, we all know the negative image of business aviation. So it's really difficult to get our voice heard, even though we are part of the ecosystem.
Yeah. Anybody has any comments or wants to pitch in? Yes, sir, please.
Thank you. Andrew Charrick from Connected Places Catapult. So as the largest polluter of aviation emissions well, globally, do you think that the business community should actually be having a higher mandate for the adoption of SAF and potentially hydrogen?
So he will answer, Andrew, but let me the whole time we've been saying that it's not that there is no willingness to comply, but that they're being forgotten. They're not being included. So they can't comply sometimes because of the restrictions that they put, like the 3-month period that you need to request for an exemption because you don't know where you're going or what your flight route is. You don't have a flight route like a commercial aviation. Andrew just told us that they increased their voluntary purchase of SAF greatly through the years. So I don't think that this is whether they should be being charged more or having something more stringent to them. Whatever exists, they're not even able to comply with or asked to comply with. So I think we're going from that side. I know whether or not they need to pay more or less, but today they're willing and they're not allowed to. They're just it's not facilitated for them to actually do it because they have a different business model than the commercial aviation. But Andrew can correct me, maybe.
No, it's completely right. We already do pay a lot of taxes. We don't have any free allowances on ETS. So we already do. There's the solidarity tax coming into France on Saturday. That could be up to 2,000 euros per passenger. There's the Portuguese tax. There's another 3 in France. There's 3 in Belgium. So it's APD's doubled in the UK, right? So we are taxed in industry heavily. Not to complain about it. It's just fact. But as I mentioned, for me, I don't look at mandates. Mandates is the bare minimum. We're already going way over and above the mandates. So I'm not waiting for someone to decide, okay, we need to do more for business aviation, because then, quite frankly, if I was another operator, I would just wait for the mandates to pop in. For us, we're going way above and beyond the mandates. So we're ready for them if they do come in.
It's not necessarily the case, though, for other companies as well, though. I mean, it's good if you're doing that, but there are other companies who are definitely not.
That's a question for them. I'm going to be very careful about this, but no, I mean, I want to project positivity on our side because a lot of these conferences I go to, it's all doom and gloom. You know, the Intertech, I can never get that name right, sorry. But it's nice to hear positivity. You know, we always talk about, well, we just heard from TNE that there's no feedstock. Well, great. We've used up all the waste oil. It's fantastic. That's a good story. There's an oversupply on the market now of SAF, so it's incumbent on all of us to use it. So I'd rather concentrate on our positive attributes rather than kind of throwing shade at any competitors or anyone else.
If I may jump in there as well, I think we talked a little bit about operational points. We're starting to come more onto kind of the market and the impact on that voluntary market. I think what we've seen certainly as a result of Refuel EU is very much a wait and see attitude from commercial airlines, sort of segueing towards commercial as well, but also in the private jet space. And I think the primary focus is on meeting the mandate. People want to make sure that they can meet that mandate, and so they think, okay, well let's just hold our horses and see what happens in that space before we then dive into voluntary. What we've also seen is a number of airlines either taking kind of two different attacks, I suppose. One is they're really being active, going out, finding their own supply of SAF and making their fuel suppliers use that SAF. The other side is we don't want anything to do with it. And I think what we're starting to see is already significant surcharges, 2 to 5 times the actual price of SAF being put on some of the airlines and potentially private jet as well. And I think what will be interesting to see is towards the end of the year, if people are, someone mentioned, I think, if people are in fact on track to meet that 2%, but what if they're not? And what happens to those penalties? I don't see the fuel suppliers taking those penalties. I see them passing those on. And that could have huge impacts for the airline space and a consolidation of that space.
Thank you, Jess.
I've got one question, if that's all right.
Yes, Sarah, yes.
Hi. Maureen and I know each other because for a European Business Aviation Association, I've been part of writing the sustainability standards for the sector. So it took some time, and it's good that things are now we're launching and things like that. Obviously, we had the pandemic in the middle, so but of course it was early stages for business aviation. Now I have heard some stats from Victor, and they said something like 20% uptake. All of their customers are uptaking SAF by 20% at the booking engine stage. What's the kind of feeling at the moment? Has there been progress? Do you see acceleration? Is voluntary good? Are people asking for it? What's kind of that general feeling at the moment?
Yes, and thank you for that question. I think in business aviation, it's pretty interesting to separate corporate versus individuals. We see much more action on the corporate side because of the ESG requirements, the reporting, etc. On the individual side, it's a little bit trickier. It depends where the person is based, where the pressures are coming from. So I think it really depends. The statistic that you mentioned, yes, Victor does talk a lot about it. So they say 1 in 5 aircraft flights are using SAF. Great. Those are charter flights, so those are not people that own the aircraft. They're just flying for destination to destination. What I can say, what I've seen at least in business aviation, is that when they do uplift SAF, they don't uplift 1 or 2 or 3%. They go to 20%, 30% of blend within the fuel tank. So that's pretty encouraging. I'm not saying everyone does it, but when they do, they usually uplift much more than airlines in that front. So again, it's really a differentiation between corporates and individuals as well. Corporates are leading the way 100%, which is great. And yeah.
If I can add to that, I think on the corporate side, we see significant increase in uptake, and it's about education. I think that is one of the positive benefits of Refuel EU, is outside of the aviation landscape, it's just brought the idea of SAF to a lot more people. People starting to understand that this is something that exists, first of all, and then actually it's something that they can get involved in. And I usually say, 90% of my job is about education and telling corporates that, they can get involved in this. And I would encourage everyone in this room to consider that for your own business travel. We also have our own tool for individuals to purchase SAF for their flights. And of course, you can do that with lots of airlines these days. But I think from the various stats I've seen, between sort of 2 and 4% uptake. But I think that also includes things like carbon credits when you're ticking that box in the flight booking path. But I think in general, the Scope 3 uptake is definitely growing. We see a huge potential for that across the globe now.
Now, by chance, and this is just trying to understand voluntary and mandatory, right? So you're definitely seeing growing. Do you think that because you have now the mandates, maybe that's going to shrink a little bit?
Yeah, as I say, I think on the corporate side, it's only growing. On the airline side, as I say, there's a wait and see approach that people are taking to wait to fulfill that mandate. But now that we're sort of coming towards the end of Q1 already, which is crazy, people have kind of got their contracts in place, and it's now giving them a little bit more headspace to say, okay, what should we be doing? Lots of airlines have 10% targets by 2030, for example, the One World Alliance members, and others, in Asia Pacific, they're looking at a 5% target by 2030. So it's now about when do we start that process? And of course, my answer is now, but that's not always what we see happening in real life. So we are expecting that, by 27, 28, many more airlines will be looking at voluntary purchases beyond their 2% or whatever it is at that point by 2028 to meet those targets outside of Europe. So instead of you might have 2% in Europe, you can do 2% for your global emissions.
Okay, great, thanks. Yes, Sergey.
Yeah, thank you. For sure, looking from outside, a little bit from outside, let's say, I have the feeling that they will not go down, they will go up. I mean, at the end of the day, corporations, they have to make reports and they have to a public opinion around them. And of course, for good or for bad, we know all of us that business aviation is one of the key main targets, even if the contribution to the CO2 climate change is not high, but life is as it is and as it looks like. And for sure, cooperation, because, well, I collaborate with some of them, they have realized if we want to keep this type of flights that we consider that we need, because in fact they need it. They don't want to pay a lot of money, if I may say, and they don't want to get business aviation. They don't want even to fly with Vueling if not necessary. So if they consider necessary, and they consider necessary to have their own private flight directly for saving time, they're going to. I think they're going to be the first ones to arrive to 100%.
I think if I can just add on that, I think if we waited for corporates, sorry to go to your original question, if we were to wait for corporates to catch up, then we would be a lot further away than we are. So for us, we launched the SAF initiative before the corporates even asked for it. And then we educated the corporates, because even in our own industry, if I say, in aviation, SAF is still, a lot of people don't know about SAF. You're still going quite basic conversations, even within aviation. So we're not waiting for the end consumer to be completely au fait about the subjects. I don't think they ever will completely, especially now with eSAF coming on board. But with the mandates, not just Refuel EU, you've also got CSRD coming into force this year and last year. And that's making everyone report in a more transparent way. So therefore, actually, that can probably help the SAF market, I think, personally. But we'll see.
And just to give a tiny bit more perspective as well, I don't know, I mean, for smaller operators, it's difficult. It really is, because you have mandates coming in, and then, so you have all these obligations that cost money. Even if it's just reporting, it still costs money. And then you're asking, especially in business aviation, we're asking them to go voluntary. So to buy SAF, even though they have no obligation to do so. So it is a fine balance. It is tricky to do, because the administrative burden is just so huge that they just want to get on with flying and transporting passengers from A to B. So it is, and that's our role as well as an industry and as a company, to try and educate as to the importance of decarbonization.
Yeah, I think one of the things that that I was always keep in my head is what happened in these first 2 months on the surcharge that we saw in SAF. That, I don't know you, but I wasn't expecting that. I wasn't expecting this huge surcharge. We know SAF is already more expensive. We were all getting ready. We have to pay for it. That's it. It's coming in. As a EU ETS, as an airline, my obligation is EU ETS. Do I have to use SAF? Not necessarily. I have other options. But Refuel EU is giving me SAF, so I might as well use it. It's there, right? But now if there's this huge surcharge, a mandate surcharge, that we still have to explain why is that there, right? It was discouraging, quite discouraging for me, meaning, you know, we were all getting ready for this Refuel EU, and what is it going to do with the normal situation? But now we have this other situation that, yeah, somehow the airlines, small, big, business, commercial, we are the bargaining power on fuel purchases, whether it's SAF or whatever it is, it's being taken away. And I think that is what actually took a little bit of my hope away of, no, this is going to take off. It's going to move forward. I'm glad that you're positive, that all three of you and Sergey as well, you remain positive. We still have to see, because yeah, that was my main concern. That was my main concern.
And it's also exacerbated by the fact that there's no book and claim. So you're arriving at an airport and you have to uplift the fuel that's there.
Exactly.
And when you don't have a bargaining power like in business aviation, it's really difficult to do. First, there has to be SAF. We don't fly to the airports where SAF is easily available to us. But in addition to that, we need to negotiate the pricing for 1 or 2 or 5 or 10 aircraft, or 100 if you're more than 100, if you're a big operator. But it's a tricky thing to do. And I feel like, I don't know if you can say that in English, we're being put sticks in the wheels in French we say.
Yeah.
So we're trying to go, but someone's putting the stick
On a bicycle wheel, right?
bicycle wheel. Yeah, on the
Yeah,
bicycle
well,
wheel.
if
Yeah.
anybody
Exactly.
experienced that, yeah, that's a big problem, a stick on a bicycle wheel. Yeah.
Because we want to uplift SAF. First, if it were available, then we need to negotiate the pricing, and without book and claim, it's super difficult to do. And then, yeah, with the availability as well, we fly to loads of airports that still don't have SAF available.
Yeah.
So it's really difficult to decarbonize.
I just make one more comment on that as well, actually.
Yeah.
So last year I coordinated a Horizon Europe grant, which was about market uptake mechanisms. So of course it will, well, everybody knows it's on its way, but at least funds are going towards making sure it is an approach across mobility as well. It's not just across aviation. So at least a holistic approach will arrive eventually.
Yeah, I think the book and claim community, I don't know if that's what you're speaking about, Sarah, but the book and claim community led by Smart Freight Center, which I was extremely glad that Smart Freight Center was leading that community, because Smart Freight Center doesn't take care of aviation, they take care of cargo. Whatever it is that you're moving, it has to be, it's what they're trying to find solutions to decarbonize heavy transport. And having that book and claim community there actually could be extremely helpful, because it's not just directed to aviation. So if the block here is just aviation, and that's why we're not offering book and claim, because we see a huge problem that we yet have to define what is the real problem, right? Where are the risks? Where is that defined? The road sector is moving forward. It's moving forward very strongly with it. In the maritime sector as well. So as we said yesterday, for those of you who were here yesterday, we were talking about, we can't speak about SAF in isolation. SAF is part of a major industry, meaning it's a solution for transport. And as you produce SAF, you can produce other co-products, that those co-products are also serving the transport sector, to decarbonize transport sector in other industries, the transport industry in other sectors. Yeah, I think I agree with you. They're coming, it's taking long. And I do remember 2010, when I was president for Chamber 2 of Industrial Biofuel Producers at the Roundtable of Sustainable Biomaterials, is when we first proposed that book and claim be allowed. Of course it wasn't. WWF would not allow it whatsoever, and mainly because it was still an enigma. How can you claim something that you didn't even use, right? And how that impossible. But yeah, I think that we have a lot to say about book and claim. Andrew, yeah.
Yeah, no, I think it's a good point. We need both. So for us, we rely on physical molecules because we want to show the industry that it's needed, the physical, because we fly, that's what we do. But at the end of the year, we don't have, for this year's contract, for instance, we've probably got about 50 to 75% of our physical needs. And then at the end of the year, I'll review our flights and then use book and claim to top up. Because book and claim is, it always gets said, but sustainability is and it's not just one silver bullet. So book and claim is great for the investment market that we always talk about, ESAF, SAF. So for us, book and claim, it would be just great if it could be accepted within the GHG protocol and SBTI, because that's a bit of a barrier. But RSB is doing some great work with that.
Yeah, exactly.
I do believe SBTI do kind of accept book and claim, and they're fairly clear about that in the aviation guidance. So I always kind of refer to, I don't even know the page number now at this point, so it's pretty sad. But my understanding is, SBTI pretty much is there. It's good to go. I think for those that aren't aware, I guess, book and claim it isn't available in the mandate. You can't do a book and claim approach. You can do a mass balance and chain of custody approach. You can do book and claim under CORSIA, which is positive, but you can't then share the scope 3 with someone else. That you have to keep the scope 1 and 3 together, so you can't split those and share that cost. So that's another barrier. Another addition to the challenges that airlines have is its mandate. We need to think about voluntary. Oh, and CORSIA is there as well. We must think about that. ETS is another factor as well, of course, and you can't use book and claim for ETS. You can't, even if it's a physical supply, you can't split the scope 3 again. So there's a whole world there of different considerations. But I think it's important to understand, at least at first, why the EU Commission haven't included book and claim in that, and a large part of that is about energy independence and fuel security. The idea, of course, is to get physical molecules ideally produced and delivered in Europe. So that's a big part of it. Book and claim was initially and still is kind of looked as a short-term solution, so that one day we do have physical supply everywhere. But there's also accounting challenges between countries about emissions and things you have to report to the Paris Agreement or Renewable Energy Directive. And there's lots of talk as well about the flexibility mechanism. Will that allow book and claim when it comes out in 2027? But it seems as though we're at a point now where it's a little bit too late to have that added in. So that's a bit disappointing around book and claim, but it has so many other benefits around, especially in that voluntary market, sharing that cost, no geographical limitations, being able to access incentives and things like that. So big fan of book and claim over here, if that wasn't clear.
No, yeah, I think you were clear.
If I may, you were asking before about if airports are getting involved in the issue of SAF and in general in energy transition, even if they are not directly, and you have commented about air quality. I think the point is just for the audience to know, for the air quality, it's the same to use SAF or to use kerosene.
No, wait a minute. No, I challenge you on empirical evidence.
You can challenge me the whole day.
I mean, we spent 5 years researching this.
And we are members of the
Behind the aircraft,
most
measuring
important
it.
project of using SAF in Europe is Allied in Copenhagen Airport, and the results are more or less the same.
No. Hold on.
Okay.
The results are, if you have more 30% or more SAF component within that blend, then there is a significant reduction in ppm 2.5.
Are we in the same project?
We are in the same project, and that is going to be published in about 3 months.
I disagree with you, but we will talk later on.
We'll talk later.
Okay, because I told you before, I think in the coffee, Winston Churchill, I only trust the statistics.
No, I made this statistics, so that's why I trusted.
I have manipulated before. So, but I think, well, the most important, going back, if the air quality would have the use of SAF would have a really, at the airport, important, positive impact.
Yeah.
Of course, we will, as regions hosting an airport, we will not be in favor of book and claim. As we consider the other way that you consider, well, I think it's important to know that that's why we think book and claim, it's really a way to fulfill the goal.
Yeah.
On the other hand, I think this is a very, going a little bit out, I think this is what we are trying. It's a very interesting, would say interesting test. In other sectors, more cars, what Commission is saying, from this day on, no more production of cars. This is very easy to control. That's it. This, what we are trying with SAF, or what the Commission is trying with SAF, it's much, much complicated because it's the interaction all the day between the sector and the public authorities about the implementation. I think it's a very interesting experiment. You are suffering it, the companies, but it's a very complicated way that the Commission is trying to fulfill the final goal of decarbonization. On the other hand, I think it was mentioned before by the woman of Transport and Environment. Now in Brussels, everyone is thinking about who is going to pay this, and not only SAF mandate, if not all the goals that we have fixed are going to be a little bit postponed. A little bit postponed. And on the other hand, ACI, IATA, Islands for Europe, 1 week after the elections, the European elections, because the result was quite clear, they signed an agreement and they signed a manifesto with 200 big organizations of all sectors. No way back to the Green Deal. Because the vast majority of the sectors, they have crossed the Rubicon. They have crossed the limit. They have gone to the runway when there is a point that the pilot has to go up, whatever happens, because there is the no return point. I think we should be happy, or at least to be aware that we have crossed this point as Europe, at least.
Yeah. Well, so I think we have only 40 seconds. I think that's a good way to end the panel, with a positive view. There's a point of no return. So let's move on and find solutions. Whatever it is that it's keeping us from doing better, growing faster, let's find those solutions. Yeah? Well, thank you very much. Thanks to my panel. I think that's it, no? Yeah. Let's just do the panel.
Thank you. Thank you very much for this insightful panel. We have one more presentation on price assessment, the key to fueling the SAF market. And for that presentation, I would like to invite Wesley Montero, Global Market Development Lead at SP Global Commodity Insights. And I believe he will join us online. Yes, here you are.
Hello, everyone. Good morning, good afternoon. I'm trying to share my screen here. I don't know if it's
Could
okay.
we
If you,
put the volume up, please?
can you hear me now? It's okay?
A little bit better, yes.
Okay, thank you, thank you.
Perfect,
Can you all
perfect.
see my screen?
Yes.
Okay, so yes, let's start. First of all, thank you very much for the lead event group for the invitation to deliver this presentation here. Good morning to you all in the audience. Sorry that I couldn't fly to Amsterdam. I was in India, Singapore last week. I arrived in Brazil. I tried to book a flight, but I was not successful. But anyway, we are here to talk about the other element that is very important to help develop the SAF market that we call a price assessment. I'm going to explain later how it works, but we firmly believe that once we have transparency in the market with those robust and also reliable price assessment, this is one of the ways to support to take the SAF market even further. I was planning to pass this slide, but I don't think it will work, so I'm just going to jump to slides here and then to say our agenda for today. So pretty much 5 topics of introduction. We will talk about a little bit about sustainable aviation fuel pricing, and then we'll talk about feedstock pricing, some aspects related to our view on the global SAF markets, and then in heading to land, we'll came to the conclusion. The plan is to have a presentation around 20 minutes. I'm tracking the time here, and then 5 minutes for Q&A. A little bit of a quickly introduction here for those who are not familiar with S&P Global and S&P Global Commodity Insights. S&P Global Commodity Insights is one of the 5 divisions of the main umbrella S&P Global that also includes S&P Global Ratings, S&P Global Dow Jones Indices, and the other divisions that you can see in the screen. Within S&P Global Commodity Insights, we are the leading independent provider of benchmark price across all the main commodities in the 3 main groups: energy, metals, and also agriculture. In energy, we have all the way from oil prices, refined products prices, and also the new, let's say, energy transition power generation source, and also wind and solar, and surely biofuels. I think that is very interesting to note is that S&P Global Commodity Insights is pretty much the result of a merge that we did 4 years ago between the legacy, what we call here, the legacy Platts and the IHS Markit. The thing that is notable here is that S&P Global Platts was pretty much associated with price assessments, and IHS Markit brought to the merge, that's to leverage our synergies, right? Brought to the merge the research and analytics part. It's very important because I will see later the way that, for instance, we can build some kind of models to cost of production price came from this, let's say, side of research and analytics that makes the price even more robust and has the capacity to represent the true value that is in the market. Come now to the price assessment per se. we have a very specific way in which you assess price here, the market-based price here at S&P Global Platts. And the way that we do that is through a very specific methodology that embed a lot of different aspects that I'm going to show later. But in a simple way, pretty much on a daily basis, our reports, our reporters and our editors, they have the capacity to follow the market, to be in touch with the market players, like in their work hours, and to try to capture what's going on in the market, information, as well as some circumstances, try to have the feeling about the situation of the market, and at the same time to capture those offers, bids, and the way that those offers and bids with the incrementability, the way that can be like reach a tradable level, that would be, related to the price. It will be the price that reflects the market in that day. So we call all this process price assessment, and this is pretty much the way that is behind all the price that we publish for all the main commodities. And we will see later, sorry, for SAF price as well. On the right side of the screen, we have what we call the subscriber notes. Why is it important to highlight here the subscriber notes? Because the way that we do all those price assessments is, again, through a very robust methodology and through this practice that we saw here that we call market on close. And this methodology is subject to change. And we know that the biofuels market has been evolved quite fast, and this methodology needs to follow the evolving of the market. But surely, because we build the price from the requests of the market, and we believe that the price to represent the market value needs to be, let's say, agreed somehow by the market players, we have a transparent way to communicate with the market the ways that we are going, to change the methodology, or to put a new price, or to discontinue a price. And the way that we do that here is through what we call the subscriber notes. Another element that I would like to highlight here is what we call a process called price verification. What I mean by price verification, it's a question that I used to get in some of the presentation, how to ensure that the price is really, let's say, the price that represents the market value. We all the time, beyond checking the offers and bids, we do the, let's say, counterpart check. If a market player reports a transaction, we'll check with the counterpart of the transaction if the price of the transaction was that. Also, we have a very robust way to check if the source, or if the market player can be considered as a source, can be like a provide prices for us, as a way for us to assess this price, and this price represent the market value. Of course, some set of criteria here that we have includes, for instance, the source level within the company, the company size, how the company interacts with the market, and so on and so forth. And this is a very dynamic process, in a sense that this is an evaluation that is doing with some frequency, again, to ensure that the price that we hear from the market can be like representative. This is I was saying about the methodology. I'm going just quickly through this slide. This is one of the ways to show that actually we have this hierarchy of information, this pyramid. Of course, once the market reaches some liquidity, we have the best way to assess the market, the more robust way to assess the market is what we call the review the MLC. It's checking the counterpart, check the transactions, checking the transactions even with a communication tool that we call U window. Once the market's not there with regards to the liquidity, especially for instance the SAF market, we still can have a price assessment that I'm going to show later through, for instance, indicative price, previous trades, and tender results. We have heard in the market that the SAF transactions has been done pretty much in the three main ways that we have here in the screen: cost plus model, differential market trajectory index, and SAF price. Related to cost plus model can be a feedstock plus, and this is a model that is pretty much more, let's say, used by the producers because they can somehow hedge against their main cost, that is the feedstock. We can see that in the screen that, for instance, in this example, the UCO price represents around 75% of the whole price of SAF. The second way is much more common to be, let's say, required by the airlines because they are quite familiar with the jet index. We have there in the screen some kind of jet fuel benchmarks that are published by S&P Global Platts and are very well referenced and very well known by the market players in different regions of the world, all the way from the jet kettle, that's a benchmark for the United States market, jet kettle, LA, California. We have a benchmark for the jet market, CIF Northwest Europe for Europe, and we also have, for instance, another benchmark, in Middle East and also in Singapore. And the way that is done, in the transaction of SAF, we'll say later what would be the premium, but it's a premium over those jet price that you can see in the screen. It has started to gain some tractions. At least the markets are following, even though there is no kind of contracts in stock exchange, things like that. But SAF prices, we have a cost of production market-based SAF price that I'm going to show you later. And those SAF prices had been somehow at least followed by the market and used as a reference for the market players in their transactions. Other ways that are less common, let's say the most common one is jet plus premium. As I said before, we also have fixed price, and some players, they have somehow, prices SAF against, for instance, CO2 abatement, cost-based feedstock plus premium, etc. Our market-based SAF price, we published 2023, we published first in Europe. Europe was, let's say, more advanced, and we identified some kind of flow of SAF in Europe, and we publish a market-based assessment there. We also have a cost-based price in Europe. And then following this evolving of the market, we publish market-based in Europe. We change one price for two different prices, Northwest Europe, to take into account the SAF flow into United Kingdom, and also we keep another price assessment to be referenced, to be used by the marketplace to account the SAF that was flowing within Europe. We call this SAF price Farage. It's AOA plus Flush and Ghent. I think Ghent is in Belgium, Flush is in France. We also have that we started to publish last year, US price. We can see that in the screen, the main elements of the methodology. What's interesting about US price assessments that we published in California, because this was the region in which we had mostly the biggest chunk of the SAF is still flowing to California. And also we published in Illinois because there are some kind of a state level incentives there that can make SAF flowing towards Illinois. We published in niche and blended version. We heard in the market that some players they are still buying some kind of niche SAF to do the blend by themselves, but surely the main, let's say, main way to buy SAF that is the blend, 30% SAF and 7% jet. Those prices are still published to refer to the half a pathway technology. Again, those are the main elements of the methodology behind those prices. We know, as I said before, we captured in the market the way that the market is transaction SAF, and we put all the main elements here, and we do that through a lot of engagements with the market to understand and to capture how those transactions have been done. And for instance, in Europe, we have a delivery period, you have a volume, you have a minimum GHG saves of 80%. Surely, if we capture a price related to a transaction that actually are not following those kind of elements in the methodology, we can still normalize it through some calculations, this price, and to have the price assessment. In Europe, again, the market's more advanced. We use a tool that we call eWindow. This is a communication tool, and this surely worth to highlight here because this is a tool in which the market players that they are transaction SAF, they can transact SAF, showing their transactions, their offer, their bids, the volumes and the price in this eWindow tool, and everyone that is involved in the market can see this lively. We also have, I didn't touch before, but I'm going here quite fast. We also have a netback SAF price in Asia. Again, the market's not involved yet in Asia, but we needed to have price between a cost of production, a modeled price, and a market-based price. And the way that we did that is try to, since October last year, we published a price, netback price in Asia that it takes into account the freight, the price in Europe, and the freight from our region to Singapore. Those are another example of what we call the cost-based price. Those prices are used somehow by the markets, by the market players as well. While the market still don't have liquidity, while SAF is still not, let's say, a commodity per se, with some kind of different transactions during the day with different volumes, we still keep our cost-based price. Those prices are calculated through, for instance, related to any specific feedstock in a specific region. We have there the charts showing the different prices that we have. We have the cost-based price also for the different regions in the world, for United States, Europe, and also Asia. In Asia, we have Southeast Asia and North Asia, pretty much in China. In the second chart here, we can see some comparisons between our cost-based price, market-based price. There is still a difference because, again, one price is calculated, the other price is capturing the market, and the price that is capturing the market has a bigger volume. What it's interesting to highlight here is the behavior between the premium related to the jet. The jet is the red line. We can see, for instance, in September last year, the premium was around $3, $3.5 per gallon between the SAF and the jet in United States. Today, it will be more, it has reduced a bit. It will be more around $2.50 to $3 per gallon, this premium. Interest to highlight is that we have, and it has a relationship between the, it's useful to highlight the relationship that has between the SAF price and the other biofuels price, as well as other feedstock price, as we saw before. This is a chart just to show pretty much a full coverage that we have. We also have a full coverage in the carbon market as well. Everything we take into account as an information, that's really, really important. While the market still don't have the right liquidity, the liquidity level that we wish the market to have, and we're pretty sure that the market will be there. We take into account all the information that we can capture in the market, not only related to SAF, but also related to other biofuels and the feedstock to come up with the assessment. This is the calculation for our cost-based price. I'm run a little bit faster here, just to be conscious of the time, but you guys will have the access of this presentation later. To talk a little bit about feedstock, this is a very important chart. The main message here is to know, biofuels industry is a feedstock industry, and feedstock is a bottleneck. That is still, if we ramp up the production, and the production will ramp up because of the demand, not only for the let's say biofuels, but also the fame ones, the most common ones, will need, let's say, I yet to find feedstock to reach the necessarily demand. As I said before, we had the coverage of the feedstock price as well. Again, I'm just going quickly here. This is a very important chart just to show this dynamic between the feedstock price and also the SAF price. In 2024, the SAF price was bigger in Europe because the cost of the UCO was bigger than the tallow, and in 2023 was the other way around. We had a bigger price for SAF in the United States when we compared to Europe because the tallow cost was higher. Of course, we saw last year there was a flow of UCO to United States, so it will change a little bit this chart here, but it's just to compare the first half of 2024 with all the 2023, because we know that the second semester in last year we had a pretty important, pretty huge flow of UCO to United States. That, by the way, we know that perhaps it should change again. We'll have more flow. Actually, this is what we have here in the market. We'll have a more flow of UCO again to Europe because of some restrictions with the new 45s in the United States. A bit on regulations, but then I'm going to jump here as well. This chart is just showing the demand per region. this is a very important point that I would like to bring here. There are a lot of different ways. Europe has a preference for blend mandates. United States have used it somehow the incentives to drive the demand. Singapore has countries in Asia, they have targets. Singapore has a very specific levy to pass the cost of the SAF to passengers. And Brazil last year approved the fuel of the future, with a very, let's say, innovative way to drive the SAF demand. The way that it will be done here in the country, it will be through, let's say, the main aim is to reduce the GHG emissions. Brazil, the main authorities here, they are pretty much like aligned with a book and claim idea, as well as some ideas related to be feedstock agnostic. At the end of the day, they believe that, and I'm just adding this here as an idea for discussion, they believe that the main aim is to reduce the GHG emissions rather than have any specific feedstock on any specific pathway to produce SAF. All the main technology and pathways to produce SAF, but this I'm going to move fast. Just to, before the end, what we believe, and this chart shows a lot of different benchmarks, a lot of different price assessment that are used by the market in other commodities to, to do the transactions. We have here the very famous ones such as Platts Dubai, Platts Dated Brent, that are benchmarks today that are using in different regions in the world. And we see that actually energy transition sectors, they will evolve to a point that it will be a commodity. And this, when they evolve to this point, the market will be more efficient and will have, let's say, the price assessments that we are publishing today will become somehow no ways to index the market. Indexation will be happen and the market will be evolving even further. We saw that in the biofuels, for instance, with ethanol already, that we have the benchmark in Europe and United States. And another thing that is important, those prices can be used not only, today transactions, but also in the contracting stock exchange, long-term contracts, even somehow to better the bankability of to improve the bankability of the projects and some so on and so forth. If I can let you with three main message here, a very robust price methodology ensure robustness and transparent in pricing process. Price reflects all the relevant information in the market, and price relevance is crucial to the evolving landscape of sustainable aviation fuel. And this is done. I open the floor to any questions, and thank you very much for your attention.
Thank you very much, Wesley. And we have questions, so I see one in the back. I will give you.
You won't hear me. There we go. Hi, Wesley. Thank you. It's Jez Lowe from Sky Energy. Wanted to really just get a clarification, I think, first of all. My understanding, I think, there from your presentation is, if I'm understanding correctly, essentially 4 different price assessments: UK, Europe, US, and Asia. I think one of the major things, I suppose, if we take the US one there, and I think it was based on tallow. I think you talked about a 45 gram carbon index, which seems high. But one of the things I think, people rely on these kinds of price assessments, and often the first discussion I would have with someone is, they'll say, well, look at the price assessment, it's here. And often what I'm saying to that is, well, there's lots of different factors that I think, in terms of it from a sustainability perspective, that aren't necessarily included in that. So an ISCC Plus certification is very different from an RSB EU Red certification. Similarly with carbon intensity, which you've tried to factor in a little bit there, and feedstock to some extent, and beef tallow is again a very different product to a technical corn oil, and at the other end of the spectrum, at least today, is used cooking oil. And there's a huge price differentiation between those two kinds of products. Yet, obviously, we're trying to cover lots of different bases. I understand that's a huge challenge to try and bring all those factors in. But how do you respond to that?
Oh, perfect. First of all, thank you very much for this incredible contribution. Sorry if I got your name correctly. It's Jess.
Jez with a Z.
Yes. Okay. Thank you for this incredible contribution, Jess. You are totally right. It's part of your challenge here. We started, while the market is still evolving, we started with the four main prices that you said, the four main prices would be the market-based ones, because beyond those market-based ones, we have the cost of production ones. So if we can split like SAF price, we have the cost of production, the market-based ones. And the market-based ones, as you said, we have two in Europe, one in the United States, and one in Asia. You are right when you say that there are some elements that we need to include in the methodology. And the way that we do that is exactly to talk to the market to, let's say, to capture what would be the best way. It's not the perfect way. What would be the best way for now to assess those prices? Of course, those prices would be used as a reference. And for instance, those prices take into account the half a pathway, but we'll know that soon we'll have like the HJ SAF in the market. And the challenge is how I can capture the price of an HJ SAF if actually HJ SAF has some different attributes with related, for instance, with the carbon intensity than a half a SAF. So the first thing that we do, we publish a price, and then we'll continue to follow the market to see if it would be worth to publish another price to take into account of those difference. In this moment, for instance, when we publish the new pricing in Europe, it was to account a difference in the location. We saw a different location for Raj and Northwest Europe to include UK. We changed from one price to have two price. So surely soon we'll have more price to take into account all those different aspects that we can have related to the molecule, to the SAF. Because we know that, for instance, I said here about the commoditization, the stage in which the molecule evolved to a commodity, but we know that SAF will have different SAFs, let's say, right? Different pathways, different technologies, different regulations in Europe and United States, different schemes of certification, and we will try to capture this as the market will mature. So, for instance, just another example, we'll have this year a cost of production HJ SAF. We still don't have the liquidity in the HJ SAF to have a market-based price, but we are modeling to launch. I think I forgot the month, but it will be first semester of this year. A cost of production SAF to account for the HJ SAF that is transacting in the market. So I think this is. I don't know if I answered your question. I don't know if you'd like to touch on another point, but thank you very much for your contribution. Very, very important.
Yeah, Wesley, thanks for your presentation. This is Chris. I'm curious to know, I have two questions for you, and I'll try to be clear. First question is, in your market-based assessment, you have applied that to SAF, and you've created rather a successful organization around the fossil fuel industry. But what other products do you guys report that include a cost basis assessment in their publication? That's my first question. And then the second question is, against your peers, where you have a methodology of market on close versus an entire day, with an illiquid product such as SAF, how do you intend on publishing accurate pricing if you're only measuring on the last hour of trading?
Perfect. Thank you very much for those questions as well. If I understand correctly, the first question was related to other commodities in which we publish cost-based price, right?
Do you produce any other products that you include cost-based pricing to include their production? In this case, you reference HEFA, but do you also reference any of the catalyst or costs associated with conventional fossil fuel refining?
Conventional fossil fuel refining we don't have. In the SAF, we will have HJ SAF cost of production, and we have different ways to publish a price, a cost of production price for SAF today, that it depends on the geography, right? In Europe, United States, in Asia. We also have cost of production price for hydrogen and other commodities that are still not there related to the liquidity. Related to the SAF specifically, the way that we do this cost of production, we take into account the feedstock, the hydrogen, and both are assessed by us, right? The revenue, we deduct the revenue to account for the co-products, and also, let's say, cost to refer to the OPEX and CAPEX. CAPEX is the money to invest in the refinery, and OPEX is, utility costs, labor costs, and so on. I don't know if it was your question, but conventional fuels, we don't have any kind of that I know that we wouldn't have any kind of cost of production price. Related to your second question, you are right. The market is still very liquid, and the way that we try to capture this price is through we use the methodology market on close, and when we publish the price, we publish the rationale behind this price. We publish as well a commentary. We take into account all the main elements, all the main, let's say, circumstances in the market to see if this price would make sense or not, and we try to develop the source. We will not take into account just one price to say that's the price that reflects the market value. Surely, sometimes you could ask me, you have herds every day? No, we don't. Right? Once we don't have the herds in the day, we publish the price in a way and we inform to the market, because the market can also follow the herds. I mean, the herd is the price that we are capturing in the market. We publish that as well for transparent reasons. And but at the end of the day, if we don't have herds, we publish the price with some kind of, let's say, not calculations, but with some judge from the editors where the market is going. We compare it with the jet fuel market, we compare it with the feedstock market and the biofuels market to see the direction of the market to publish a price if we don't have herds. So, of course, if you remember there in the presentation, the hierarchy of information, it will be in the lowest level of the information. In the situation in which we don't have liquidity, but we still publish a market-based price assessment, and this is the way that we do, even though we don't have the hertz. We believe by market on close that price is a function of the time. This is in a way in which the price can reflect the true market value. That's because we don't use the averages such as the competitors. I don't know if I answer your question, but thank you for the question. Very important one as well.
Thank you. We have actually one more question. Before we... No? All right. Sorry. Then this was it. Thank you very much for your presentation, Wesley, and we'll see you soon. We'll go for lunch. Bye.
Perfect. Have a nice lunch, you all. I stay available. Thank you very much again for your attention. Thank you very much for the invitation. And please, you can reach out to me in LinkedIn. I mean, I'm always available to have a conversation on the SAF market.
Great.
Thank you.
Thank you. Thank you. Bye.
Bye.
All right, this finalizes the presentation for this morning session, and we will have now an hour for lunch. I'm looking, it's an hour, right?
Yeah, we should be here around 2:10.
All right. Welcome back, everyone. We're going to start up the session again. Just checking if Marta is already here. Yeah, great. Then we can start. So welcome back, everyone. Please take your seat for our next presentation on green finance and SAFs. I would like to welcome Marta Oliveira, Senior Associate at IKG Group, that will give this presentation. Welcome,
Thank
Marta.
you very much, and thank you for the invite to be here today. You'll probably see a different face than you normally see every year, because normally it's Helen and Roberta that come around. I came this year. But I come with good news, so hopefully that's a good thing to come through. So today I want to sort of touch on firstly what is the approach that we're taking as Ikigai in terms of how can we best structure projects for them to be bankable. And this means how can we best structure projects that are attractive for investment and therefore we can get external finance into these types of energy and nature solutions across infrastructure assets. And then I'll also dive into a little bit into Glasgow Airport, the hydrogen hub that we have been leading for the airport for future flights, and how does that connect with the whole sort of infrastructure around the airport, the collocation of other fuels, including SAF and others as well, and how we're sort of approaching that whole ecosystem. So in terms of Ikigai itself, we're European, London-based, net zero bankability advisor, and also a project developer. I know this is lots of words, but really what it means is that we support infrastructure assets, so airports, ports, water and waste sector, big industrial regions, to decarbonize. And that decarbonization or that net zero optimization of the asset comes in two things. One of them is energy solutions, and that we can start sometimes talking about sort of electricity solutions or heating solutions for buildings, but it also comes across sort of how to decarbonize fuels and the use of those fuels in transport. In airports specifically, we're obviously talking about flights, but also looking at the full ecosystem around cargo, ground handling, buses that also go around the airport. So that's one side of the solution, the energy solution. We also complement the projects on sort of the nature complementarity solution. This is something that is sort of coming up now, especially in the UK, as planning regulations are sort of coming through about sort of the requirements around biodiversity net gain and others. But we go beyond that, and if we are looking at an asset and try to improve it from a revenue perspective, also from a resilience perspective for the future, then it does make sense that we look at that complementarity between what we can do in energy, but what we can also do in nature. So that's how we approach projects. On one hand, we develop all this work for the asset owner. Where does the investment come through? A lot of these airports, I mean, energy and definitely nature is not core to them. So there's no funding that goes into any of that. So where we come in on the funding side is, as a project developer, we either invest our own money in, if external investment is not ready to come in yet, or we just get external investment into the project so that institutional investors, renewable energy money, so that we can push the projects forward. So we crowd in institutional investor money into these projects, and now our work is mostly to make the projects bankable and the structuring of the projects attractive for these mandates so that we can accelerate the transition on that basis. So what does it mean for a project to be bankable in our world? It means approaching it as a hub. And why a hub? Because hubs actually solve a lot of the issues around bankability. I mean, if we think about what makes a project bankable for an investor, the first thing is demand stability. So how do we look at demand? How do we look at having that revenue visibility, especially in markets where, if we talk about hydrogen, the hydrogen planes are not there yet. Even the trucks are not there yet. So how are we going to structure a project around offering something to someone if there's no demand? So how do you structure that demand is really the first key thing. Why does a hub structure help? It helps because we can, one, give diversity around the demand. So we can look at multimodal approaches. As I was saying, if we're structuring something for flights, the flights or the planes don't need to be our own off-taker. There are other vehicles, there are other industrial users in the area that can potentially use the same fuels as well, and that will have a transition period that is different from the transition period of the flights. But that's actually good because it sort of decreases the exposure of demand risk by the fact that we can look at it from a multimodal perspective. So demand resilience through demand diversity is one of the key things we look at. The second one is how can we make the fuels or produce the fuels in a way that they're more cost competitive and that they have a cost that is actually viable for off-takers to take it. And just taking the example of hydrogen, for example, we've seen, and I'll explain in a bit on the project, that behind-the-meter renewables really helps making the fuel competitive. Grid non-commodity costs are absurd and make a lot of the projects very difficult to reach. Also, restrictions on sort of grid capacity as well make that a very big hurdle on a couple of projects. So looking at that sort of demand resilience from an offtake side, but also from an input side on how we can respond to that demand and make sure that we can get to the costs that they can pay. It's a very important part of structuring those projects as a hub for financing. The second approach, I'd say, is to look at it from sort of a stranded asset resilience perspective. No one wants to get a stranded asset, so how do we make sure that that doesn't really happen? And again, it's looking at the projects from a holistic perspective. How do we best integrate the systems? How do we know exactly what's happening around our little projects, and how do we know how does that connect with the rest of the airport? How do I know if currently we're going to produce gaseous hydrogen at the airport, where are they going to store it with the liquid hydrogen, with the SAF, with the other fuels that are coming through? You don't want to make the airport a whole coma region, so how do we make sure that that is sort of integrated with the wider operations at the airport as well? And finally, I think on the stranded asset resilience point is also looking at the nature side and just coming back to that point around sort of the biodiversity balance, because that will support sort of asset resilience for the future, but also even looking at, is there a nature intervention solution that's actually much cheaper than an infrastructure solution, for example, for flooding measures or other types of interventions which actually really support sort of efficiency around the projects? And I guess sort of the third big theme is, can we make these projects replicable? I mean, we're talking about airports, but being in airport sports or other, we're talking about networks. You can't fly to an airport and have hydrogen on one side or SAF, and you don't really do it on the other side. You need to build a network. And if you don't make the first model projects replicable, then you're making life of everyone much more difficult. So can we make the project in a way that they do look sort of scalable on a portfolio basis? And if yes, what are the things that differ, but what are the things that we can standardize? So that's sort of the approach that we take. And that's also what we tested when we started looking at sort of the hydrogen hub at Glasgow Airport. We already had history with them, so we already kind of started the process with them, first on a solar plant, then connecting to a district heating network, so that underlying base of energy was already sort of there. And then that's when we got to the side of how are we going to decarbonize fuels. And I mean, you're probably all thinking, why Glasgow? Well, Glasgow has something that is really relevant in terms of the flight structure. They have up to 19 seat flights that fly back to base to the Scottish Islands, and actually, which are probably going to be the first hydrogen airplanes to come through. And therefore, it's a good case study to understand how we can put the hydrogen there now, handle the hydrogen at the airport now, and really understand from that bubble, how can we then scale that up for a larger scale after. So that's the primary reason why we chose Glasgow for this first approach. We had a lot of partners with us, I mean, both on the technical side, but also from the technology development side, on the flight specifically, ZeroAvia, but also Cranfield Aerospace, and then partners on the input side as well. So for example, the water company in the area, how do we make sure that we have the right water input, which everyone forgets about, but actually is one of the most important parts of making the project right. And obviously the support of the airlines that at the end of the day will be sort of the end consumers of the fuel and need to understand how, with the ground handling operators like Menzies, how they will work together on this new sort of set of operations at the airport. So when we looked at the project, our scope was a hub that included both production of hydrogen on site, also storage of that hydrogen, and specifically here, a relevant point around what we looked at in terms of storage. I mean, it's a critical infrastructure environment, so we tried to test different types of storage that actually would allow us to store the same quantity of hydrogen but require much less safety distances around them, so solid state versus the normal compressed storage for hydrogen. So it's production, storage, and then distribution of that hydrogen into both the airfield, so from a ground handling and flight perspective, but also towards what's in and around the airport in terms of vehicles, so cargo, haulier depots around the airport, organic traffic though, because of sort of planning restrictions, but also sort of what's going in and around the airport that can also piggyback from that fuel. And then obviously analyzing how can we best integrate the demand, which per se, it's quite fragmented in terms of scheduling and in terms of really the usage and the profile and the phased approach to getting the fuel, and how we integrate that with sort of systems sizing. And we did that through sort of a data-led software from H2Go. And obviously the last approach is to see how can we leverage this to other airports, and I'll go through that at the end of the session, but we'll also see a couple of actual Dutch airports that we've been speaking to about this. So in terms of where did we get to, we're obviously considering sort of three big areas there on the production, storage, and distribution for the fuel. A couple of interesting conclusions that kind of came out of that. The first one is on production. Can we produce liquid hydrogen? Because that's what can potentially also go into bigger airplanes in the future. No way we can produce it on site. The scale of hydrogen that needs to be produced on site to even have a commercial liquefaction plant is huge. You need to do more than 30 tons of hydrogen per day. So it was the first conclusion that we got to. Liquid hydrogen is not going to happen on site. It's relevant because if it's not happening on site, where are you going to get it from and how are you going to transport it? And that's actually one of the big gaps around the UK, but potentially in other regions as well, which is how are you going to manage the transport of those amounts and that quantity of hydrogen or other fuels between the production and the demand side, and how we are making sure that they have security of supply as well, and how we're making sure that all that works out co-located with all the other fuels that you also have at the airport. So that was sort of the first conclusion. Then in terms of the storage, and I mentioned already here, we looked at solid state storage and compressed gaseous storage. The purpose of looking at the solid state storage again was to understand whether there is a possibility of decreasing those safety distances around the storage, and specifically what is the relevance of that for the storage of other fuels as well at the airport fuel farm or at any other areas at the airport. Where does it make sense to put the storage? There is something else that's quite relevant to consider as well, which is what happens landside versus airside. And when we talk about airside, obviously the perfect situation is that the operations at the airport don't really need to be changed. But if they do, and if because of the introduction of new fuels, suddenly you can't refuel with passengers on the flight, on the plane, because it's not safe anymore, or the fuel is not necessarily safe to be refueled on that basis, then you need to understand how we're going to manage that throughout the airport operations and how that landside, airside proposition is going to work. The other area that we looked at as well was, is it efficient to put electrical storage versus hydrogen storage on site in a way to sort of again, look at what is the best solution in terms of sort of the safety complex of it. From a systems integration perspective, it was not very economical to do so, and it didn't make much sense in terms of an efficiency perspective, and that's sort of one of the conclusions that we got to as well. And then finally, on the distribution side, we looked at what is the best way to sort of co-locate those fuels, and specifically that a distribution facility, a refueling station landside, is one of the best, is potentially the best solution to do it, and then you can transport that back onto the fuel farm at the airport, and definitely not a pipeline for hydrogen within a critical infrastructure zone like that. So in terms of two phases, we looked at how can we phase this on a gaseous hydrogen perspective, also a phase two on how can we integrate the larger scale hydrogen, liquid hydrogen into the airport as well. And that scale up is depending on the demand and what the demand can offer and when the demand is coming through. So first, sort of starting with vehicles, buses, trucks, refuse collection vehicles, then sort of moving on to scaling that up. So first some of those vehicles, then scaling that up for a bigger quantity of vehicles, and then from 2030 coming in the flights as well. Just something to raise here on the constraints. I think all the projects that are producing fuels go through how can I produce fuels on this side and what are my constraints. And so one of the big areas that we had to look at was, do we have grid constraints? If we do, what is the behind the meter solution that we're going to look at? How are we going to make, how much behind the meter do we need to make the price of the hydrogen competitive? Do we even have space for that? And then also from a water perspective, what can we use effluent? But if we use effluent, we need to build the whole infrastructure to go to the production side. Is that economical? Is it not? So we were sort of doing this exercise on how to balance out the best cost and carbon footprint for the production of the fuel. And good news, what we got to in the end is that with the subsidies, we are able to get to diesel parity price, which is what we were considering because of sort of the willingness to pay of the off-takers that we were discussing with. But the key considerations around the project bankability really come to two or three things. I mean, the first one, and I keep repeating this, but it's because it's crucial for the pricing, is on an input side, the grid non-commodity costs can really kill the project. So what is the structuring around that and how can we improve that? And if there's no grid, how can we improve that through renewables? It's a very key piece of that production feasibility. Then from an offtake side, and specifically if we're talking about hydrogen and transport, that's a very big piece to tackle. And it's big because the flights are not there. The trucks sometimes are not there. There are some buses out there, but we need to build a whole supply chain and a whole infrastructure to be able to even get to that offtake case. And on top of it, that also influences the kind of infrastructure that you have on site. Because if you don't know what vehicles are, you don't know what pressure you need at your refueling station. So that is all sort of a chicken and egg issue. But at the same time, it is the offtake proposition that's going to make the project investable because that's the underlying purchase of the fuel. But then it's also quite fragmented. So how do you make sure that you have one single counterpart rather than all of these fragmented counterparts? It is sort of from a deal with a forecourt and a fuel supplier, or how do you manage that sort of counterpart risk is also something that's quite important in terms of the bankability of the project. And lastly, it's about sort of the shared infrastructure and how to scale that up on a level that it's not feasible to produce on site. How do you scale that up to receive hydrogen and other fuels, and how do you manage that from an airport handling perspective? Something quite important to consider, and actually from governments as well, how that sort of national infrastructure is going to be built. And finally, just from an investor perspective, is always about the revenue visibility. So interestingly, the UK structure is there is a certificate scheme for transport versus sort of a CFD scheme which applies for transport and industry. All the investors said, there's no way that I'm going to go with a certificate scheme. The market is volatile, the certificate pricing is volatile. You either do the CFD or that's not going to work. However, on the CFD, you're competing with very large-scale facilities that have a long-term contract for the steel plant that is going to use that hydrogen for a long period of time. They don't have to pay transport costs because they can put the electrolyzer just right next to the facility, and they also can pay a bit more, which haulier companies can't, for sure. So how to resolve this transport versus industry but still be able to kind of put the project through is something that's really important to consider, and it's also something that we've sort of been raising on with the UK government and others as well. Just a final touch on how does this kind of go to other regions and how this is relevant for other regions as well. We were speaking with a couple of other airports around Europe, which are also doing trials around hydrogen and other fuels as well, on how to replicate this sort of model One, because there's potential routes between the airports where this makes sense, and therefore the planes need the fuel on one side and the other, but also in terms of can we do a series of mirroring of different airports around the country being regional or big airports, and sort of piggyback from that to learn from each other and make sure that we can scale up the network faster. And I think that's all, so thank you very much.
Thank you, Marta. Are there any questions for Marta in the audience? You give a very clear presentation, apparently.
It's after lunchtime as well. I think everyone just needs a bit of it.
All right.
All right.
Well, then I want to thank you again, Marta, and
Thank you.
our next presentation will be about navigating politics to meet net zero aviation targets through e-fuel and nuclear. It will be given by Sarah Wilkin, founder and CEO of Flying Green Alliance. Welcome, Sarah.
Okay, so yeah, my name is Sarah Wilkin. I founded Fly Green Alliance 6 years ago now, in 2018. Myself and a chemical engineer we were at a Booking.com grant together, which was proposing sustainable aviation fuel technology to Booking.com. We were fortunate that in December 2018, we got the grant and we started that work. Sky Energy is gone now, but even Sky Energy congratulated us on that one, so that was good. So yeah, my background was marketing, business development, but Shiju's, is chemistry. So over these, over these 5 to 6 years, we actually were the first SAF alliance that developed. So it was it was very new back in 2019. I did start as a business developer for the research project, but it was it was very difficult back then. So we've been part of developing the rules around SAF, developing the rules around book and claim, 5 years of consultancy. We've been developing business models and strategies, working across different sectors, and it has been mostly around the demand side, which has been discussed, of course, in the last couple of days. But it is that kind of across different sectors and that education that also Jez was talking about on the panel before. Another topic that has been brought up is working across different sectors and fuels. So we've now gone on to develop a new program called In the Loop, because actually, even though we've been working in SAF for the last few years, it isn't really siloed. It is moving, it is very connected to the biodiesel sector. Now e-fuels are a big topic. Because of e-fuels being a big topic, then SMRs and nuclear power is definitely on the agenda now. So we've been putting that on the agenda actually in the last year and a half, and that's why I wanted to bring it into the conference today. To start to sort of embed that thinking. I've now spoken to a lot of different groups, and even though I thought it wasn't a topic, it now is being discussed quite a lot. So that is why it's coming together. So this, so actually In the Loop is a new program that also, it will be a monthly meeting where different agenda points, cross-pollination, cross-sector topics are coming together so that insights can inform each fuel or each sector to really help their business development and net zero targets. So that was our episode 1. Episode 2 was the EU electricity market. So for any EU e-fuel developers, this was also really insightful. A guy that was working at Vattenfall, so he knows the kind of policy and the market, EU market inside out, so it's very helpful for any project developers. These are our members, so as you can see, they're quite varied, and it goes from nuclear to airlines to data solutions, but they all are working on net zero and innovation. So we just opened our membership this year, so this will then grow with our net zero declaration, and we'll even though, as I said, we've been working more one-on-one with consultancy, it really will be about representing a group going forward. And there's our declaration. So yeah, the topic that I want to discuss today is nuclear for net zero aviation. Well, whether you may know this, but actually the UK's Department of Transport, in the net zero roadmap, they have outlined nuclear as an option, and there's a lot of sort of work happening now in the UK. Just in December, it was the National Nuclear Laboratory, became United Kingdom, got the Royal Coat of Arms. So it's really now aligning the work that they're doing with the government policies essentially for net zero. I spoke at the UK NNL a session last week actually, and I co-presented with their application lead, and of course one of his topics is transport. And he, even in his talks, he is talking about synthetic fuel. And one of the big topics, which also connects to the EU electricity market, is access to the grid. And actually, I forgot this one. So the Prime Minister, of course, this is in response to the US, but Build Baby Build is the kind of headline that's come about. And it is with a view for nuclear as well. Production. Last year, the Department of Energy and Security and Net Zero did invite me to speak at COP, and where's my other? Sorry, I've lost that one. And last year, I also spoke at International Atomic Energy Agency and World Nuclear Association to represent aviation. At the World Nuclear Association, Google was to the right of me, Dow Chemical to the left, and we were all representing different sectors that are, of course, heavy energy users. So this is kind of work that we're embedding into our action points, which we want to put on the agenda. So, 1 second, I just need to skip back. No, is this going the other way? Sorry, this is now going a bit haywire. It's not behaving. It's actually just done its own thing there. Yeah, okay. Right, so I won't go into this. Everybody know, most people here are technical. And you probably know that synthetic fuels were invented in the US in 2008. So they were for national security in the first place, but they have gone on to support net zero as well. And of course, it is a closed carbon cycle. Many of you will also know about the need for aviation for 2050. Of course, we've discussed demand today, and whether demand is going to be curbed or not, the plan for aviation, of course, needs to be to make more synthetic fuel. And with regards to e-fuels, this is kind of a comparison. I do want to discuss the grid today, because if we are going to be making a lot more e-fuels, then of course we need more grid capacity. Sorry, yeah, it went a bit haywire there, so let me just... and then why do we need to think about it now? So in the UK, the access to the grid for new project developers is said to be not possible until the late 1930s. So of course, any additional or new e-fuel projects, even with mandates in place, this does need to be considered by a project developer. So what we did discuss in our webinar this week for In the Loop episode 2 was other solutions to that, and the other solutions can be virtual power plants. Of course, renewables is part of the decarbonised solution as well, but what we are wanting to discuss and ensure that everybody is kind of has some common thoughts is that we're not touting one against the other. We're talking about a kind of common approach. I've heard the term used by Cyril, actually, is just making sure the base load is covered, and that when more projects are coming online, making sure that there are already planned in solutions to make sure that that energy supply is there. I actually want to go to the next one here. So I have had some feedback that the levelized costs of energy for wind and solar are significantly cheaper than others. And that actually, yes, I'm sure that is a true statement. However, what renewables cannot give, as we know, is 24/7. The prices are unstable, demand goes up and down, it fluctuates. As I mentioned, there's access to the grid issues. And it is about having a hybrid energy system and not siloed. So potentially for e-fuel producers, think about actually putting it into plans. So I want to go back. You can't go back, can you? Yeah, you can't go back. You can't skip. Hang on. Are you able to help again? You can't go back, I don't think. You can't skip in between. To go back?
Yeah. Just wait a second. I'll put it up.
Okay. Well, anyway, I will carry on talking. Yeah, so what I want to go back to is the fact that for the planning, right, let's see. For planning purposes, I've had the conversation with different people. We're putting the point on the agenda, and people are kind of saying, yes, it's not a priority right now. However, if you are a project developer and you're thinking about, it might even be commercial plant 1, commercial plant 2, commercial plant 3. These conversations and off-takes can be actually taken now. They can be, because what is available is co-location, especially with small modular reactors, where there are more sites opening up because of the size of the production plants. So it could be that some of the e-fuel projects could co-locate close to SMRs, and they could also benefit from co-investment. There are now more banks opening up to invest in SMRs and nuclear. HSBC is one of them. And there are now 14 pledges for that kind of investment to happen. As we know that quite often with SAF production, banks are not even able to kind of go near SAF production. So it's basically opening up different opportunities to then think about co-investing, co-location. The SMR designs and the site location is taken some time to advance and to develop. And it actually is similar timelines to SAF realistically. So the considerations and conversations could happen essentially now. And the discussions with UK NNL as well as other groups is that we're working towards a hybrid energy system. As I said, it's not siloed. It's also not about political aspects. It's really making sure that we have got that decarbonised energy for the future to serve all our energy needs, our industry needs, our travel needs, housing needs. So this is a map created by UKNL. They've kindly donated it to me, but this is the thinking behind it rather than kind of putting it onto a not right now list. It's kind of like, think about it now. And these are, some advice. Is basically what kind of also approach. There are of course in nuclear as top issues and discussions on waste. Now there are also closed fuel cycles with nuclear materials. So it's also good to kind of look into this as they also have circular approaches, and actually there are ways and designs that don't need waste, which is usually one of the blockers. So that it's good to kind of start to think about some of these issues, and we are starting to look at the societal acceptance of it and unblock some of these issues for e-fuels for aviation net zero. And what actually could be an interesting I know, of course, everyone is concerned about what's going to happen in the US with policy, with some revoking of budgets and policies. What the Trump administration is happy to go ahead with is nuclear power. So potentially in some of these next 4 years, if there are concerns about bio-based or SAFs, then this could be another way to kind of invest in net zero aviation while kind of navigating the current political situation. So I thought that was kind of an interesting insight in the last month. So yeah, and there was discussion, of course, about it being a renaissance. It has actually been, the technology has been around since the 1950s, after post-war, and then, so it isn't new, but of course it has been less discussed or less popular. But with net zero really on our doorstep, I think the conversation is just opening up again. And also the investment and the opportunities. And of course, so the UK government really are now committed to that. As France, of course, is 80% grid already from nuclear. So I think in Europe, the European Commission are well, they're not agnostic. They actually refer to it as within their low carbon fuel wording. They just choose wording which doesn't use nuclear currently. So if you want to also see which articles that refers to, I've got some wording on that as well for you. So current status of what is happening, there are 65 reactors under construction and 400 planned. That is the report for the information, if you want to kind of get into more detail on that. The UK grid, yeah, we're currently using 300 terawatts. The prediction of what is needed is 600 to 900 by 2050. So it is absolutely within the maths of the, the needs for the UK. And that will be the same in, I'm sure, all countries. And interestingly enough, the airlines I've spoken to about this who believe within their countries they're not going to get access to bio-based SAF or materials are saying this is very interesting. They see this will be the solution for them for e-fuels, and some of the Latin American countries are saying this. So it is also kind of a new approach to making sure they also can make their e-fuels. And then, yeah, we've been discussing this kind of, it's some thought leadership. We want to kind of discuss everybody is understanding what leapfrogging is. So what we could do in principle, obviously it's not meeting short-term targets, but there is some debate about whether we'll meet 2030 targets anyway. Why not kind of plan for the longer time frames? SMRs can be online by 2033. So there's some opportunities for developers to really think about putting those projects in place for then, but of course starting the planning now. We are part of Project Sky Power. We're down there in the corner in industry associations, so it does make sense for the groups in Sky Power. Some will be able to kind of be supportive. Someone may be a bit agnostic at the moment, but that's kind of all part of the process. This was the same situation in SAF when I started the work in 2019, so there was obviously some resistance to SAF, but now that is, of course, a very different story. So we can use also what we've learned from the SAF industry to bring nuclear on board and to help unblock some of those issues in a quicker way this time. So yeah, how could you get involved now? We have been supporting World Nuclear Association to gain signatories for their net zero declaration. So they have just created a new declaration. The current one has 140 signatories of CEOs. The next declaration is about large end users, so aviation. Google will sign this. So I'm now working and speaking to different groups about who may want to be part of this declaration. And we have made a 25-page report, the one on the left. So you please kind of, I've sent this on to quite a few people here. We've made it very kind of high level with some of the timelines and some advice. And then what we can do is be a facilitator. So if you wanted more information on this topic, it's also got the declaration on page 11 in there. And that's the other report I've been mentioning. Oh no, I can't go back. That's the other report. We have a documentary also talking about some of our work. And then in summer, what many people probably don't know about is that Oliver Stone has made a documentary called Nuclear Now, and it tells a lot of the technical story. It is also supported by World Nuclear Association, well, fact-checked by World Nuclear Association. They've also fact-checked our report. And we're going to screen this in summer in London. And it's a very interesting and insightful and also a perception changer piece. So if you haven't watched it, I'm happy to invite you to a London screening. I think it's a really good piece for industry or anybody that is kind of thinking about net zero. So yeah, the way you can get involved is to join our membership, is to speak to me about the declaration if you've got any groups. I know there's some topics where they say we can't sign such a declaration at this point, but we are building up that momentum so that it really has, so that aviation is a stakeholder and it's not just, it's not in a lagging situation. We want to put it in as a kind of a first mover, like aviation can be. Aviation can be innovators. It can be very fast moving. So it will be great to have groups sign the declaration. I'm going to go to CERAWeek in Houston next month, and I will be there to support World Nuclear Association with their media announcement. So thank you very much. That's us. And yeah, look forward to, well, we're nearly at the end of the day, but look forward to any questions. Thank you.
Great, thank you, Sarah. Do we have any questions in the audience? What happened to all our questions this morning? We had so many. All right.
Was it a new topic to anybody? That's what I'm kind of interested in.
Oh, I like this idea. Let's ask them questions.
Yeah, because that is what I'm interested. Is it on anybody's agenda? That was like an interesting point. No, on nobody's agenda. Wow. Well, that's very good feedback for me. So thank you. Thanks very much.
All right, thank you. Thank you, Sarah. Our next presentation will be virtual and is on fueling innovation, accelerating the takeoff of eSAF in Europe. It's given by Amalia Danjou. I can see you. You are on our screens. She's financial and investment analyst at Green Finance Institute, and she will be guiding us through this presentation.
Great. Thank you. Can you hear me okay?
Yeah, we can hear you. It's maybe a little bit... Can the sound be put a bit higher?
Let me check.
On our side, yeah.
It says it's on full volume, but I can try and speak loudly if that's helpful.
Yeah, we also adjusted it on our side, so I think it's going to be okay.
Great. Okay, and I'll just share my slides. Just bear with me a second. Sorry, just having a very slight technical difficulty. Can you see that?
Something's coming up. Yes, we can see it.
Great. Okay, perfect. So I'll get started, I'll go through the presentation, and then we'll hopefully have a little bit of time at the end for some Q&A. So I start with a quick introduction. So thank you so much to all of you for your interest in Project SkyPower today. As the introduction said, my name is Amelia Dongju, and I'm here from the Green Finance Institute, which is one of the members of the Secretariat for Project SkyPower alongside Systemic and Mission Possible Partnership. I'm here today to present mainly on our open letter that we recently published last week on the 5 key policy asks that we need to have within Europe to have an enabling environment for the eSAF industry to be able to accelerate. And I'll give you a brief introduction to Project Sky Power more broadly, in line with our goal of making eSAF a commercial reality by the end of this decade. So if I move on to the next slide, if this wants to cooperate today. Perfect. So why is this a focus for us at Project Sky Power? Why do we need eSAF projects to be passing final investment decision by the end of this year? Well, eSAF in Europe, as many of you know, is a mandated market. And we have the mandate from Refuel EU Aviation to ensure that 1.2% of aviation fuel in supply in 2030 is from synthetic sources, so otherwise known as eSAF. Currently, we have a number of announcements for eSAF projects within Europe, but none of these eSAF plants have passed final investment decision. And as you can see on the slide, it's around 3 to 4 years for construction, commissioning, and ramp up of an eSAF project. So if we work back from the 2030 target, we really have only over the next 12 months to see the first final investment decisions on first of a kind commercial eSAF projects. What happens if we don't start seeing these final investment decisions happen? Well, this will delay the start of operations and really put the sub-mandate and the long-term emissions reduction trajectory of EU aviation out of reach. And this is why the conversations that we are having today are so urgent, and the window for meaningful action is closing rapidly. We really have a 12-month time period to get the conditions in place to get these plans, past final investment decision. So to give you a bit of a flavour in terms of where we are in the eSAF industry within Europe, so we've got over 30 projects that have been announced, which account to over 2 million tonnes of eSAF capacity across the region. However, the problem is that the majority of these projects remain in pre-feasibility or feasibility stages, which means that there are years between them and a potential investment decision. As I touched on the previous slide, we obviously have the 1.2% mandate that's coming in within 2030, which will require around a 600,000 tonne blend of eSAF within the 2030 aviation fuel market. When we've conducted analysis on the eSAF market, we can only really see 5 leading projects that have a high probability of being online in line with that 2030 target. And that accounts for only around 300,000 tonnes of eSAF. Now, even these projects still need some sort of support to be able to pass that final investment decision. And the ones that have a medium likelihood, so this second bar here, which you can see in blue, which shows 500,000 tonnes of SAF, they need then even more support in order to have the chance of coming online and obviously giving us the opportunity to aggregate those totals to have 800 tonnes of potential eSAF supply, which would obviously lead us to be in excess of the 2030 mandate. One of the things that we have identified within Project Sky Power is that all of these projects are facing a common set of barriers. And that's what's really led us to create the Project Sky Power mission, because we've recognized that this set of challenges is not one that any single player can resolve on their own. And so what we've done is to bring together all of the players across the eSAF value chain to create a common vision and to make eSAF a commercial reality this decade. We want to pave the way for the first large-scale eSAF projects in Europe to reach final investment decision over the next 12 months. So to give a quick indication of what would happen if we don't manage to execute on this, so the cost of not acting on eSAF is incredibly high. At the moment, the penalties will be set at least double the premium, so the difference between the yearly average price of eSAF and conventional jet fuel. And then you also will have the requirement to make up any shortfall in the subsequent reporting period. So as you can see on the slide, taking the levelized cost of ESAF, which is currently around 5 times the price of fossil jet plus the ETS price, and using this as an indication of what could be the market price for ESAF, you can see that the potential cost of non-compliance could be between 16,000 and 26,000 euros per ton of ESAF that's not complied with. This highlights an extremely high cost of not acting and really underscores the urgent need for investment within this market. So how do we plan on delivering this? Through significant engagement with members across the ESAF value chain, Project Sky Power have developed a 10-point action plan, which we believe will help establish the ESAF industry within Europe. So we've split this into two sections, the short-term actions, which are highlighted on the slide, which we are focusing on in the near term. These ones really tie in with getting these first plants past final investment decision. And then on the right-hand side of the slide, we've got our 5 longer-term actions, which really help to establish a long-term, stable ESAF industry within Europe. So touching on these 5 short-term actions very briefly before I go into the work that we've done from a policy perspective. So these have been split into 4 key categories. The first of which being around regulatory certainty, so ensuring that we have policy certainty on mandates and penalties. The second being to bridge the premium with public funding, but to make sure that any public funding commitment secured is used in the most catalytic way to make sure that we are splitting the burden between public and private finance. To stimulate demand for ESAF, so to be done through establishing structures for bankable offtake contracts. And then finally, to unlock investment through both establishing low interest loans and guarantees, but also through developing effective risk sharing models across public and private market participants. So as I touched on briefly, our primary area of focus for the early part of 2025 has been on the policy ask perspective, and that's what I will be talking throughout this presentation. So we published an open letter to the European Commission, which went live last week, which referenced 5 key asks, which we think are necessary from a policy perspective to really create this enabling environment for ESAF production within Europe. In terms of who has contributed to this letter and who is involved with Project Sky Power more broadly, this slide gives a flavor of the organizations that we have engaged with in order to develop this list of interventions. So we've worked with members across the entire ESAF ecosystem in an intensive period of consultation and collaboration over the last 2 months, and over 70 organizations have unified their voice behind these 5 critical policy asks. And it's been, from a personal perspective, absolutely incredible to see all of these stakeholders come together from such different starting points to really unify on a common ground. And I think that's such a true testament to the readiness of this industry to work together and take action in order to progress the collective goals and really get some acceleration and get it off the ground. So why ESAF? We see ESAF in Europe as being a very strong strategic opportunity for the following 3 reasons. Firstly, it's the ability to strengthen the domestic industry, to improve energy security, which will spur renewed investment, job creation, particularly within the regions of the chemical and the fuels sector. And it will also increase the resilience of aviation fuel supply chains within Europe. Secondly, is the opportunity to position ourselves within Europe as a global leader in ESAF technology, which presents the potential to unlock a 350 billion euro opportunity. And finally, is the opportunity to advance the region's climate targets in what is a hard to abate sector that currently accounts for 2.5% of global CO2 emissions. Europe is the epicenter of ESAF activity. So 60% of all ESAF projects that have been announced globally are concentrated within Europe. And this presents a real clear advantage for Europe and an opportunity to gain a head start. Refuel EU is a critical starting point, but it's not just up to policy to solve all of these challenges. And we believe that industry leaders, particularly the ones that have balance sheet and risk appetite to do so, must take bold action to ensure every effort is being made in this space. But to accelerate the process, and if we want to have any chance of meeting these 2030 targets, we do need additional strategic policy support in order to alleviate some of these key barriers. So I'll touch quickly on what these 5 key asks are before going into them in a little bit more detail. So together with the members of our broader ESAF ecosystem, Project Sky Power has identified 5 critical policy interventions that are needed within the EU to accelerate progress on ESAF. So the first of which is to make ESAF a strategic priority in both the Clean Industrial Deal and the Sustainable Transport Investment Plan. Secondly is to recycle ETS revenues from aviation to capitalize a market intermediary that would enter into auctioned 10 to 15-year contracts with ESAF producers and 3 to 5-year contracts with off-takers. The third aspect would be to establish a bridging mechanism which would cover the time between now and when a capitalized market intermediary would come online to give first movers priority access to any new funding instrument. The fourth point is to provide long-term certainty over EU mandates, production criteria, and penalties. And the fifth is to mitigate project-on-project risk via a government-backed safeguard and financing structures. So going into a bit more detail, starting on point 1, which is to make ESAF a strategic priority within the EU's Clean Industrial Deal and the Sustainable Transport Investment Plan. So the upcoming Clean Industrial Deal is to be published towards the end of this month, and the Sustainable Transport Investment Plan is expected later this year. And both of these offer a critical opportunity for ESAF to be recognised in the EU as having high strategic importance. In particular, the recognition as part of the Clean Industrial Deal would send an important signal which could accelerate the mobilisation of capital and secure the EU's leadership position. And secondly, within the Sustainable Transport Investment Plan, this provides an opportunity to really specify a detailed investment roadmap for ESAF and really explain how it can be developed in order to meet the increasing refuel aviation sub-mandates, giving confidence to the sector that these sub-mandates are achievable and will be upheld. It's an opportunity to identify the most efficient and effective instruments for supporting these first projects, which brings me on to the following 4 policy interventions. So the first of which is number 2, which is to create a market intermediary which would solve 2 key challenges in the ESAF space, which are not currently being addressed by existing policy support. So these challenges revolve around, 1, on the producer side, the need for long-term revenue certainty from a credit-worthy organisation, which we are proposing would be solved by a government-backed market intermediary that would enter into long-term offtakes with ESAF producers for a 10 to 15-year time period. And then on the other side, we have it from an off-taker perspective, where off-takers really need to manage price risk, particularly given the perception of potential future cost reductions in the ESAF production. And so the management of this risk is enabled by the market intermediary entering into short-term sales contracts with off-takers. And these off-takers could be the likes of suppliers who would be obligated under Refuel EU, but also the likes of airlines and freight forwarders. For this mechanism to work effectively, it's very important that it has a high creditworthiness. And so it's very important that the market intermediary is backed by the government. The model has already been developed and put into practice by H2 Global, and it's been demonstrated to some extent in the H2 Global pilot supply-side auctions, which have been held by HINTCO, the market intermediary for e-ammonia. And finally, it's not just about mitigating risk through the asymmetrical contract durations, but also this instrument can be capitalized to keep European ESAF production and the aviation industry within Europe competitive by recycling the ETS revenues from aviation to bring down the price of ESAF and to level the playing field. This is particularly important when you think about other regions which potentially have access to low-cost feedstocks, such as renewable energy, and access to government subsidies. As they begin to ramp up their production, it's very important that Europe remains a competitive place to purchase ESAF. Now, one of the problems with a mechanism like this is that it takes time to implement. And in the most optimistic scenario, that could be between 1 to 2 years. So there are a number of regulatory and operational stages that need to be passed before it could come into effect. And for this reason, we are proposing to establish a bridging mechanism that would avoid a scenario where the market waits, so no offtakes are struck between now and whenever a market intermediary comes into effect. What this bridging mechanism would do would be to offer certain offtakes which meet specific criteria priority access to the market intermediary when it comes online. And this should really help to mitigate that early mover disadvantage and allow projects to gain that revenue certainty that's required in order for them to pass final investment decision. Moving on to point 4, which is around uncertainty. So this presents a key challenge to getting investment into this space, and we split it into 3 critical aspects. The first of which is around whether the mandates will continue to be upheld after the planned review of Refuel EU Aviation in 2027. So I'll highlight here that the review is a standard part of European regulation, and the Commission is required to review but not necessarily revise the regulation. However, that doesn't solve for the huge market uncertainty around this topic. Obviously, you don't want to have a significant amount of investment flowing into an industry off the back of it being mandated, and then for those mandates not to be upheld. What we need in order to mitigate this is clear and early communication around what potential outcomes could be of this discussion, in particular to have guidance in what would happen in the event of an anticipated shortfall in 2030. We expect that this would provide some much needed confidence to the sector and would encourage investment. Secondly is on the penalties. So there was a target for the end of last year for member states to provide guidance around what these penalties would look like. And to date, no member states have actually provided that guidance. So until we receive that concrete information, we can't properly assess or account for what those penalties will look like. And this is a really key barrier in terms of securing investment. Crucially, we also need harmonization of penalties across member states to assure things like a level playing field, to avoid market distortion, and to have ease of implementation. And we do know that the European Commission is working on this alongside several member states, but again, this is something that we do need further clarity on. And finally, it's around ESAF production criteria. So investors need certainty that any ESAF that is produced today will still be eligible under Refuel EU in years to come. And therefore, it's necessary to introduce grandfathering principles that ensure that current regulations would apply over the full lifetime of a project. And then finally, moving on to our last request, which is to mitigate project-on-project risk via a government backstop mechanism. So why do we need this? Well, an ESAF production facility being able to operate and produce ESAF in line with expectations is dependent upon them being able to obtain sufficient feedstock. You can have a plant that is built on time, on budget, but if they can't get feedstock in, then they can't produce the synthetic aviation fuel. So if you think about core feedstocks that go into ESAF production, such as renewable electricity and carbon dioxide, each of these carry their own delivery risks, which providers of finance struggle to get comfortable with. So for example, if you think about under Refuel EU, the electricity to be used to produce ESAF comes with very strict requirements, which often mean that new renewable energy sites need to be developed such that the electricity is additional. Or using the example of carbon dioxide, point source carbon capture is a relatively new and complex technology, and its delivery depends on the development of a centralized CO2 transport infrastructure. In both of these examples, the availability of the feedstock depends on factors that are outside of the ESAF producer's control. And that's what creates this project-on-project risk, which really presents a challenge when trying to get ESAF project past final investment decision. So what we're proposing as a mitigation method is a financial backstop, which would provide coverage for fixed costs, such as fixed OPEX and debt service payments in the event of this scenario that a plant can't operate for reasons outside of its control. We're proposing that the mechanism could be underpinned by funding from the European Commission and should come with strict eligibility criteria to minimize any chances of the backstop being triggered. So moving on to my final slide, we appreciate that this is not a small ask and it's not an easy task either. So I wanted to highlight quickly our 3 main priorities over the next 10 months to lead us to success in our goal in getting first of a kind commercial ESAF plans past final investment decision by the end of this year. So as it says on the slide, number 1, to explore and advocate for a market intermediary model and for that to be introduced under the Sustainable Transport Investment Plan. Secondly, to support long-term bankable offtake agreements and to explore policy incentives for first movers. And then finally, to establish de-risking mechanisms and models for first-of-a-kind ESAF projects, such as guarantees and backstop mechanisms, which share risks between public and private stakeholders. So thank you for listening. If you have any questions, the email address for our secretariat is on the screen, and I'll happily take any questions.
Thank you. Thank you, Amelia, for your presentation. I'm going to look if there are any questions. I don't think there are any. So thank you again for presenting to us.
Thank you.
All right, this brings us to the last presentation before a short break. This presentation is on green energy integration into SAF production. It will be given by Stavros Mikhailos. I hope I say your name correctly. He's a lecturer in chemical engineering at the University of Hull. Welcome.
Yeah, so hi everyone, my name is Stavros, I come from University of Hull. I joined a couple of years ago. Before that I was at Sheffield University. This is how our beloved university looks like in a sunny day, which is very rare up there. About SAF. Yeah, I started working on SAF probably in 2016 when I was at Aston University. Back then, working on a SuperGen project. So the project was about doing a literature analysis of different feedstock and different processes to convert lignocellulosic to sustainable aviation fuel. Then when I was in Sheffield, I was leading the theme of process modeling. So we do have in Sheffield a small pilot plant that produces SAF through Fischer-Tropsch. When it becomes operational, it will produce around 50 liters of SAF per day. And recently in Hull, we are developing bioreactors. Basically, we want to ferment cellulosic feedstock to lipids, and then these lipids can be easily upgraded through the HEFA process to SAF. So today I will be talking about my research on power to SAF, BECS to SAF, power and biomass to SAF, direct air capture, and post-combustion capture, and how this can be all integrated with SAF. And we'll be focusing on techno-economics, life cycle assessment, and a bit of policy analysis. The first one that is basically we try to replicate what exists in our facilities at Sheffield University is the power to SAF. We have modeled a scaled up plant, okay, and we have considered for the provision of electricity an offshore wind farm located in the Teesside, low temperature duct technology, which is pretty much similar to Climeworks, the reverse water gas and the Fischer-Tropsch, and obviously the purification upgrade and some heat integration. Hull itself is in the heart of the biggest industrial cluster in the UK. By biggest, I mean the most pollutant, the cluster that emits the most CO2 than any other region. But we see that as an opportunity. Okay. Here, as I said, we used offshore wind to supply electricity, which is a big thing in the northeast of the UK as well. We used relevant modeling tools to basically predict, based on weather data, the electricity generation. And we have used the grid as a virtual energy storage for this analysis. So no batteries, but obviously we need to pay a fee to the grid, to the network operator. These are some of the technicalities when it comes to the Fisher tropes. There are many things that they are under investigation, and we are trying to resolve them. Well, we try to analyze them initially through process modeling, and our goal is to narrow down the operational window when we go to pilot campaigns. So the reverse water gas operates at around 800 Celsius, meaning that we need to supply quite substantial amount of energy at and of quality at high temperatures. The Fischer-Tropsch, on the other hand, operates at lower temperatures and pressures of 25 bar. But the interesting thing about the Fischer-Tropsch is that we can extract some heat out of it and basically supply this heat to the DAC operation, minimizing cost and energy demand for the direct air capture. As I said, for this study, we used data from Climeworks, data publicly available. This is simply a graph of how we did the heat integration to minimize energy costs. This is how it looks like. This is the carbon balance across the whole system. You can see that 53% of the carbon ends up to jet fuel. There is some for diesel or naphtha, and much is most of it it can be converted to usable fuels. The electricity demand was calculated at 200 megawatts, and almost 90% of that goes for electrolysis. We do have a low hydrogen efficiency, but this is an inherent problem of Fischer-Tropsch. It dumps lots of hydrogen as water. It's just a reaction chemistry. We cannot do much about it. The techno-economic results show the minimum jet fuel selling price of slightly higher than 5 pounds per kilo of SAF. This is below the current SAF mandate buyout for e-fuels in the UK, which is 6.25. But still need to mention that this analysis was made for an end-of-a-kind plant, okay, and not for the small pilot plant that will be soon operating. Based on the sensitivity analysis, the highest contributor to cost was the electrolyzer island, electricity price and hydrogen cost, followed by the CO2 capture cost. We performed also cradle to grave LCA, and we have calculated a global warming potential of around 20 grams of CO2 per megajoule. We compare that to current mandates and directives, with the SAF mandate in the UK, we are way below the threshold. Also with the RED II, again below the threshold. And another thing is that we used energy allocation for the LCA. We think that this is more relevant for fuel production when it comes to allocate emission to to the byproducts. We did also calculate the certificates based on the SAF mandate. This is how the government, the UK government, induces to calculate the number of certificates that the process is eligible for. And you can see here this CI factor, okay, carbon intensity factor, that has another formula to be calculated and is based on fossil jet fuel, the estimated SAF of the investigated process, and the average SAF carbon intensity factor, which, if I'm not mistaken, assumes 70% reduction compared to fossil jet fuel. Basically, the SAF mandate is based on LCA, incentivizes lower global warming potential processes. So what we did in this graph, what you can see is we plotted basically CO2 capture cost and hydrogen production cost, okay, and what you can see is with this different shades of the green color, at which price of the certificate cost the project breaks even with the fossil jet fuel cost. In our case, these certificates can be sold for 0.1 pounds in order for the process to break even. You can see that we calculated hydrogen production cost of roughly higher than 3 pounds per kg, which is quite optimistic. And same appeals for the direct air capture cost, that is slightly lower than 400 pounds per ton of CO2. But yeah, as I said before, these are nth of a kind cost, okay? And for the direct air capture, there are some savings because of the heat integration with the Fischer-Tropsch plant. We also investigated back to SAF process. So basically, we wanted to see the integration of Fischer-Tropsch now with gasification and carbon capture, if we can achieve negative emissions through that. In this case, the feedstock is sustainable sourced forest residues from Scotland at 20 dry tons per hour. And the CCS is something also, a unit that also exists at our facilities in Sheffield, carbon capture, a conventional one based on amines. No. Yeah, I think I have the same issue. I think I need to go back, but I can only go forward.
Could you help go back one slide, please, as the clicker is not working?
Yeah, I think, yeah, Chair, thanks. This again, the carbon distribution for this case. Now you can see that basically only 16% ends up in the jet fuel, and almost 25% to valuable products. 31% can be stored, and you can see 43% is lost as flue gases. Well, the gasification itself that was dual fluidized, where basically we burn lots of the char to provide energy to the other fluidized bed where the gasification takes place, but also for the cleaning section of the syngas, especially for tar removal, we need to spend lots of energy, and in order to cover this energy demand, we burn some of the syngas that the gasifier produces, meaning that the final output of jet fuel reduces by a lot. In this case, we do have a much lower minimum selling price of 3.27 in the case that we add CCS, and in the case that we don't add, we can see that CCS increases the overall cost by only 8%, okay? And here the main cost contributor is CapEx, followed by the feedstock price. LCA results, again, we compare the BECS with a scenario that there is no CCS for different allocation methods. You can see regardless of the allocation method, the inclusion of the CCS reduces by a lot the global warming potential, and we can achieve a process with high carbon, negative carbon intensity. I'm going to speed up a bit, and this is basically combining these two processes, okay? And the feedstock is forest residue, but we use also some electrolytic hydrogen to boost the hydrocarbon production, the jet fuel production. We investigated these different scenarios. You can see more details in the attached paper. Again, techno-economic assessment, the CapEx, OpEx, and we have seen that for most scenarios, because there are some CapEx versus OpEx trade-offs, the selling price is more or less the same for everything, around £3 per kg. Again, LCA results, for most cases, we can achieve negative emissions, and then it's all again, I guess, in a way, there's a trade-off between how much CO2 and how much fuel you produce. So I guess what configuration you can chase all about selecting a business model, making the CO2 selling credits, or producing more SAF. Again, similar policy analysis based on SAF mandate. We can at the moment, there is no incentive for negative emissions. Basically, there is no CDR business model in the UK. Okay. We assumed in the first scenario in the A graph that there is acknowledgement of negative emissions, and we can see how the price of certificate changes from 0.025 to 0.037. We do lots on direct capture. One study, one project that is currently running is integrating with conventional post-combustion capture, and we can reduce, we can halve the energy cost with this approach, and also the DAC unit can share some equipment with the conventional post-combustion, which means we can have also potential CapEx reduction. And one of the advantages is that we use non-proprietary solvent, MEA, cheap, with lots of data in terms of physical and chemical properties available. This is the cut design. The PCC is the post-combustion absorber, the DAC absorber, the water wash, and this is the LAC equipment as delivered some months ago. So right now we are at the stage that we are putting everything together, setting up the lab, and as future work we will calculate all the necessary data to allow us to scale up the technology, mass and transfer, modeling, and techno-economics. This is the work we've done also on post-combustion CO2 capture. The focus here is to capture the whole amount of the fossil CO2. We have examined that in several industrial applications like cement, oil refineries, energy from waste, and steel. And we have seen that with a proposed design and design that has been tested in pilot campaigns from SSE. We can see that we can achieve comparable to 90 or 95% capture energy cost below 4 gigajoules per ton of CO2. Techno-economic assessment on energy from waste and biomass from waste, because the flue gas has pretty much similar properties from both applications. For 95%, which is the current benchmark in the UK, we calculated a capture cost of 93, which increases to almost 95 if we capture the whole amount of CO2. The gross capture cost or the residual capture cost is around 126, which is much lower than any current DAC cost. Now, future work is to integrate this post-combustion using biogenic CO2 from biomass and or waste, and integrate it with the SAF, and also perform the necessary techno-economics and LCA. Now, to finish off, still don't have any pictures from lag equipment. They are about to arrive. What we are going to be doing now in Hull will be basically fermentation. We will use again cellulosic feedstocks and upgrade them to lipids. The main goal for this project is basically to diversify the feedstock of the conventional SAF process, i.e. HEFA. And we will follow we will do all the things, design, scale up of the system, techno-economics, and LCA. Acknowledgements to the funders and collaborators at Sheffield University, and thank you, and I'm open to questions.
Thank you very much. Are there any questions? I'm getting desperate for questions here. All right. Well, if there are no questions, I'll thank you very much for your presentation again. We will now move into a break. And unfortunately, after the break, I won't be able to chair the last 3 presentations, but I will give back this to the lead event that will host you. So I won't see you back, so I'm saying goodbye now, and hope you enjoy your break before diving into it again.
I will be here instead of her. So for next session, we have here Helena Rodriguez, who is Sustainable Consultant and SAF Resourcer from Netherlands Airport Consultant. Her session is about the role of airports in signs of SAF uptake at airports. Floor is yours.
Thank you. Well, thank you everyone for being here. I see we lost some people along the way, but it's fine. My name is Helena Rodriguez. I'm a sustainability consultant at NACO, Netherlands Airport Consultants. We're a consultancy and engineering firm with over 75 years of experience at international airports. Recently, we released a white paper on what airports can do when it comes to the uptake of SAF. So my presentation will mainly be about that, with a small focus on a project that we did a year ago on a small European airport. Yes, so I think this was mentioned quite a lot during the past 2 days. So we know that SAF deployment requires quite close collaboration, but this is mainly important for airports as well, since they have been on the sidelines for a long time. They're not really in the system, they're kind of on the side. That's why they're also quite confused of when it comes to SAF uptake and what they can do or what they should do. I think it was mentioned in one of the presentations before. They're really confused. So it's a little bit of a complex system for them, which is, I think a lot of you know how the SAF supply chain works. However, for airports, it's very complicated. We try to map it out. This is a very high level way to map out the SAF supply chain for airports, and airports are somewhere there, but they're not directly implicated when it comes to the uptake of SAF. So it's mainly, between fuel suppliers and airlines, and the airports are just there. Most of the times they don't operate or own their fuel farms. So when it comes to SAF, sometimes, there's quite some limited things they can do. So we determined certain spheres of influence and scopes of influence the airport can have. We identified 3 different ones. Of course, airports, as I mentioned, they have limited influence over what they can do with SAF, but for airports to understand this, and as well for regulators and even airlines and fuel suppliers, is quite complicated for them to do. So we identified the core sphere, which is the direct influence of airports. This entails airport operation, airports policies internally, and internal stakeholders. This can also involve passengers sometimes, so promoting SAF or marketing SAF to passengers a little bit more directly. Then we have the strategic sphere, which is the indirect influence. So that's where airports behave more as facilitators between, airlines, fuel suppliers, sometimes local or national governments. And then we have the external sphere, which is where airports actually can have quite a lot of power, and they are not using it yet. Mainly in the EU, they can have quite some advocacy when it comes to policies. However, they're not really confident to do that. They don't really see the value of that, but we have seen in a lot of other congresses like this one, and in some of interviews that we made, that this is quite valuable for the industry, but airports don't see themselves in that role. However, we want to encourage airports to really be more vocal about the uptake of SAF, despite not having a direct influence per se. They don't really use fuel themselves. They just, provide the infrastructure for airlines and fuel suppliers to do it. The advocacy part can become really important for them. So, we defined 5 considerations for airports so that they can, see what scope of influence they have. And I will get into detail on these aspects on my next slide. So first we have the ownership and management of fuel infrastructure. Airports really need to understand what, they have to identify their own ownership. Sometimes they're owned by the government, sometimes they're owned by private parties. It's quite complicated, and for them to understand it makes it easier to see where they can have a bigger impact. and then that leads to, they have to understand the ambitions of airport shareholders. Sometimes some ambitions for SAF, for example, can be quite high. Sometimes shareholders are not interested, so that really limits the influence of airports. It was also already mentioned in other presentations, partnerships and engagement are equally important for airports. So identifying certain partnerships and engagement strategies for them is really key to see where they can add more value. We have the local context. Some airports have this advantage of where they are. For example, Schiphol Airport, where it is, they can have quite some influence. There's a lot of stakeholders, Sky Energy, Neste. So they have quite an advantage, and they're an outlier of airports. But when it comes to smaller airports, it can be a little bit more complicated. I think there was this airport in the UK, a really small one, and there was a SAF plant being built close by, so they took that as an advantage to invest. The shareholders were interested in it, but of course that's not always the case for some airports. Lastly, this way they can determine the scope of influence in the sphere that I showed in the previous slide. Yes, and we then came up with a guiding framework so that airports can get more involved in the uplift of SAF. They do have to identify and understand the policies and mandates that can implicate them. For example, Refuel EU, many of them don't understand what this means for them, what they can do, how are they going to be fined, for example, what they have to report is not clear, so they have to try to understand it as far as they can, because policy is also not direct enough for them. Then they have to map the status of the airport, its scope of influence, the supply chain, which is we found out it's quite difficult for them to do and quite tedious. They don't really understand their own supply chain, which makes it more complicated to see where they can have an impact. Then they do have to define the role they want to take, where they want to influence directly, externally, indirectly. It really depends on the airport's own ambitions. Then, of course, designing and planning, which is coming up with strategies for short, medium, and long term that they can do to help this uplift of SAF. Yes, so now we did a case study for a small size international airport in Germany. Well, it was more of a project. A little bit of background on the project is, the local government owns the airport together with the state of where the airport is located, and they had previously conducted a fuel feasibility study to produce SAF in the area, which turned out to be not feasible. Due to where it was located, the fuel suppliers weren't interested, so there was no really, so that was not feasible. The airport does have a SAF incentive in place, which has not been used, so we were also tasked to find out why airlines were not interested to using this incentive at the airport. Also, the German government has introduced several measures to support Refuel EU, but most of them really support bigger airports. When it comes to smaller and medium-sized airports, then you see kind of like an issue. The local government had actually really high ambitions compared to what the airport could do, and there was a big pressure from the government to the airport to really do its best when it comes to the uplift of SAF, and that was quite challenging for them. The goal of the project was that the local government wanted us to explore other strategies as part of the previous feasibility study to see what the airport could do, aside from having maybe physical SAF or what other things the airport would be able to do. They wanted us to assess strategic roles and options for the airport and foster collaboration with stakeholders. So what we did was try to understand the current fuel supply chain. We conducted several interviews with the fuel suppliers, government, airlines, the airport itself. It was quite not a long project, but we did do quite a lot of interviews. and we try to identify trends and opportunities, which the outcome, of course, we provided them with a future growth outlook of staff, which, I mean, in reality, it was not feasible because the airport was, it's not connected to a main fuel pipeline, so that made it also more complicated for them to really adhere to Refuel EU requirements. We determined their sphere of influence, which was more external, advocacy, and maybe some, to passengers, but still, it was not enough for what they really expected, unfortunately. And we provided them with a roadmap for the airport and for the local government to really try to understand what was happening. So some of the lessons learned from this project is that, there is quite some opportunities for an improved understanding and enhanced communication among stakeholders. There was quite a mismatch between what the stakeholders wanted, what the airport wanted. They weren't really talking to each other, which really made the project a little bit more complicated to understand. The ambitions of the local government were not really aligning with the local context, which of course can be good when it comes to having high ambitions and trying to drive up the uplift to reach those ambitions. But in this case, it was actually putting too much pressure on the airport, and they could, there was really quite limited actions they could actually do to meet those ambitions. So it was a little bit difficult for them to get to that level that the government wanted. There was a need for transparency and information sharing for fuel suppliers. Of course, it's understandable why there is quite some secrecy and not sharing of certain information among fuel suppliers, but it made it quite complicated for us to really map out the fuel supply chain, understand where things were kind of hindered for SAF not to be uplifted at this airport, why airlines did not, were not trying to get the fuel suppliers to bring SAF to that specific airport. So it was quite difficult for us to really get behind of why that is. And again, we also gave them the advice that the incentive at the airport should be reassessed. A lot of the interviewees mentioned that it hinders the uplift rather than, helps it. And IATA actually published a position paper of why airports should not have incentives. It should come from the government, but not from the airports, since it really hinders competition sometimes among airlines. And lastly, there was quite a need for a roundtable with relevant stakeholders. We tried to have this, and we advised to have more of a collaborative roundtable with really all the stakeholders, but it was not really, we weren't really helped to foster this. And a lot of the fuel suppliers, as well as airlines and the airport, would mention that this would have been really useful for them. However, it was not really possible for us to do due to the context. So I think that's what limited us quite to really deliver something that matched the expectations and the ambitions of the government, for example. And that was my presentation. Thank you. If you have any questions, let me know.
Can you tell us a little bit more about why the production of SAF wasn't feasible next to the airport, and specifically also which technology you were investigating for this analysis?
Yeah, actually the previous feasibility study was not done by us. It was done by another company. We were only provided with like the high level results of it, which also made it a little bit more difficult for us to understand why, why the SAF couldn't get to that airport. From what we understood, they looked into more specifically PTL SAF, but yeah, we didn't get like specific results, unfortunately. So even for us, it was a little bit difficult to understand. So I'm sorry.
Hi there. Thank you. I'm just wondering if you agree with what Andrews mentioned before that none of the airports are really aware of SAF.
Yes, that's correct. And we have seen not only with this airport, but other airports that we have talked to, what they know about SAF is quite limited. A lot of them actually have asked us, like, what about blending on site? Which we really strongly recommend against it because of all the implications that it brings. And it can be, you know, if one drop is contaminated, it can ruin a whole batch of fuels. And airports are very limited in space, so really having a blending facility on site is not, yeah, it shouldn't happen. And yeah, we have definitely encountered a lot of airports that have trouble understanding why they're being asked to have SAF, but at the same time, they have never really dealt with fuel specifically. So it's...
And do you have relationship, how do you work with maybe like ACI or ARC?
Well, with ACI, actually, we have kind of like a masterclass, so to say. So we worked with ACI Africa, where we delivered some classes on SAF, actually, and SAF deployment, and we hope that we can continue doing that in the future. So we do work closely with them, mainly with ACI. We're currently developing ESG framework for ACI, but yeah, when it comes to SAF, a lot of times it's the last thing on the airport's mind, which is a little bit unfortunate as well. And yeah, it's a little bit complicated of where airports lie in the whole system. So we're trying to make them really understand where they place and what they can do.
Yeah, like their role.
Yeah, exactly.
Quick question, can you say which airport it was and if it's covered by the Refuel EU directive?
I unfortunately cannot say which airport it was, but it is covered by Refuel EU. That's why we were also asked to do this research, because they will have to report on Refuel EU. Unfortunately, when they commissioned this project to us, the full guidelines of Refuel EU were also not out, so it was difficult for us to really provide them a full advice on what they can do. And it's still very confusing of what airports can actually do, like airports like this one that are medium to small, they are already have to be reporting on Refuel EU mandate, and they still don't know how or what because it has not been told by them, by the Commission. So it's quite complicated when it comes to those airports. Yeah, I hope that answered your question a little bit. Yeah, sorry.
I had also a question. In the case of the Netherlands, isn't it true that all the airports are connected via pipelines to the, let's say, refinery where the jet fuel is being provided? So in this case, you don't have this blending issues?
I think not all airports. I think the Schiphol, yes, it's connected to the pipeline, so they don't really have an issue. And also Schiphol is quite an outlier when it comes to SAF uplift, for example, but I know for Eindhoven airport, it's delivered by truck, and the same, I think for Rotterdam, the Hague airport, I think it's also by truck. I'm not sure because it's quite small.
All right. Yeah.
Yeah.
Thanks.
Yeah. Thank you.
So I think that's all. Thank you so much.
Thank you.
For the next session, we will have Nicolas. Nicolas will do the session about Travel Green, making it easy to book your least pollution flight. He's a co-founder from Book Better. The floor is yours.
Thank you. Hello all. First of all, thank you for still being here, the last part of the event. But great to see there's still a little bit of crowd in the room, although less than before. Today I would like to introduce you to Book Better. But first I would like to ask you a question. Who of you came by flight to Amsterdam? Hands on? Okay, quite a few. And who of you chose the most sustainable flight option, including SAF? Well, not enough hands, none of them. So good that I give this presentation because hopefully by the next time you have an event, you will do so. Book Better. What are we doing with Book Better? We are trying to make it as easy as possible for consumers to book the most sustainable flight. And with that, make it the aviation industry better. So who are we targeting? So if you look at the European airfare market, it's around 127 billion. That was in 2023. And if we take only 1% of that, so 1% of the travelers, and roughly 20 to 30% of the people books fine OTA, we still end up with quite a significant market, right? So 350 million of airfare. So who are these people that want to travel more sustainable? We see three groups of people. So we see the SMEs and freelancers, which actually can reimburse the cost to their clients. We have quite some contacts already with sustainable tour operators and events and festivals. So they do a lot already in providing sustainable options at locations. For example, in Lapland, or doing travel to glaciers, or have an event where the food and everything is more sustainable. But the travel to the destination, they often cannot consider, or they don't have a lot of influence in. So they want to have more sustainable options for that as well. And then there's a group of eco-conscious travelers, which are really willing to pay more for a more sustainable flight. What we see currently in the market is that those people are not well served by airlines and OTAs. For example, if you go to an airline website, often only at the end of your booking, you have like a small checkbox with, I want to offset my flight, or sometimes you have to look for where the SAF is hidden in the booking flow, or it's in the middle of the booking flow. And it's quite painful, right? The moment you look for the flight, your flight is maybe 100 euros, and then in the end of the booking, you have to add another 100 euros for your flight, and you cannot make an easy comparison anymore between the different airlines. One of the reasons why the uptake in those cases is quite low. Well, we also see that the most conscious travelers, they don't want to have 20% SAF on the flight, but they want to have an emission reduction that's at least 70, 80% or higher. Sometimes 20% SAF we compare to giving a 20% vegetarian steak to a vegetarian, right? It's something that will not work, and people are not really accepting. So we want to do it different, and we want to give 100% SAF on every flight. So how do we do this? At Book Better, you can search your flight just a normal way as you can do at Expedia or Booking.com. You can fly any airline you want at any time, right? Just you can use a regular flight. However, we calculate how much fuel you'll use for that flight, and then we purchase SAF for that amount of fuel. So we work together with suppliers to purchase that fuel. And you, as a customer, in the end, get a certificate as well to make sure we can really show and prove that the SAF you bought, we actually delivered to the airlines and the airports. So here, a little impression how it will look like. So it just looks like a normal booking page where you can book your flight. However, there are quite some differences. For example, the price we show is the airfare plus the price of sustainability. In this case, we start with SAF. However, in the future, when hydrogen aircraft, electric aircraft will be there as well, we will include those as well. So we combine the price of your airfare with the price of sustainability, so you can make a fair comparison between price and sustainability in one go. So that's where we also rank on. We also are working already to include other sustainability factors like contrails as well. We know they have a very big impact, so we also include that in the ranking as well, but also other sustainability efforts of airlines. What we want to make sure is that airlines that are doing best actually rank up highest in terms of price and sustainability. So the work they do and all the hard work, which is sometimes unseen by the consumers for sustainability, is also rewarded.
Can I interrupt you with my question?
Yeah.
How do you measure? Do we have an idea today?
Yeah.
Thank you. Do we have an idea today how to measure those additional sustainability efforts?
Yes.
Yeah?
Yeah, so for the contrails, we do have. So we are working together with one of the companies that is doing estimations on contrails. So we can already predict quite a bit how much contrails you will have. So we can factor that in the price as well. And for now, we're also looking at there are some rankings out there which say, okay, which airport are doing better. So we do have some metrics. However, for the first version, and we will see later, we work on the first version, we will focus on the SAF for now.
Of course. Well, thank you.
And we also stand for transparency, right? So we want to show your typical airfare, but also the additional cost of SAF on it. We want to be as transparent to consumers, so they see what the SAF of a flight costs normally, but also to show them this is actually maybe the true price of flying. For now, it will be all based on HEFA SAF, but in the future, we also want to include eSAF and other types of SAF to the platform. We also see the need of educating the customers. I think a lot of people don't know how much a flight emits and how bad it is for the environment. And we also want to ensure that all the purchases you do, you can also look back into the registry to really have a rigid method for people to look up the emission reductions they have. We really aim to build a strong brand so that people are at the dinner table can tell their friends, hey guys, yes, I flew to visit my family or for my holidays, but I used Book Better to do so. So we aim to close the say-do gap. A lot of people want to travel more sustainable. However, it's not always easy. They don't know how to compare it. So we really want to close that gap. We also see that we can collect a lot of valuable data because we are targeting a very small niche of people. However, this group of people is growing, right? So we want to know where can we find them, how can we find them, and with that we can uplift additional stuff and help the airline industry to become more sustainable. And maybe last but not least, we also want to make sure what I said before is that airlines that are doing best will rank up at highest as possible, so they get awarded for the hard work they do on sustainability. And why has this become especially relevant right now? We see or we heard the past 2 days a lot that we can, on the technological side, we can do a lot, right? We can make eSAF, we can try all different technologies on hydrogen batteries, but in the end, it is what the customer can pay for it and wants to pay for it. So we really want to focus on creating the demand for sustainable travel and that people start to pay more, a little bit more, for a more sustainable flight option. At the same time, what we also see right now is that producers, airlines sometimes are struggling with buying additional stuff right now. And also the market has become more uncertain, right? We see a lot of government changes. We see that producers sometimes are delaying their build-up of the factories. So we want to take that away by creating additional demand by people paying more for their flight. We are not live yet. We will be live very soon. So I also want to encourage you guys, if you want to be one of the first testers of the platform, please give me your business card. You'll get an invitation or send me an email. So we are really encouraging people to start using our platform. We'll be live very soon. But we need testers for the platform. So if you want to, after this session, please let me know and I will invite you to be one of the first users for it. That was it. Thank you. And if you have questions, please let me know. Yeah.
Thank you. So just in terms of how this translates in practice on the SAF you have on the flight, I mean, obviously there will be on the same flight people that will purchase it with a SAF component and people that won't. So do you see it more from sort of a mass balancing basis where the companies will start to have more overall money for consumption of SAF in their flights? Or are you trying to create a situation where there's direct incentive for that specific flight to have a percentage of SAF blended?
Yeah, so right now we will work with a book and claim mechanism. So when you book your flight, we calculate how much fuel you actually need for that flight, and then we purchase the amount of SAF. So it will not end up directly on your flight, but we use indeed the book and claim or mass balance to make sure that the equivalent of SAF we supply to an airport. However, that's where we start. If volumes grow and airlines are directly interested to work with us together, then we can work more specifically with airlines.
Thank you.
I've got a question. Thanks, Nicholas. So when it comes to the process, so you are a SAF aggregator essentially. So yeah. And then how do you become an intermediary when it comes to, do you aggregate all of the SAF, wait some time and then purchase, or how does your sort of payment process work, if you can?
Yeah, so we aim to deliver the SAF as close as possible to after your flight, right? Because we don't want to wait a year, half a year for people then to receive their certificate. So for the first pilot, we actually looking to procure a small batch of SAF, and then so as soon you did your flight, you get the certificate. However, when volumes grow, we can constantly, every month, we can buy SAF and get SAF delivered. So
yeah, there's different approaches.
Yeah.
But
we want to make sure that it's relatively close to your travel, so it becomes more tangible for people.
Yeah. What does Choose do? Do you know?
I think they do what their partners do. So I think it depends on all their partners.
Okay. Thank you.
I had also a question. What's your business model? Because I mean, by mandate, we have to blend anyway, starting from this year, and in 2050 we will have 70%. So, I mean,
yeah, but for the next years, 2% is far away from 100%, exactly. And then 6% is also still far away from 100%, and yet to be seen where we get. And also, when new technologies come available, like hydrogen and battery electric. Probably they will be more expensive than the current technologies, right? So also there will be a need to rank them differently than only compared to fossil.
But better book, so the lifetime is 25 years. So from now to 2050.
No, I don't think we will get there soon. And also maybe by then we act globally, so outside the European Union as well.
Okay, thanks.
Yeah, thanks a lot. For the presentation, question regarding where are you buying the SAF? First question, and the second question, how can I be sure that my money is not used for other purpose?
Yeah, so to start, we plan to work with fuel suppliers. Maybe when we get bigger, we can also work directly with airlines. But we will use we are exploring one of the existing registries to use. So you as a consumer, right, you can see where the additional SAF you buy is going to be uplifted. So we want to make sure that your booking code, or you get a specific code, you can look up the registry and you can see which part of the SAF has been delivered, where, which fuel producer, which airline, and that you have the right to claim that scope 3. And thank you. And if you want to become a tester, let me know after.
So thank you so much. For the last session of this day, we will have a panel discussion. The panel discussion about pathways to 2050. And the moderator will be Sarah Wilking. And the Sarah, floor is yours.
Yes. Thank you, everybody. So we are going to discuss scalability and urgency. There's a few questions here that have been raised, but as we have discussed kind of the first point quite a lot, we thought we would jump straight into the topic of adoption, mass adoption, and how to overcome some of those blockers, because we've spent some time together and realised actually there are solutions, and the group here are really bringing different aspects, so we want to bring that out. And so so it was helpful to have Nicholas present his SAF aggregator business model, and also Geraldine is going to discuss Atoba, because there are all these, like Nesta said, there is supply. Therefore, we've already got kind of the proposition of how do we ensure that supply is taken. We need to increase demand. So actually there are now business models coming online which can help to uptake demand at corporate, individual, event level. So Geraldine, would you like to talk about Atoba and let us know your solution?
Sure. Thank you, Sarah. Good afternoon, and sorry for being the last presentation. I think you might be all exhausted now, but happy to present what we do. Actually, we are new on the market. Atoba has been created in August 24, so we are a startup. The objective of Atoba is to answer to the financial dilemma in between producers and off-takers of SAF in order to be able to scale up the SAF market and to be able to reach the decarbonization in aviation. So what we see, actually, we see producers today with a target to reach FID, and reaching FID meaning we have talked about that for 2 days already, and a lot before even. They need security in order to have a bankable project, so they need offtake. With Atoba, so we are answering to this need by taking some offtakes of the projects, the best-in-class projects, actually. We are technology agnostic, but are obviously oriented with the futures, and especially second and third generation of SAF. So with the idea to aggregate the supply on one side, and on the off-taker side, we do the same thing. Actually, we talk to airlines or obligated parties, such as supplier, who also have their obligations. We do aggregate the demand with aggregating the supply. We link both, and we sell actually to off-takers on an index price, which is not available on the market today, but we are working with counterparties to do that right now. The idea would be to have a price which will reflect the market trends in order for an off-taker, an airline, to not lock with only one producer or two, according to their needs, at a fixed price, but mostly to have a index price based on the market trends. So this is a bit new.
And have you do you have a methodology for is it all kind of, you have a methodology? Is it a digital platform?
It's not. For now, we don't have a methodology. We talk to producers. Actually, we also are here to help. We have the possibility to compare projects, maybe also to support producers sometimes. But we don't have a platform itself. It's not yet. I think it's a bit too early, maybe.
Yeah, I think there's a few different groups, and there's a few different approaches, and there is, of course, new approaches. But actually, what I think there can be a misconception that the industry is so advanced on demand, but actually the approaches are still things that, well, I'll just explain one and then I'll introduce Enzo and Cyril. But one of the approaches that I've heard about is, and I've supported Norwegian Airline and Norwegian Armed Forces, is a contractual approach over 4 years. So like you said, it's actually bringing groups together. It's bringing demand and supply into an approach, and it is almost a manual approach. It's legal, but it is a mechanism, and that's what we are needing to do. And it can be classed as a SAF aggregator as well, because if you have more than one of these, you're bringing that demand together. And I think there's sort of people think we sometimes do need to be at another level, but you still need to be very in the conversations and understanding and introducing groups that want to do it. So I think it's now just at this stage starting to get to the place where we need solutions such as these, and we can then make that market. But it will, it can switch into a product, and it can do that at the right time.
Definitely it can. And another thing maybe to enhance also what we are doing, we are part of Sky Power, for example. We talked about that, and thanks for the good presentations before. Helping scale up in terms of production by taking some actions with producers, and even sometimes we have the willingness also to invest in some projects. Actually, it helps to. I mean, we are pushing and helping in terms of regulation and policymakers, etc., with this kind of business model, which is a bit new, I think, in the market.
You want to add, Cyril?
Yeah, from a producer perspective, we are very supportive to such an initiative. Aggregation is good because it can solve the issue on both parts. Because it's difficult to align the interest of producers that for the bankability of the project need long-term offtake agreements, and on the other side, the airlines, they are not really ready to commit over 5 years. Even in that case, they could commit to 5 years. And the aggregation is very similar to what has happened in the electricity sector, in the renewable power sector, by proposing a bunch of sources to a final user, power-intensive company, enabling to meet the requirements. So that's why we are very supportive to that. But if we think about the 2050 goals and the way to meet the target, I think we have mandates, and the mandates whether will require a much bigger volumes than what we see what is possible to produce by 2030 or even by 2040. Or a decrease in the consumption, in the volumes, then you easily reach the target. But I don't mean to reduce the flights, but to increase maybe the efficiency of the airplanes. Then you decrease the consumption of each airplanes. And I'm not saying that as a wishful thinking, but it's typically part of the French roadmap. For decarbonization of the aviation by 2050. They say that 50% of the goal will be achieved with SAF, okay? But 40% of the goal shall be reached with better efficiency and lower engine consumptions and so on. So this is putting pressure also on the equipment suppliers to the airlines, and the rest is achieved by increasing the ticket price. So that's also a way to meet the requirements.
It is a way. Whether we get that, we'll see about that one. Because of course, there are, of course, as we're discussing, as Nicholas discussed, as KLM does, there are obviously various approaches at the booking engine. And maybe for individuals it is a harder, I think Ryanair said 1% was taking that up at this stage. So we've always kind of in our work at Fly Green Alliance, it's always been, and I presume with your work at October, it's business level that are probably good because you've got the ESG and net zero targets. It's already a business case. With an individual is still, it's double lug ticket is not going to happen. But yeah, anyway, there's various challenges and ways to approach it. So Enzo, you have a really interesting kind of a way to handle the moving forward of SAF projects as well, because I think what we discussed over lunch actually is, and we discussed that there is a gap in technical knowledge, but as well as getting to FID. So what does your company do?
Yeah. Thank you very much, Sarah. So basically, at the end, I believe this really what you say, Geraldine, it goes into the direction of having this scalability done, because at the end, scalability means that to make it available for more players in the market, no? So at the end, we have seen that the deployment for such projects so far, and at least in the recent years, it was belonging only to the big major oil and gas players that were converting their refineries, their assets into something green. But at the end, if we really want to scale up something, which does not mean that we need to build giga plants, but it means that we need to make it available for more players. And we are actually going into that direction with our technology, because we are making small plants, so small for all, no? Because it's small facilities that can be handled by industrial player like biodiesel producer, animal fat renderers, UCO collectors. And at the end, I really believe that to make these projects flying, you need to put together different stakeholders, so investors, off-takers, feedstock owners, but also EPC contractors and technology providers. So we, let's say, from our perspective, we are putting those two things together, because we are both EPC contractor, but also technology provider. So from one perspective, at least from the technology side and engineering side, we are able to provide a comprehensive package to this kind of projects. But that's still not enough. We know that. And for that reason, I was discussing with Sarah during lunch. We also, as a group, as a MIVER group, created this new, let's say, business line, or it's more a supportive line for project development. We experienced that these projects typically were not going to fly alone. So basically, we are providing also this kind of support, so capital structuring, but also finding partners for off-taking feedstock. So we really need to increase the percentage of projects that today are dying at early stages of development.
Yeah, I think this is a really good point, because also we discussed as well the groups that are open and willing and starting to put SAF projects together towards FID are the ones that are already working in methanol, biodiesel, because they've already got the decades of engineering experience, project development experience. And that you said with NextChem, it also became as a natural next step.
So, that's correct. There is a lot of expertise down there, I mean, outside, for those kind of players that have been involved in the biofuel industry since the very beginning, but at the end that today they are not able to make this step forward to the next level, because there looks like there is a barrier, for them in terms of capital, of complexity, because all these technologies that are now on the market playing a role on the low carbon fuels are, let's say, a bit, or they look like more complicated. So we need to really make something to allow these people to jump in. So one entrepreneur or a small, medium-sized company to jump into this.
Yeah, because I think in SAF, you sort of need those that are willing to have the spirit to do it almost, and the sort of energy behind it. But then you need to bring in your decades of, so the groups that are doing this successfully are now, of course, getting their decades of engineering experience plus the entrepreneurial spirit, because you sort of, in SAF, it can be a wild card still. So you kind of, you have to have that, I think it's the combination that is pushing it forward. And then, of course, so I've been speaking to Wastefront in the UK, and they seem to have this excellent combo now, and now there's SAF mandates, and there's already kind of, they've sold certain products that are not SAF, but they've got their, and I think that's what you were saying. Is this your approach Cyril, or not? I might be veering off a bit too far.
Kind of.
Kind
Kind of.
Maybe I won't get to it. But and anyway, speaking on kind of technical, what I also find from speaking to different investors is that, again, they're not used to, they don't know about SAF. It's too far away from their knowledge base. I still think that what we're finding, there's still a lot of information missing, gaps. So it can be group, there is information needs to be spread, shared, workshopping, smaller groups actually. So working groups, we're going to put a group together in summer with investors in London. So I think it's spending time and getting people really up to scratch so they feel confident they've at least got people to speak. They know how to speak to. They've got a group to come back with, people that can facilitate.
Yeah, I fully agree to that, because we need to increase the understanding of many stakeholders, in particular in the financing area, that are quite reluctant to jump in such complex projects, and they focus on maybe the lower hanging fruits. But if we do not make them acknowledge that this is where to invest, it is delaying everything, and then putting us much more away from reaching any goal that we have in the roadmap.
Yeah, because I think also groups with a portfolio approach, which of course Nesta has done. They had a portfolio approach. They already had profitable business. They're not purely a startup. So because all of the startups are, then of course when delays happen, they've got wages bills to pay and they are getting stuck. And that's when they.
Yeah. Maybe 3 years ago, it was much more easy to raise money for development expenditures. Today, it's the opposite. Financiers, they want to deploy CapEx, but not to take money at risk into DevEx. So the problem in this industry, or this industry, is to reach the first FIDs. Because once you have reached 1 or 2 FIDs, it's a different business, because someone has demonstrated that it can be done. So that's why but it's true for all the e-fuels, not only for SAF, but it's really the pain point today. So we need to have one large scale project reaching FID, and then it will ease and relax people.
Yeah, I think the ones that are seeming to do it is spinning out of a bigger company, or rather than stand alone, because they need some profit to be paying them. But this is what I also interviewed Nuclear, which I know NextChem have got some agreements with. Nuclear were an SMR developer, and they've raised 500 million already. So that's like amazing for SMRs. And they, of course, could anything, like I was saying in my presentation, it's kind of, they can supply the base load, as you were saying, to other projects, and then they can, it's all kind of co-investing, they've got end goals where you're also speaking to similar financial groups. Some banks are willing to invest in SMRs. They're actually not willing to invest in SAF. So it's kind of thinking of smart ways around the blockers.
Yeah, that's actually what we believe. I mean, as an XCAM, and that goes more into the let's say long-term deployment for sustainable aviation fuel. No, at the end, for any low-carbon fuel that is synthetic, so from captured CO2 and hydrogen, really the key element becomes the energy supply and the costs of energy. So at the end. Cost of energy, yes, on the renewable side, it has good margin to be improved, but at the end, it takes time, and it has a lot of uncertainty behind that. So nuclear from SMR is one of that solutions, in our opinion. So basically, we are working on that, and as a technology company, we need to get ready before anything goes to the next level, right? Because at the end, when it goes to the next level, we need to be ready to provide that kind of solutions to our customers. So yes, to reply to your question, and that's a way to do that.
And not just solutions, it's the stable offtake cost that renewables, for example, doesn't often give. And that demand is, well, as I explained in my presentation. So anything that can make
stable and reliable.
stability is less risk for an investor.
If we look at the timeline of deployment to reach the 2050 goals, we all should understand that it is happening now. We have to solve the main issues now and to deploy, because if we speak about SMRs, it will take maybe 8 to 10 years to have SMRs in operation. So we cannot wait some more years to take decisions. It has to go fast now.
Yeah, plan to now. So the UK Export Finance Group came to speak to me today about SMR. So it's interesting that certain groups are now infrastructure groups, or they said that it can actually give 100% guarantees to banks. So that very useful. So it is about getting more. It's quite interesting that even some parts of the UK government hadn't been aware of SAF. Some groups are just getting their knowledge base going. So like the blockers are getting unblocked, and then of course the demand side blockers. It's basically the supply, and in the report I keep talking about, it is really about supply and demand. But of course the mandates are creating supply, but it also doesn't come without work. I speak to some of the major fuel producers. They are nose to the grind, so basically getting those mandates fulfilled. So it is a lot of work even to get to 2%. So the next one, it's just so many more people. And if you think about, if you look at the numbers when new tech has come online, you can look at how many people were involved with that, how much investment, and actually it just hasn't got to that stage with SAF. There aren't enough people and there isn't enough money invested in it yet. But that's why, of course, all the conferences are coming, all the groups are existing, the new business models. So it's just literally gathering that, the numbers. And then it starts pushing away. Cyril, you have some thought?
No, I have a question on the demand side. Maybe for Geraldine before we open for questions. How do you see the willingness of airlines to commit to such an aggregation scheme?
It's a tough question, indeed, but they need today. If you take an example of I won't name one, but you can imagine a big self-supply company, European SAF company. Today, a self-supply company will be an obligated party, actually. So those big airlines will have to comply anyway, but they need, if they want to comply with regulation and to reach the 6% mandate, 2% mandate today, they have, if they commit on a long-term basis without like a price which will follow the market. If they go today with one supplier, actually one supplier will not be enough, so they will have to go to at least 8 suppliers. So imagine the negotiations behind and the possibility of price discrepancies, and so that's where the aggregation makes sense, because we can do that aggregation for this kind of obligated parties. So that's when you're coming back to your question. Yes, there is really traction from airlines, while committing on 10 years contract is difficult always. So it will not be a contract done in a month or two. It can take a year to develop this kind of offtake agreements, but it gives stability. But
I've got some comments on that because we are an aggregator as well, basically. I'll come to it. But basically, any fuel supplier or airline is open to aggregators because it helps them meet their Scope 1 target. The only thing they are constrained with their own internal resources and the budgets put to this, and the fact that there are more aggregators coming. So they have to be mindful of not basically, they want to sort of align it. But as long as you can sort of be agnostically working with, then it's they just say, no, we can't work with 10 people, it's too much. So it's about also being smart about how you align, you know, like the book and claim, we're trying to common denominators, make it easy for everyone to do their own part. Basically, there's so much work to do. There could be 100 aggregators, but as long as there's commonality.
Yeah, but just to make it a bit clearer, maybe also when we talk about aggregation, it will be by SAF generation. We are not going to aggregate tomorrow SAF with HEFA or whatever. It will be really step by step, and it's following the market evolution, technologies, production coming on stream, etc. Yeah, and then the pricing will follow up accordingly.
Yeah, you would like.
Yeah, thanks a lot for interesting discussion and interesting initiative. Quick question. First question: is Atoba Energy the counterparty in this aggregation? So are you the counterpart to the offtake and then supply to the airlines, or is it just in between?
Atoba is a middleman, so in between, but taking title and then selling. So
but the contract is with you. The
yeah.
contract is with you.
Yeah, the contract is with us.
Okay.
And then we are supplying, so buying, and
selling again, and then we have another contract.
Yeah.
Okay, but how do you handle the counterparty risk? I mean, it's enormous amount of money, and you have a huge counterparty risk. And are you able to handle this?
Yeah, there is a fund behind, but indeed, but it's a back-to-back transaction also. So we first start with aggregating the demand.
Yeah.
So we need the demand, and then as soon as we have the demand, we can work on the supply side, and then up.
Yeah, sure, but still you have some days of counterparty risk. Yeah, yeah.
Indeed.
And regarding the term structure, I mean, the terms are the same, so the duration of the offtake and supply, or how, to which extent is this term structure problem solved? That on the one hand, the off-takers want to have 10 years and the buyers only a few years.
It will start the same, but as soon as we are growing our portfolio of production, you know, of supply and demand on the other side, it will grow. So the terms could vary. But the first project locked, then it will be a back-to-back transaction somehow. But as soon as we grow, then we will have potentially different terms.
Okay. And last question, you said it's indexed.
Yes.
So to which extent then you can have a revenue certainty? I mean, index means that the price is varying, and how does it solve the problem of having fixed prices in the long term?
Depending on which side are you talking about, the off-taker side?
Both sides.
Both sides. So we are supplying with our conditions. On the other side, we are reselling at an index price. So this one, it gives stability to it will be production cost based. So it gives stability to the off-taker.
So off-taker gets a fixed price and...
Not a fixed price. It's an index price following the trends of the market. We know that we all hope that because, you know, next generation of SAF will be based mostly on production cost more than, you know, which is today the opposite with HEFA. We saw Plat's presentation with 74% on feedstock, which is highly volatile. So tomorrow production cost will be more stable, and the trends are that with maturation of the industry and scale, etc., the price will go down.
Yeah, but I always heard banks,
the trend of the market.
The banks want to have a fixed price, otherwise they cannot do a calculation of the bankability, of the profitability of the project.
You want to?
May I just to jump in? On the production side, the price are rather stable because they are fixed by the penalty and the multipliers. So it's rather stable. I understand that the index is not a very fast fluctuating number, at least at the beginning or the first years, but it's just a trend to demonstrate that according to the increase of the volume and the offtake, it will decrease. That's why I understand. So the airlines, they would buy the fact that they will see a decrease of the costs over the time. That's more on the offtake side. But on the production side, obviously, the banks will require more fixed price, and they need to see how they can understand the market price for the SAF.
Well, the banks just want to know they're actually going to get paid back a certain amount. The actual SAF price could go all over, but as long as you've got a credit-worthy person literally going to pay you back, that's all they want to know to give you debt finance. So if it goes like that, that's what I'm imagining. You take that risk, that as an intermediary, and like was mentioned in the Sky Power, it's having this credit-worthy intermediary that it has the credit, because airlines have very poor credit actually. So that's why they never get credit from the banks, basically.
Yeah, that's what I said in my presentation. We have a trader in between because you need someone with a strong balance sheet somewhere.
So it's all evolving. It's very interesting. It's very current. It's changing in the right direction. The mechanisms are coming, and so mass adoption is starting. But of course, as everybody said today, it needs more education, more rollout, more business models and solutions. The airports definitely should be involved. So yeah, if anyone got any more questions, or if all good, if anyone's got any final comments you want to takeaways?
I think we still have the requirement for advocacy, but the advocacy must be followed by actions now.
I think there is, the advocacy, yes, definitely. But let's be quite positive. I think the market is finally evolving quite quick. I started in SAF in 2020 with, it was, by that time, it was so tiny volumes, etc. And you see that even people start to be so much well educated, if I'm more educated on the market, and policymakers so much involved. I think there is a lot of hope. I was in a conference in Brussels. We talked about the Sky Power project just before, and we even see that it was quite interesting to see that we are already talking about BSAF, eSAF. It's already, it's going so fast. So I think there is a lot of hope. Now we need more support.
Yeah, I'm pretty much on your side, Geraldine. I mean, the beautiful part of this product is the fact that it makes everybody happy, and anybody agrees on the fact that there are no alternatives to sustainable aviation fuel. So that's a huge starting point, because if you look at other biofuels in the past, they've had some issues in the deployment, the blending walls, the food versus feed, so all matters that were against the electrification, were against the deployment. For sustainable aviation fuel, this is not happening, and which is already a good starting point. Then yes, I agree also with Cyril. The advocacy needs to make to talk the walk, how to say, no? So walk the talk. So at the end, a support is needed. That is clear. But in my opinion, it's happening. So it's happening now, and in 5 years we have already seen so many actions.
Yeah, and I've been asked to make the closing words today. No, just stay. So well, I will. Yeah, I think it's been the last couple of days have been really interesting for me. I think personally, I have been at various conferences, so I haven't been to a SAF conference for a while. So actually, it was very good to see the updates and progress. Of course, now the mandates are coming, policy is there. So there's as I said, our grant for Bookie.com was 2018, so it's been quite a magical mystery tour, but the mechanisms, CSRD is on its way, as was mentioned today. The GHG protocol has a technical committee which is developing the rules around Scope 3. Scope 3 basically makes demand. Science-based targets has around 6,200 members at the moment. So everything in net zero is growing, the demand is growing, which is making the market for SAF. So the signals are there, as I presented, even if there is some political uncertainty in the US and other, we're going through political phases, and we're always going to be in SAF. It is non-fossil, and we do need fossils. So it's having these hybrid systems in so much work with groups, because they're going to be ones that also produce it. It's you of course have to have a quite philosophical approach when you're working in net zero, but I think we can see the technical aspects are really there now. So it was also really nice to have a group where everybody got time to spend and meet each other. It was a good size conference, and people have said they really liked it. So thank you to the producers of the conference, and thank you to all the people left in the room. It was really nice to meet you all, and thank you to the panel members too.
Thank you.
Thank you.
Thank you.
Last words from me, ladies and gentlemen. On behalf of Litvan Group, I would like to thank all the speakers for their commitment and interesting presentations. I would like to also thank all the participants for coming and joining our discussion, and all the people who join us online. But last but not least, I would like to thank our two chairmen, Bas and Christine, for their guidance and valuable input through our conference. We are looking forward to receiving your feedback on the event through evaluation forms, so please fill them out and hand it to me or my colleagues. You can write us email or just give us a call. It was a great pleasure to be here with you. We are looking forward to see you on another Litvan Group, and thank you so much, and safe travels to home. Thank you.